in warm welcome to the all delegates, technocrat, and eminent manufacturer suppliers present here for the technology provider session. So, in this session, there is a reflection of various technology in the field of sugar engineering, process, alcohol, ethanol production related to the juice extraction, power reduction, raw sugar, sulfurless sugar, fermentation, and distillation efficiency. So, with the permission of Honorable Chairman, we start the session. So, in this session, the 14th renowned machinery manufacturers suppliers to deliver their technology with the design concept, new equipment related to the sugar and its byproduct. So, I request to first Entris India Private Limited to deliver to start with presentation.
So welcome all of you. Welcome to Enrich Pumps Private Limited. Entries.
So Interis started more than 30 years ago in 1989 and went to very quickly different countries such as Poland and Pakistan, where Interis is very well known for the ENA production, and a little bit later on in Thailand, where most of the production of the bioethanol has been designed by Interis. So Interis India came in 2023, which office is based in Pune. And the aim of Interis India is to provide turnkey projects in the ethanol industry for India and in India. Interis India does belong to Interis France, with a workforce and helped by Desmet Engineering and Contractors, which is providing us helpful solutions to any project we need. So as I said, Interis India is based in Pune, where the CEOs of Interis and Desmet went for the inauguration in a year ago. And so our main business line will come from bioethanol plants based on first generation and to construction EPC. I will go as well for the commissioning activities and later on for the after sale services. So with Interis, you will go with reliability and stability of your plant. So as very well known and as we all know, we will provide different technologies and solutions in the ethanol industry, starting with liquefaction and fermentation, when all the key parameters have been carefully studied, which is coming after the distillation, where the integration of the energy coupling is helping us lowering the steam consumption and being one of the lowest in the market. The rectification process allows us to provide one of the best quality alcohol we're having in the market, especially with the hydro selection technology, where Interis is one of the only mastering. The dehydration where we spoke of, and the evaporation and drying technology with forced circulation, allowing us to having and decreasing the scaling of the unit, allowing our client to use it bioethanol with 230 KLPD as an example, and in Argentina with 200 KLPD of ethanol. So thank you very much for your attention. And if you wish to contact us, you have the details here.
So, any question? So, Pierre, I want you to just highlight some of the work you are doing with the VSI and on the 2G ethanol.
Sure. So with VSI, we have a partnership and some studies going on, highlighting and working on the molasses storage, where we all know that the molasses could be stored for a longer time. And with VSI, we're aiming to find some solution for our clients to store this product during the off season, allowing the clients and the industry to work for a longer time during the year. So we hope all these results will be successful with VSI, and hoping to provide our clients very soon a new solution to store this molasses. Sorry.
Yeah, let me. Is it again? No, no, no. Fourth, last. Is here, no? Very good morning to all. Myself, Ramesh Kumar from CRI Pumps Private Limited, Coimbatore. Yeah, we are very proud to be here in VSI third international conference, uh, part of VSI family. And on behalf of my management, I would like to thank complete VSI management and VSI team for the excellent arrangement and for the opportunity given to CRI. CRI basically Tamil Nadu based company which is located in Coimbatore, having manufacturing facilities of 16 factories at Coimbatore and 12 subsidiaries units in overseas. We started in 1961 at Coimbatore as a small company in foot valve. We have entered into the market, and now till 2023 we are having the turnover of 2,600 crore. As far as the pump is concerned, we are the leading turnover in pump industry in India. Back in 2011, we understand that when the moment is getting changed, shifting from water to liquid, there is a vast potential across the globe. So then we thought of since we have all the technology with us in pumping solution, we thought of designing the pumps for the industrial application. But when we go for the own designing and all, it takes few years. Yes, that project also we have taken in 2010. And in parallel way, in global, is there anyone good brand with the good technology, with the good product, with good process pump? If we able to acquire the company, so that can be shortest solution can come into the market. So we have got a good acquisition from UK Italian based Scotland based company called Tough Pumps, who were well known brand in UK, who were manufacturing presence being a Indian manufacturer. Well, when we are going overseas market, there are multiple standards you have to follow. Multiple norms are there. Yes, those norms are complied by CRI, and more than 40 in 2,600 crore turnover, more than 40% we are catering from the export market. So our presence is there more than 120 countries. And these are the Indian footprints. We have 31 sales branches across India, and our backbone would be, I would say, proudly service. Every 200-kilometer radius, service in the sense I'm talking about the industrial pumping division. So we have service centers, company authorized service center every 200-kilometer radius, and we are having the track record. The downtime, it won't go beyond 24 hours in industrial segment. We have track record. And these are authorized service center where it is there, as I said, every 200 kilometer we are having across India. And addition, our strength would be our own R&D. We have R&D facility at Coimbatore having 120 plus our own engineers, and we are authorized by, we are recognized
awards.
Plant where most of the hydrogen fuel manufacturers are from US based companies are there. We are accommodating their technology, we are accommodating their norms, and we are our major one of the particular product, it is going into the green fuel where hydrogen plants are being manufactured. And this is what I spoke about, the product which we acquired from UK based company Tough. This is excellent product we are having, and proven product for the distillery industry. Start from fermentation, distillation, evaporation, and for the MSDI section and cooling tower, cogeneration for boiler, we have complete range. If we talk about particularly this product, this is known as a N-section chemical centrifugal pump. These are centrifugal pumps are there, and which complies ANSI standard. We are not into we are having ISO standard also, but ISO, you know, well, it's a conventional way of method which was being used for the water application with cast iron construction, which for our convenient it has been converted to stainless, based on the MOC, based on the liquid stainless steel SS304
Yes,
316
please.
316.
Last 1 minute.
Yeah, yes, sir.
1 minute.
Yeah.
Just
Sorry?
conclude.
Okay, only 1 minute is there. Oh, fine. Yeah, I'll give some features of this, where we can go up to 46 bar pressure of delivery. And again, this is mixer where in compressed biogas plant in digester it is being used. We have the technology in Indian pump industry. We are only having this technology who's manufacturing in India. We have CFD analysis also for this product. This is aerator for biological tank aeration purpose. And firefighting. And split case, we have up to 15,000 meter cube per hour. And vertical turbine pump, we have up to 35,000 meter cube per hour. These are few installation. And certifications. And awards. Any questions, sir?
No questions.
Yeah.
So next technology provider is Sovereign Equipment Limited.
Thank you,
Please.
sir.
Thank you
Yeah.
for good presentation.
Yeah, thank you.
Yes, sir. Hello, good morning.
Distinguished guests and fellow delegates, thank you for coming over here. I'll just start with the introduction. We started in 98 as a Suviron Equipments Private Limited in Ahmednagar. We are based in Ahmednagar. This is our workshop. We are into specialized equipments like solid liquid separation. We are into rotary juice screen for cold juice in 2 stages. We have a patent for that. For hot raw juice screening also, and we are into mild screening. Then we are into Suviron. We have our own design of Suviron low retention time clarifier. Then filtrate clarification system, syrup clarification system, melt clarification system, then desweetening process, dip bed filters, and we are into also turnkey sulfur-free sugar production. This is our key product. We started this in 98 rotary juice screen, and very modestly, every second sugar factory in India, we have our rotary screen. We have around more than 800 installations worldwide and in India also. We are exporting to many countries like USA, Philippines, Vietnam, Zambia, Rwanda, Iran, Ethiopia, Kenya, Uganda, Guyana. This is a PID. We have an this is a rotary juice screen. Here there is an inlet. We have a caustic soda header for cleaning the screen. We have a wash water header. There is a pump which there is a auto wash water timer is given over there. This is a small photo. You can see the feed box. Wash water header is on the right side. Then the drive assembly. We give a planetary gearbox. It's a chain driven one. Guide roller. It rotates on 4 rollers and 2 on the thrust. This is a front view. You can see the feed distributor which minimizes the velocity, and the thrust roller or the bottom. This is a specially wedge wire screen which we manufacture. It's our own manufacturing setup in Ahmednagar. You can see some wedge bars, and there is a V-groove bar. If you see the close-up, we weld it over there, so the strength of the screen or the life we get, it is more or better than others. We have also given, this is a closed rotary screen we have given for melt. This would be beneficial for the port-based refineries. Then we have a mixed juice screening for 2 stages. These days what has happened, because of the fiber or which is a 0.5 mm screen, it cannot handle more fiber because it is a fine fiber. Long thread preparation has gone up. Earlier, if you see the records or the data which we have collected from 2000, we started in 98. So from 2000 2004, the fiber in that is a dry fiber which we get, that was around 1.35 to 1.5, and 2010 to 17 it has come down, or it is almost 2.20. So because of the fine preparation, we could not arrest the fiber in 0.5. So we have used another screen. It is a gravity flow 0.35. But coarse separation is also required, so the first stage screening is also required. This is a photo which you can see at the top. That is a 0.5 opening screen, and the below is a 0.351. It's a gravity. The flow is by gravity. There is no pumping required. This is a front view. Again the PID, somewhat same. And we have number of data we have collected in number of factories. This is a screen for hot raw juice screening. This is a new equipment we designed around 2015. Here on this platform, I should thank Sonira Sugars, because we jointly did it around 2015. We got a patent for that. Here in first stage screen raw juice, you can see 1800. It comes from 1200 to unscreened raw juice comes around 1200 ppm, 12,000 ppm. Then 1800 ppm. Second stage screening in J1 Sugars, we have given a second stage screening that comes around 900 ppm. So the fiber has come down, and from 1.20% to 0.05%. That is around 95% removal of fiber. It is a closed one, and here what has happened, because of the temperature, we could separate the fiber from the screen. It is a 0.18 screen, so the area is more. It's by gravity. Here juice sulfide is there or a defecator. You can see from the up there is an inlet, again there is an outlet. We have given number of valves, so we can bypass the system. There is again wash water header, caustic soda header is there. There are slurry pumps. We can leave it on the mills or we can take it to the mud tank. This is a photo of it, the installation one. This was the first installation, Sonhira. You can see before screening it was 0.155, after screening 0.018. This is all on dry basis. Here we could also achieve the color reduction of 1500. These are the multiple advantages. From 1500 to 2000 IU we get the color reduction. Then reduction of clear juice turbidity, improvement in transmittance, additional separation of 0.15 to 0.165% cane of dry fiber, lowest fiber in screen hot raw juice, that is around 500 ppm. The white sugar produced was always tested negative in all the installations by the Acumensa method. There are multiple advantages for this. Reduce solid and color loading on subsequent process of juice, syrup and milk clarification. No fiber contamination of sugar crystals. Other mechanical advantages like pump, tubes, pH is eliminated. Increase in capacity of existing clarifier. We found some small capacity increase of clarifier. And moreover, most important, improvement in sugar color around 10 to 15 IU in normal condition. These are numbers of screen from on the mills. We have 2.5 and 0.35, and again on the process house we have 0.18 screen. So this is a diagram of given over here. We have our own clarifier, so retention time, then suspended particles, sucrose invasion losses, temperature drop is around 2 to 3 degree. Turbidity of clear juice is 5 to 10 IU in sulfitation plant and 15 to 20 IU for defecation plant. It's a simple in maintenance. Only mud outlet wall is there. It is the only wall required for regular operation. Then we need a polymer for settling. It has wide range of applications. We have given it for secondary juice, primary juice separately, sweet sorghum, beet juice, and foundation. We can use the existing foundation on the, or we can use on we can have a civil structure, a new civil structure or a staging structure in mild steel. You can see a flash tank. We have a magnetic flow meter, so proportional polymer is added. This is photo installation one. Then on the left side you can see decanters which we had installed, and the right side our clarifier. That is a clear juice.
Yes, please conclude.
Yes, I'll conclude, sir. I'll finish it. Then syrup milk clarification system. This is a PID. Installation photo. Then we have also done raw sugar melting, screening and clarification for sulfur free production. These are the number of advantages. Finally, we express our sincere thanks to Vasantdada Sugar Institute for giving us an opportunity for this presentation. I request distinguished delegates to visit our stall number GS7 in Trade Area 1. Thank you.
Thank you, sir.
Next technology provider is Thermax Limited. Please.
हॅलो नमस्कार. VSI टीमचे मी आभार मानतो हे व्यासपीठ देण्याकरता आणि सर्व सकाळी आलेल्या आपल्या डेलिगेट्सचे जे सकाळी सकाळी इकडे हजर आहेत टेक्निकल प्रेझेंटेशन ऐकण्याकरता. Since many of our delegates are from across the world or from India, I'll keep my presentation in English. So good morning to all. I am Ganesh Daivadkar. I am from Thermax Limited. I head the growth unit for biogas upgradation or the gas purification segment of Thermax. So I'll start. So Thermax as a company in India, I think doesn't need any introduction. So I'll keep my introduction about my company very crisp, and I'll be very specific on the technology slide. So conserving resources, preserving the future. So this is the tagline of Thermax, and we are implementing it since its inception. Thermax started in 1966 as an energy company, and we are going strong as an energy company. In spite of that, we diversified into environment segment as early as 1980. So Thermax, I guess, is the only company in the world which is into energy and environment segment. Now coming to our today's topic. So Thermax, what brings Thermax over here in sugar segment? In sugar, Thermax is definitely present as a renowned boiler supplier, spent wash boiler supplier, bagasse boiler supplier, water treatment solutions, chemical supplier. So all the areas of the industry we are catering. But as the world has progressed towards net zero, towards circular economy, we are now into the bio CNG segment. We are also into green hydrogen, but currently I'll address on the bio CNG segment. So Thermax is catering to a complete bio CNG plant, that is a greenfield bio CNG plant. From as a EPC supplier, and also supplying specific purification systems for biogas that is generated from the digesters. So I'll be now today catering discussing on this specific bio CNG purification system. So when we say sugar, it is actually think beyond sugar, think bio CNG and think Thermax, because this is one avenue which will increase the profitability of the sugar segment. So circular economy, that is sugar plant, we have the main product sugar, but the waste that is generated from sugar plant, that is press mud and spent wash. So that can be used as a feedstock or as a substrate for generating bio CNG. Now, why bio CNG is important in today's aspect is because we are currently importing natural gas as a fossil fuel from other countries, whereby our foreign exchange is getting drained off. If we generate this bio CNG or natural gas equivalent to natural gas in India itself, we'll be saving our foreign exchange. So government's aim is today to at least generate 15 million tons of bio CNG in India, thereby we'll be reducing our imports. Now coming to the sector of bio-CNG, this is a schematic diagram. So in this, as most of the sugar plants will be having a digester wherein we treat the spent wash. We can here treat press mud also, and from press mud through anaerobic digester on the top left corner, you can see through anaerobic digester, we can generate the biogas as the product, which can be purified into a bio-CNG and compressed. And the digested that remains, that is the lower portion, you can see it can be used as a manure or a fertilizer in the farm. So that is a circular economy that we'll be gaining from this segment. It's a win-win proposition for the industry, for the farmer, for the government. Now, these are the few government schemes that government is encouraging bio-CNG sector. Predominantly what is happening is people from other segments are putting greenfield bio-CNG plants, taking feedstock from sugar industry like press mud and generating biogas. So our appeal to sugar industry is that you have spent wash, you have press mud. Why can't we put our bio-CNG plants and sell it to the oil marketing companies? So there are various schemes. I'll not touch upon to that. The main scheme I think is Satat scheme. which government introduced in 2018 to promote 5,000 bio-CNG plants. And this bio-CNG will be used as a vehicle fuel. After rolling out of this scheme, the traction for bio-CNG plants has picked up a lot. Players like Reliance, Adani's are into the segment who are putting in the biggest bio-CNG plant in the world. So Adani is putting a biggest bio-CNG plant in Uttar Pradesh. Fortunately, Thermax is part of that project. And we are supplying the equipment for that project. Also, we are catering Reliance in that. So technologies to convert biogas to bio-CNG. So before we go there, we need to understand what is biogas, what are its constituents. So I'll be crisp. I have 5 minutes. I have time, no? So we have biogas which contains CO2 to 30 to 40%, moisture and H2S. So these all technologies cater in removal of these impurities, and only methane remains in the biogas, which is equivalent to a natural gas, and that can be used as a vehicle fuel. So that is a technology. And for doing that, we have many technologies, out of which we have listed 4 of them. That is pressure swing adsorption technology, vacuum pressure swing adsorption technology, water scrubbing, and amine scrubbing. In Europe and in Americas, this technology is prevalent, and they are using membrane technology and pressure swing technology for purifying the biogas to bio-CNG. But in India, because of the capex constraint or because of ignorance of our people on the methane slippage or the methane loss that happens to the atmosphere during recovery, the technology adoption, the uniformity is not there. So I'll touch upon the technologies quickly. So for purification of the biogas to bio-CNG. So this is a pressure swing adsorption technology, predominant in Americas and Europe, because the methane slippage in this technology is hardly 1%. And this is a proven technology in foreign land, and that we have brought here. And same technology we have offered to our reputed players. The purity, of course, so purity with this technology remains 96%. Most of the technology will give purity of 96%. But the methane loss that happens during purifying that or removal of CO2, that is of significance, because methane loss is the product that we lose, and in terms the revenue or the money that we lose. So that we have to limit while maintaining the purity. So this is one technology. So this is the overall, I think, dashboard, but I'll skip this. Second technology is vacuum pressure swing adsorption technology. This is dominant in India. All greenfield projects that are coming in are using this technology. With this technology, also 96% purity is guaranteed, that is methane content of 96%, but recovery of 97%. Unlike the earlier technology which was giving 99%, this is giving 97% recovery, or 3% methane loss, I'll say. So this is the inherent, I'll say, drawback of this this technology, that it will give 3% slippage. Next is high pressure water scrubbing technology, or I'll say water scrubbing technology. So this is a very old technology in India, predominantly used, and many scrubber manufacturers or many distillery manufacturers will be providing this technology. Thermax also does provide this technology. So in this, again, the purity, the methane purity, the top left, 96% can be guaranteed, but consistently giving the recovery or the slip of methane less than 3% is a challenge in this technology. So for this, you need a reputed or engineering company which will design this scrubber system meticulously. So that is the need of the hour. Last is amine technology. Amine is a very proven technology used in refineries basically, and it gives the highest purity and highest recovery amongst all the technologies. But this requires steam, or boiler is required, and sugar industry inherently has a steam. So this can be the technology of future once the norms for the methane slippage become stringent, wherein you require 99% purity, or you limit 1% methane loss from the biogas generation. So uniqueness that Thermax brings, I'll say Thermax has all the technologies we are offering. So we will not be peddling to peddling any one technology and and pushing one technology to a customer. We'll show dispassionately the pros and cons of both all the technologies, and it is up to the customer or up to the user to select the right technology depending on his capex and the opex that he has. So that's all from my side. I'll request my colleague to join me for giving this presentation, continuing this presentation on water. 1 minute. Okay.
So I'll not waste my time since I have got a very limited this thing. So we'll quickly take you through this advanced mechanical vapor recompression technology, primarily for the zero liquid discharge treatment of the wastes. So in this advanced mechanical vapor recompression technology is nothing but wherein the latent heat of the vapors is used to do the evaporation. Unlike we use the steam for the evaporation purpose, so herein the latent heat of the vapors is used for evaporation, and the vapors are sent to a vapor blower wherein the vapors are compressed, and then there is a delta T of 10 degrees which is achieved, which does the evaporation purpose. So the uniqueness of this technology is this discards the use of steam, which is a costly utility nowadays, and the entire evaporation equilibrium is established by virtue of the latent heat of the vapors. So this results into optimized OPEX, wherein the use of steam is done away. So it's only done by the latent heat which is carried by the vapors. Then we also have the multiple effect evaporator, primarily for the waste treatment, wherein what we do is there is a huge volume reduction which is established by evaporation, and in this ME we use steam, wherein if the customers have got steam as a utility and the power is costly, then some of the customers opt for this particular solution, wherein the waste is concentrated and you typically end up with a gunny bag of powder which can be disposed of in a landfill or a central disposing facility. So that's the multiple effect evaporator for the waste treatment. See, I would like to just touch base on this. The beauty of this technology is the customers end up achieving water positivity. In this whole forum, I think many times we talk about water and water as a waste. We call it wastewater. So my request to the whole audience is, let's refrain from calling water as a waste, because water has never been a waste. It was never a waste. It was the most scarce and the most precious resource. So we have to work, this solution helps the customer to achieve water positivity. What is water positivity? Is you achieve, generating the water rather than using it from the natural resources, tapping it down and generating your water requirements on your own. So my colleague Aniket, if you can just in a minute touch base on the CPU. Sir, 1 minute.
you.
Just 1 minute. Just 1 minute. Just fast.
Sorry for that. I'll just take a minute of your time. So what we are coming up with an advanced granulated anaerobic technology. This is for the condensate polishing unit that we have in the distillery segment. So unlike the wastewater treatment plants that we usually take care of, there are many technologies coming up. So Thermax has a unique technology tie-up with a foreign company wherein we bring this unique advanced granulated technology to take care of the condensate polishing unit. This technology has its benefit wherein we reduce the civil footprint of the area, have a higher COD efficiency of that particular system, so that this water can be used again back into the processes, wherein we limit the wastage and the discharge of the water into the ground resources. So basically this is the typical flow of what the system is could be like. Hence in this particular system wherein we have the condensate polishing unit traditionally been done, wherein we don't have higher COD efficiency or higher COD removal in this particular case, but this technology proves that it can reduce the COD up to 90% in the anaerobic digestion system, thereby reducing the load on the aerobic system and the further treatments that are required to use that water back into the process. So that will be all. Thank you very much.
Thank you for good presentation. Next speaker is SS Engineers Limited, Pune.
Just a
SS
request,
Engineers.
any questions, or if anybody
No
would
question,
like
we'll
to-
take the question
so we can take it later, or you
at
can
this
approach the
end
side.
of the session.
Thank you.
Thank you.
respected session chairman, all dignitaries and my dear friends. In in these 10 minutes, I shall tell you about about SS engineers, what we have achieved so far, and what technological innovations we have done in sugar industry. Established in 1980s, SS engineers provides turnkey from concept to commissioning solutions in the field of sugar and ethanol. We are specialized in complete sugar plants, distilleries, complete sugar plants, distilleries, cogeneration plants, and industrial boilers. We have rich experience of 40 plus years, and our services include design, procurement, manufacturing, erection, and commissioning. This 40 is not a mere number. Over the year, we have built more than 40 turnkey plants, 275 cane crushing mills, 100 industrial boilers, 8 diffusers, more than 40 cogeneration plants, 4 distilleries, and 4 distilleries. Now I shall take you through some of the main important parameters. Turnkey plants. The key feature of our turnkey plants are we can provide turnkey plants from 1000 TCD up to 25,000 TCD. We guarantee you minimum power consumption for our plant due to highest crushing for our given size of mills. We assure you 30% steam consumption, 30 to 32% steam consumption by use of falling film evaporators and continuous fans. You get complete expertise, supply and execution from a single source. We provide you optimized design and compact layouts which are suitable for future expansions. So, okay. Now I will show you some of the photographs of the plants which we have installed. This is a Sharayu Agro 6000 TCD plant, 33 megawatt cogeneration. This plant has got a diffuser. Bajaj Hindustan, Asia's largest sugar producers. For them in 2004-2005, we have built up 3 turnkey plants in a single year. Currently, they are crushing above 9000 TCD and they have got 20 megawatt cogeneration. Baban Raoji Shinde, this is also diffuser based plant whose capacity is 5000 TCD and 30 megawatt cogeneration. Siddhanath Sugar 5000 TCD plant, 26 megawatt cogeneration. See, this plant in 2008-2009 we put up of capacity 2500 TCD. After that, all subsequent expansions are carried out by us. Currently, this plant is crushing more than 6000 TCD and their capacity is 26 megawatt. Indian Sugar, again a diffuser plant of 4500 TCD. Kukudi Sugar 5000 TCD, 33 megawatt cogeneration. Rohtak Cooperative in Haryana 3500 TCD, 16 megawatt. Rajaram Bapu 2500 TCD, 20 megawatt. Bhaironath Sugar 2500 TCD. Kancheshwar Sugar 3500 TCD. And this is the entire list of our all plants which we have built 2001 onwards. These numbers are more than 40, highest compared with any other manufacturer after 2001. You will see the capacities are from 1000 TCD up to 10,000 TCD and cogeneration is from 3 megawatt up to 35 megawatt. Our record executions in 2004-2005, almost 20 years back, we have given 3 turnkey plants to Bajaj Hindustan of capacity 6000 TCD. Currently, they are running at 9000 TCD. In 2002-2003, we have built up 5 plants and commissioned in the same year. The names are Kukudi, Rajaram Bapu, Bhoramdev SSK, Mohan Rao Shinde and Shambhu Mahadev. The same feat we achieved in year 2014 and 15. We built again 5 plants and commissioned in a single year. Their names are Baban Raoji Shinde, Balaji Sugar, Baliraja Sugar, Bhaironath Sugar and Kancheshwar. You can see their capacities are from 2500 TCD up to 5000 TCD. The boilers which you have put up over there are from 80 TPH up to 150 TPH and cogenerations are from 15 megawatt up to 30 megawatt. So this underlines our inherent design strength our construction capability, and our execution prowess. Now I shall touch upon the mill, which is an integral part of the sugar industry, wherein cane is crushed and further sugar and other products are prepared. We can design economic and extraordinary mills of any capacity. This is an indigenously designed mill and we have got a patented for it. In 93-94 we got a patent for this mill. The unique composite simple robust design accommodates 3, 4, 5 or 6 rollers on a single monolithic headstock. I shall show you the drawings in just some time. We can provide you milling plants from 18 by 36 size to 55 by 100. We guarantee you more than 20%, 20 to 30% higher crushing for a given size, and I shall show you the results in some time. See, the features of our mills are easy removal of feed roller without touching the pressure feeders. I think you check the other drawings, other designs. There you cannot take out the feed roller without removal of the pressure feeding system. Then we have got very extremely short pressure chute. It reduces the friction and power consumption is less because of that. Because of less pressure chute, we guarantee you the least possible contact angle, which improves the cane feeding, and this is the reason why we always claim that our mill can give you minimum 20% higher crushing for a given size. See, this is a photo of a typical conventional mill. I just want to put one point why we call it as an integral mill, because we have integrated pressure feeding system in the mill. I told you that the same monolithic headstock can accommodate 3, 4, 5 or 6 rollers. For a conventional design, you will see that for pressure feeding arrangement, you will always have to put additional headstocks or fabricated structures to accommodate the additional rollers. But in our case, you will see that on a same headstock, these rollers can be accommodated. See, these are the photographs of the mill. The headstock is same. In first photo, you will see 3 rollers, feed, top and discharge. In second photo, you can see the underfeed is added. So 3 rollers plus 1 underfeed. In third photo, you see 5 rollers, 2 are TRPF and 3 regular rollers. In fourth photo, you can see 6 rollers can be easily accommodated. This helps sugar factories to increase at the time of increasing the capacity. In low cost, you can get very good results with such kind of headstock. This headstock is not a mere geometric arrangement. We have put up a lot of engineering into it. When pressure feeders are very close to the feed and top rollers, you get better extraction and more crushing rates. You will always argue that everybody says their mill designs are best or their products are best. But where are the results? I shall show you some of the results. At Jawar SSK, 20 years back, we have put a milling tandem of 42 by 84. 5 mills, they are regularly crushing 12,000 TCD. At Nirani Sugar, they have got 2 tandems at one location, comprising of 4 mills of 36 by 78 and 1 mill of 45 by 90. The cumulative tandems provide 22,000 TCD crushing. At Bajaj Hindustan, 20 years back, we have given 40 by 80, 3 tandems. Each tandems comfortably crushes 10,000 TCD. Siddhanath Sugar in Maharashtra, on 4 mills of 30 by 60 with TRPF and 1 mill of 40 by 80, 6,400 TCD crushing is achieved comfortably. At Dwarkadish in Nashik, very small mills of 28 by 56 are crushing more than 4,500 TCD. You can compare these results with any other mills and you on your own will get to know which designs are best. Till date, we have supplied 275 mills and 42 tandems. You can see the 45 by 90 onwards, more than 25 mills supplied. 42 by 84, almost 30 mills. 40 by 80 and 36 by 78, more than 50 mills we have supplied. And 2001 onwards, we have supplied maximum number of mills in sugar industry. This is a list of mill tandems which we have supplied over the period. Overall 45 mill tandems we have given. Now I touch upon very important subject, diffusers. Diffusers are again used to extract the sugar from the sugar cane. The main principle of the diffuser is it is a mass transfer process basically. The movement of sucrose and non-sucrose from sugarcane cells of higher concentration to lower concentration of imbibition water through a semi-permeable membrane is called diffusion. To make you understand, I will give you the analogy between heat transfer and diffusion. For heat transfer, we need a temperature gradient. The more temperature difference is there, the higher and faster heat transfer will take place. We all study this in our engineering colleges. For diffusion, it needs a concentration difference. The sugar concentration difference is more, the higher and faster diffusion will take place. Again, area. For heat transfer, we need more area, more heat transfer. Same way, for diffusion, more contact area of sugarcane cells, or for that matter, any of the material which is to be extracted, is required for faster diffusion. Heat transfer depends on many other.
Sir, interest of time.
Yeah, 2 minutes.
Okay.
On diffuser, there the other parameters which are used in heat transfer are metal conductivity, heat transfer coefficient, flow velocities, temperatures, pH, velocities. For the same way, diffusion, we need temperature control, pH, retention, preparatory index, and water quantity. We guarantee our diffusers give you low power consumption, very low operation and maintenance cost, high extractions, no major foundations. The very important thing is that all parts of this diffuser are indigenously designed and manufactured, which are high capacity chain, drive mechanism, filtration screens and frames with high percolation area, horizontal cane macerators for keeping the cane bed porous, and automation system. Again, one of the main features of this diffuser are we provide one fiberizer, one diffuser and one mill. Nowhere in the world you will find that diffuser is running on a single dewatering mill. This underlines the inherent strength, capacity and efficiency of our mills. These are the diffuser plants. 6-7 diffuser plants are already running. 8th is under construction of 12,000 TCD. This is the highest number of diffusers we have put up in India compared with any other manufacturer. Boilers, I shall quickly take you through boilers. We provide all sort of boilers running on bagasse, coal, lignites, paint wash and other biofuels. From 10 TPH up to 220 TPH capacity boilers we have installed with pressure of 110 kg and temperatures up to 540 degrees Celsius. These are very high efficiency boilers. They have got ability to adjust to rapid load swings, liberal designs. Again, main important point. For these boilers, we have designed a simply slat type traveling grate. For all other manufacturers, you will see that the grates are either imported design or collaboration with other companies. But this is a first kind of grate wherein it runs on mechanical drive. It does not have very complicated parts like hydraulic drives and T-bars and other things. And such, our 60 boilers are running on this grade. These are the boiler installations. More than 100 boilers we have done. Above 150, 8 to 10 boilers we have given. Above 120, 6 boilers. Above 80 TPH, more than 32 boilers we have given. And this is a list of all major boilers. Process of equipments, we make all kind of process of equipments. Centrifugal machines. In last 10 years, we have supplied more than 250 centrifugal machines. Our more than 12 plants are running on the centrifugal batteries of our own. Recently, we have started with distilleries. Diffusers are very good for ethanol extraction per ton of cane. 2 distilleries are already in running and another 2 are in construction. Spent wash boilers, 6 spent wash boilers we have already provided in the industry. We have got a manufacturing facility in Pune. We have got 5 workshops. These are some of the photographs of the workshops. Pioneering efforts. Over the years, we have done a lot of innovation in the industry. Some of them I shall just note. SSTRPF, short space tooth pressure feeders, we put up at Terna in 86-87, almost 30 years back. That time the crushing capacity increased by 60%. Swing type fiberizer hammer, first we put up at Kopargaon in 86-87. Then superstructured mill, as I told you, we introduced in 93-94. After that, we have put up more than 250 mills. Entire juice extraction by only one fiberizer, one diffuser, and one mill combination, which is perhaps nowhere in the world. This we put up in 95-96. Simple slag type traveling grate, again indigenously designed.
Sir,
Grate. Yes, sir.
you
It
require
last
to wind up,
yeah.
please.
In 2007, these are some of our certificates. And we got felicitated at the hands of Mr. APJ Abdul Kalam for the best techno-commercial entrepreneur. Felicitation by RBI. Best Co-Generation Performance Award at the hands of Shri Sharad Pawar Sahib. Thank you so much. Thank you for your time.
Thank you.
Thank you, sir.
Next presentation by Siemens.
Thank you, sir.
Good morning to all. I'm Lalit Salunke from Siemens Energy Business. We are from steam turbine segment. Today
So-
we are here to...
Hello. I request everybody to stick to the time, please.
Yeah.
10 minutes only.
Yes, sir. sir. So I am here from Siemens Energy. I'm Lalit Salunke from Siemens Energy the steam turbine business segment, along with my colleague Viraj Pawar and Shital Malade. First of all, we are thanking to VSI to providing us this platform to energize the society. So we are starting from problem statement. इसमें आ नहीं रहा है सर स्क्रीन में प्रेझेंटेशन मोड बघून घेतलं सर प्रेझेंटेशन मॉडेल आहे ना म्हणजे आपलं हे व्हिडिओज येत नाही नहीं येते रे विराज ओके got it आला
We know it just would not work without these industries.
Responsible for nearly 66% of global carbon dioxide emissions.
You look at steel, you look at chemical, you look at cement. How do we decarbonize these industries?
It's really hard to do, but if we don't, the consequences will be unthinkable. To transform industries which can't directly use renewable energy, we need to solve the energy trilemma.
For me, really large petrochemical plants and plastic producers are the next frontier. Hydrogen is going to be a vital piece of it, but it's going to be a piece of the whole energy chain. It's not that one company can do it all alone. It's really how do we bring the different players together, the different technologies, the different business processes, and do it in a partnership way.
It's the interaction of our people together, pursuing the same purpose.
I think there's tremendous power in human alliances.
We've started, but honestly, it's only a start. Because without more of these alliances, the decarbonization of hard-to-abate industries will not work.
Our Siemens Baroda plant, manufacturing facility, a world-class German standards plant. It was years 0.5 to 2 America, East Asia. Rotor machinery, machines, which can take up to 7-meter long rotor machine. This is the biggest in India balancing tunnel. These are vertical pressing machines. This is our product portfolio. It's a an acquired machine. So it is the impulse technology machine. It works in the lower parameters. It's our reaction machines. It's basically suitable for the small chemical plants and distilleries up to 25 megawatt with the efficiency ranging up to 88 to 90%. It's our machine SC300, which is also reaction based machine. It is ranging up to 50 megawatt with the efficiency up to 88 to 90%. So this is our service portfolio. Last minute. This is our service portfolio in India. Then across the India, we have installation of up to 2,000 fleets in India, generating up to 20 gigawatts. These are our service and sales offices across the pan India. At Durga, Kolkata, Raipur, Pune, and Chennai.
Sir, you require to conclude. We have next session also, so it will get delayed. Please.
So thank you, sir. Thank you, sir.
Good morning, distinguished guest. My name is Dheeraj Rana. I am here to present my company, Uttam Energy. I will just give you an introduction about what Uttam Energy is doing, what businesses we are doing. As a group, we are in the industry for last more than 4 decades. We owned sugar mills, we own distilleries, we have a unit Uttam Energy where we are doing the business for the sugar plant and machinery, boilers, and also we have a Uttam school for girls as a corporate social responsibility. So business solution, we are providing a turnkey cogen power plant for end-to-end solutions. It could be complete power plant, it could be cogen plant, it could be BTG island, or whatever is the requirement of the customers. Then turnkey sugar plant solutions, we as the group known again for 40 years, but in Uttam Energy we reborn say 2012 again. So we are doing these sugar plant by our own under the name of Uttam Energy. This is the latest sugar plant we have commissioned here in Maharashtra. It's a 3,750 TCD sugar plant. With a 12.5 megawatt power plant with it. So we are like in cane handling and proprietary devices. We are doing like end-to-end solution for sugar plant. So we do all our in-house design and manufacturing. Mill design, milling components, everything we are doing our in-house design. This is the milling unit you can see of the same plant. We are doing 3,750 TCD with 3366 mills. Mills are driven by AC variable frequency drives with mill control, automations. Boiling house also we are doing in-house design engineering and process house design with 35 to 40% steam consumptions. Uttam mills are known in the industry since long. So we have acquired this technology from Australia long back. Now we are designing it by ourselves, and we are providing mills up to 55 by 110 inch size. The complete range from 30-60 or even less than that up to 55 110 size. It is 3 roller, 4 roller, 5 roller or 6 roller mills configurations. Some installation in sugar industry. We have recently got an order in Kenya for 1,500 TCD sugar plant. As I said that as Uttam Group, we are 40 years in the industry. Many people know Uttam mills and all. But Uttam Energy has started their business recently with the sugar. Say last 4-5 years, we are doing the sugar plant by our own. Boilers, we are known earlier with in the name of Lippy Boilers, which in 2012 converted to Uttam Energy as a complete energy solution providing company. So these are some plants which we are executing at the moment. This is a 27.5 megawatt power plant along with a spent wash fire boiler. This sugar plant equipment we did in Bangladesh. This is for BSFIC. We installed the cogen and sugar plant there. Then turnkey 25 megawatt sugar plant we did in Belgavi, Karnataka. This project we did in Punjab, the complete modernization of the old sugar plant. It was a very old sugar plant which was remodified, modernized and installed completely by Uttam Energy. Another 15 megawatt power plant with the 90 TPH boiler and a high pressure segment. Temperature range is 515 degrees centigrade. So there are so many. You can see like in this range we are executing these boilers. As I said that we known from the Lippy time 40 years well in boiler segment. So we did a lot of projects already in boiler and power plants. So some of them are like you can see here another 15 megawatt, and then recently in ethanol plants we are doing quite good since this new change of bioethanol policy has done. So we are doing a lot of projects for these bioethanol plants. You can see small power plants with the boilers. It will be a spent wash fired boiler or a grain based for grain based distillery. It will be a fossil fuel or any other biomass fired boilers. Another 3.5 megawatt. So you can see in this small power plant segment, we are very competitive and very good and getting the repeat business from our existing customers. We also did this.
Sir, 2 more minutes, please.
Yes, very small presentation I have. Sir,
no, sir, but still.
Okay,
please.
So this is like straw handling packaging, which we did for this 2G ethanol plant, with the first one installed in IOCL Panipat. The project at 2G plant was done by Praj, and we did the straw handling facility. This plant we did in Philippines. Just have a look on that. You can understand what quality of work we did actually. This is a power plant. So the construction is done like if you go there, it will feel like say shopping So infrastructure capabilities, just 2 minutes I will take quickly. We have all latest 3D engineering softwares. I'll not take much of the time. You can see our manufacturing facility in Aurangabad. Just a quick look of that, which is very important to show that where we are manufacturing these boilers and equipments. It is at par with the.
Sir, please, interest of time, sir.
Just
no, there are other presenters are there, sir. I have to give justice to them.
It's almost finished.
So please, humble request, please, please.
Okay, thank you.
Thank you.
You gave time to others, but this is not fair, sir.
Next, Raj process.
Thank you.
Everybody has taken 10 minutes. Okay. Thank you. Thank you.
Nine.
Hello. Yeah, good morning, everyone. My name is Binu Panikar. I represent Raj Process Equipment. I'm VP Sales of, I take care of the sales part. So I'm very thankful for VSI for taking such efforts, gathering everyone for last 6 months. They've been continuously working on this event, and very thankful for Konde sir, PDA Patil sir, and all the members on this dais. First of all, I would like to question, but I don't expect an answer from you. Will the God be graceful to us? What we are doing presently with the ethanol industry? Government is saying that increase the ethanol. But really, will the God be graceful to us when you go up or wherever you go after the death? Will God be graceful to us? The way we are polluting the industry, we are polluting the nature. Will God be graceful to us? I don't think so. Government is saying that increase the ethanol production, but do you know that every liter of ethanol you generate 10 liter of precious effluent, that is spent wash? To whom will you everyone will give us a solution? Yeah, you can extract some of the other thing, like you can incinerate in the boiler, or you can do some of the other thing with this spent wash. But I don't think so that there has been any perfect solution to this. Incinerating is not an option. That is what we have come up with. And we have been focusing on this for last 6 years, and we have come up with technology that truly gives you a solution. Till 2019, it was in a R&D stage, but after COVID, that is 2020, this technology has really come up with a ready solution. I will explain you how the concept is and what it is. And really, this technology was a game changer, but it is truly coming up with much more benefits like CBG and all other things. In 10 minutes time, I will explain you. And after this presentation, you really will think that this technology would have been really helpful if we would have gone up with this concept for people who has gone for incineration technology.
Now this is the spent wash what I am talking about. For C-molasses, for every liter you get every liter of ethanol you get 10 liter of spent wash. For B it's around 7 to 8. For juice to ethanol, after recycling it comes to around 3 to 5. Now what we are going to do with this spent wash? Now this spent wash has a COD of 1,20,000 with a pH of around 3 and BOD of around 80,000. So it has a high organic load. So what this organic load can help us, and what we can achieve with this spent wash. Now this is the typical flow diagram, like how the spent wash we're going to treat with that. From the distiller you get the spent wash, ENA, RS, that is your final product. But what you're going to get is the raw spent wash. We treat it in the biodigester, and after keeping it for 25 days, its COD value comes down by 65% and you get the biogas. That's a precious gas. 3 years back, government used to give around 46 rupees in hand. Now you get about 70 rupees when you convert this biogas into a CNG. So rather burning the biogas into the boiler or rather incinerating the spent wash, we prefer that you go with this bio-CNG concept. Now, if you go with the bio-CNG concept, the question is what you will do with the biomethaneted spent wash. The biomethaneted spent wash is really very highly rich in potash if you convert that into a potash-rich granules. Now, how you going to convert this into the potash-rich granules? I'll shortly brief through this process flow diagrams. Later, I will elaborate each section. There's an integrated evaporator. After biomethanation, this spent wash will go to the integrated evaporator. And from the analyzer column, you get the vapor. You can concentrate up to 5.5 to 10%. That is the digester outlet is 5.5. You can concentrate up to 10% or 8% based on the analyzer vapor load. And then it will go to the standalone multiple effect evaporator, which you can concentrate up to 40. Then it will go to the spray dryer where you use boiler flue gas to convert and some sort of bagasse to raise the temperature, and you convert that into a powder. Then you mix press mud and bentonite and you get a good granulated potash. Government gives a subsidy of 1500 rupees per ton for PDM granule. Along with that, you get a selling price of 7,000 rupees per metric ton. Combining bio-CNG and potash, you get a total saving of 8 rupees per liter of ethanol compared to incineration. I have the comparison. I will show it to you. So that's why we say that going with bio-CNG and this scheme of Raj ZLD will give you a good revenue. So in case of juice to ethanol, you don't have spent wash and you have steam, then this scheme gives you much more benefit. And second thing, the evaporator part, how best is our evaporator, that I will show it to you later. This is a typical, section wise I will be elaborating it. The spent wash which you get from the distillery, it goes to the digester where you reduce the COD load. It's a CSTR type digester for 25 days retention time. Along with this, parallelly, if you have press mud, if you get 200 ton press mud, 100 ton you can store and 100 ton another press mud digester you can install. Both the biogas you can take and pass it to the H2S and CO2 scrubbing system. You get bio-CNG both from press mud as well as from spent wash. From press mud, from 1 kg you get around 90 meter cube of biogas. So it's very, very profitable to go for a combination, 2 separate digester, one for spent wash, one for press mud, and a common bio-CNG unit.
Bino,
yes,
two more minutes.
Yeah, sir, fine. And this is the bio-CNG system. We have installed a 20 TPD bio-CNG unit in Jagria, where you get 95% pure methane, where we have used biochemical scrubbing as well as CO2 scrubbing system. And this is the multiple effect evaporator. This evaporator has a typical degasifying unit where we remove ammonia and then we feed it into the evaporator, which you concentrate up to 40%. Now this is the patented spent wash spray dryer. Now after concentration, it goes to the spray dryer. How the spray dryer looks about, it's cylindrical in shape. This is like a cylindrical shape, and this is the process flow diagram. What is the main technology in this? That we are using boiler flue gas. This spent wash spray dryer is installed adjacent to the boiler so that we can utilize the boiler flue gas at 130 degrees Celsius. We boost it to 250 degrees Celsius and you get pure powder at the bottom. And this powder has a very good potash content. That's about 21% of potash you have it in it. Then it has a organic content of 25 to 30%. And what we do, this spent wash powder is very difficult to handle. So what we have done is we have gone one step ahead by granulating it. How we granulate? We add bentonite and press mud in it to convert that into the granules. And these granules, you get a subsidy of around 1500 metric ton. This is the letter from the ministry, and this is like second office of memorandum which government is boosting so that import of potash will be stopped. And this is the customers who will procure this potash, IFCO, Patanjali, GSFC, Deepak Fertilizer, there's a good demand for this PDM granules. Now this is a typical case study, sir. Just one more minute, sir. This is a typical case study of 120 KLPD molasses-based distillery. If it's a totally new distillery, it's a plain ground. Now you are in a confusion that whether to go for incineration or whether to go for a drying scheme. When you go for a drying scheme, this is the total boiler capacity required, 25 TPH, and you will get a CBG of 21.5 TPD by using press mud, as well as there's a separate digester for press mud, and SME you get 21.5 TPD CBG from this. And this is the raw spent wash incineration scheme, where you install a boiler capacity of 55 TPH, the 60% bagasse, 40% raw spent wash. Now this is the steam of this is the total consumption. Now when you compare both, this document is totally open to all. Whoever wants can contact me. I'll share you this document. You can see if the comparison, you will get a saving of 10 rupees per liter of ethanol. 4 years back, it was only 3 rupees because government used to give 46 rupees. Now they are giving 70 rupees, so it has gone up. So the total saving comes to around 10 rupees per liter of ethanol. That means for 120 KLPD, you will get 12 lakh saving compared to incineration. Now this is a typical, like a total installation. It's a journey from 2015. Raj process, just 30 seconds. So Raj process started its journey from dryers in 2002. Then it went into distilleries, cogen boilers and all. So our main forte is dryer, which we started in 2002. So we came up with this solution that how this spent wash can be dried. So this is the total list of installation. We have come up to like 50 plus installation of this technology. Recently, we are doing in Venkatesh Krupa Sugar Mill in Shirur and Siddhapur Distillery, Indian Cane Power. There's a lot of installation. I will share you this installation list. Recently, back of VINP Distilleries, GM Sugars. Now, we have a good presence in distillery as well. We have recently installed 250 KLPD in Venkatesh Krupa. You all are invited to see the plant, how the technology is out there, and around 40 plus distilleries we have an installation list. And dryers, we have a good installation in paddle dryers, spray dryers, tube bundle dryers. We have dryers for zinc sulfate, sulfur WDG, milk powder plant as well. And this is the recent compressed biogas unit which we have installed in Jakriya Sugar for 20 ton per day. In Manjra Sugars we are installing, and Srigonda also we are installing the same. In both it's a turnkey order with distillery.
Binu, thank you.
Yes, sir. And this is the evaporators. Thank you. Thanks. This is our manufacturing facility as well. Thank you.
Next, Man Energy Solutions. Sir, you are requested to stick to the time, okay?
I'll try my best, sir. Sure. Thank you so much. So, good morning, everyone. And I'd like to first extend my thanks to VSI for giving us this opportunity, and all you exceptional guests for being here and listening to all this barrage of information that all of us technologists have been sharing with you from the morning. So I'm coming from MAN Energy Solutions, and I would like to just introduce, because MAN is a very new company when it comes to steam turbines. So most of you would not have heard our name in steam turbines, but you would have one way or the other dealt with MAN. As of today, we will be covering 266 years. So MAN has been here from 1758. We started off as a humble iron works in Germany. And in 1904, we started manufacturing our first steam turbine. So as of this year, from 120 years, we've been making steam turbines. This is just a tidbit. So diesel engine, was developed by Rudolf Diesel when he was an employee at MAN. And the first prototype is still available at our facility in Germany. MAN as of today is a 50,000 crore company, completely owned subsidiary of Volkswagen Group. We have 15,000 employees globally in 150 locations. This is just what I was speaking to you about. So we have production sites in 9 countries in Europe, 3 sites outside Europe, and Bangalore holds one of the distinctions of being a global product center, meaning we manufacture steam turbines in India and export it globally. So these steam turbines were manufactured until 2017 exclusively in Germany. As of 2017, we shifted the production to India with the goal of being more competitive in the market and serving industries in the Southeast and the African market. So as I mentioned, we are there in about 150 locations globally for both sales and service operations. Decarbonization. So I'll speak more about this because this is our strategy for the next coming decade. So our goal is to limit global warming by 2 degrees Celsius and contribute to this with our technologies. So these are the 5 pillars which we have developed. Quickly going through PEM electrolysis, so generating green hydrogen using renewable energy sources. Next is green engines. MAN has developed engines which can run on green methanol, ammonia, because our strength or one of our biggest portfolio is engines which are used in marine industry and for power generation. Then we have retrofits where we are replacing engines in our existing fleet with the new engine families that we have developed. And then we have carbon capture and storage. So this is contributing majorly to industries like steel, cement, where there is huge amount of carbon emissions. And our technology will help you in capturing this carbon and utilizing it. And then we have heat pumps, where these pumps are used, especially in the European countries, where we have district heating, district cooling. And we are developing a solution which uses renewable energy to achieve these processes. I'll skip all this. People know about steam turbines, so I'm not going to speak much about it. So our presence in India, MAN is here from a long time, about 70 years we've been contributing to India. So our manufacturing facility for steam turbines is in Bangalore. We have an engine manufacturing facility in Aurangabad, and we have a compressor facility in Baroda. This is a snapshot of our manufacturing facility. We are capable of manufacturing turbines up to 50 megawatts, up to the, say about 45 machines a year. So this is our product portfolio starting from less than 1 megawatt. We go up to 50 megawatts. We have both impulse and reaction turbines. And we have both for power generation as well as drive turbines. So for pumps, blowers, compressors, our turbines can be utilized. And this is again one of the best things. So you must have seen turbines which have top exhaust or bottom exhaust. That's the radial this thing. We have turbines which can do axial exhaust. So we are currently developing a project which is which will be delivered in about April, May. It's a 12 megawatt turbine which we are delivering to Turkey. So anyone who's interested, we welcome you to our facility to witness this turbine. Steam turbine references, as I mentioned, so we've been doing this for about 120 years. We have 2,400 installations globally. So this is one of the first machines we supplied to the sugar industry. So most of the references you find here are for sugar industry. This for DCM Shriram Group, 11 megawatts. We got a repeat order within the next year for a 9 megawatt back pressure, both turbines running wonderfully from the last 2 or 3 years. This is for Ultratech Cement, MP Myhert 20 megawatt turbine. This is for a biomass plant in Argentina. And all of these turbines are manufactured 100% in India. This is one of our oldest customers, Reliance Jamnagar. 32 megawatt, 6 turbines running in their plant from 25 years. This is for Al Khalid Sugar, UAE. People who are familiar with the Middle East market, you will realize that they're one of the largest sugar manufacturers. 7.5 megawatt back pressure turbine. This is for Uganda, Kinyara Sugar, 5 megawatts, running again from about 2022. Sexaria Biswan, 3.5 megawatt, running from 2020. And this is just interesting because a lot of people kept asking to me, what is the lowest pressure your turbine can handle? This turbine is designed for 5.62 bar with about 165 degrees Celsius at the inlet. Completely condensing, generates about 1.15 megawatts of power. And this is again the interesting. I'm done. Don't worry. So this was a geothermal power plant, Kenya, 20 turbines, starting from 3.5 megawatt up to 5.5 megawatt. The worst quality of steam It has every sort of chemical in it, silica, and also comes with about 10-15% of water in the steam, and our turbines are designed to run with that. Thank you so much, gentlemen. I wish you all a great day. Bye.
Thank you. Thank you, sir.
Thank you, Manerji.
Aqua Systems.
Hello, good morning.
Hello. You have 5 minutes, huh?
Yes, yes, yes.
Thank you.
Good morning. My name is Pratik Bore. I'm from Aquatic Systems. Firstly, I would like to thank VSI for organizing such a good event. So we Aquatic Systems, we are mainly into water and wastewater treatment for sugar and non-sugar industries. We have been supplying to a number of industries since 1990. This company was founded by Mr. Sunil Bore. He started this company in 1990. We have been doing a lot of projects in water wastewater treatment like ETPs, STPs, WTPs, mineral water plants as well for beverage industries. Recently, we have been doing condensate polishing units. These are RO-based condensate polishing units for distilleries which we have been supplying. So if you see the inlet outlet parameters, this is actually a very good technology which distilleries should actually we suggest, because you can use different type of parameters. So if you see the flow chart, you can use process condensate and cooling tower both at the same time. These are the parameters. If you see, this is a 700 mld plant, 700 m³ per day plant we did. The inlet parameters, you can have a look. After utilization, the TDS was around 10,000, and at the outlet, if you see the plant TDS and all, it is below 250, and the recovery is around 80 to 85%. These are some of the process condensate plant installations we have done. These are the inlet outlet parameters of the plant. The complete plant runs on complete automation. No human interference is required for this, and it has a lot of interlocking systems, due to which the RO membranes are completely safe. So there is no reasons for your RO membranes fouling or getting damaged or continuous replacement of it. Mainly consumption in this is only of your caustic, which will be required for neutralization. Complete system runs on automation. Also, recently we did a no. I'm showing. प्ले होत नाही प्ले तर ते हे होत नसेल. Was the presentation? Anything. This was one of a recent project we did for Ambalika Sugar. This was a 3 ml DTP city plant. The entire sugar city water is being consumed for the entire agriculture land which the factory has. Not a single drop of water has been wasted. All 12 seasons, the entire factory is always green because of the CP water what we have been giving to them. And since then, we have been having repeated orders with a number of sugar factories. So this is the ETP and CPU plant which we have been supplied to Ambalika Sugar. It's a 3 MLD ETP and 3 MLD CPU plant. It's a sugar CPU plant.
Sir, Please wind up.
Yes.
Okay, thank you.
Thank you.
Next is Snyder.
Hi, good morning, everyone. By the time I got the laptop, I would wish you all a happy Bhogi and Sanskrati festival. So I am Vikas Verma. I am handling the business development for automation inside Schneider. So give me a minute. By the time that technology got fixed. Okay, so once again, happy good morning and very good morning to all of you. And we really want to thank VSI for giving this opportunity to present in front of you and for this great initiative that they have taken in. I am Vikas Verma. I am handling the business development portfolio inside Schneider. So when we talk about automation, we are having the latest technology of the automation that we will be take you through during this presentation. So as a Schneider, we are a technology company who works into energy as well as into industrial automation, digital software solutions, like provide the efficiency as well as the sustainability solution for our customers worldwide. We are around 34 billion company worldwide and having the more than 135 plus 135,000 plus employees worldwide that we have across 100 plus countries. We always believe into innovation, so that is why we spend more than our 5% to our R&D, and one of the R&D center for software solution we do have into India also. So we are one of the local into the global companies that we say. We are not the energy producer, however we really guide people or the to the industry how really we can save the energy and to get the energy efficiency out of it. So we work into the efficiency, energy efficiency, along with the sustainability part of it. So we have the business into energy management as well as into the industrial automation, as we can see over here. So as I told, our mission is really to become a digital partner for sustainability and for efficiency to drive it. So through decarbonization, for the electrification, as well as to drive the efficiency through digital, we really want to drive the sustainability for out of it. This is what all we know, how the digital technologies are really driving the forces into the market right now, because we all know what all are the challenges are there: commodity price, then the capex and the opex cost, how we really want to drive the ROI. But along with these challenges that we have in industry, we also have the digital opportunities, like we have the IoT, we have the AI and ML. These are the engines which really help us to drive our uh, we are empowering our user. First of all, like we are having the more agile operation, and we can see all the operations through remote control facilities at one place, maybe at your mobile, at your smart devices. So all these inside Schneider, we are driving it through the ecosystem plant, wherein we are driving the efficiency. We are securing your capex as well as how the install base you have done, because we are driving the cyber security. That is one of the very essential part of it, considering the today's scenario, because everything is connected to the internet these days, right? So this is what we really call it as a EcoStruxure plant inside Schneider. So this is a total 3 layers that we talk about. So starting from variable frequency drives, or maybe the IMCC, intelligent MCC, or the instruments that are there in the field are directly connected with my edge controller, where we have the controller or the DCS systems, right? And on top of it, to drive the efficiency, like to drive the OE, for the analytics part of it, we have the Aviva software solution which are there. And the best part is we are having the end-to-end cyber security, which is really helping us to keep secure our complete capex, basically. This is how we have driving the automation. So we were the first in 1968, like, who has brought the PLC or the control system to the market, and since then we have bring this journey to in 2023 or 2024 right now, wherein we have the latest technology of the controller, which are totally EcoStruxure based IoT enabled controller that we having. And also do we have the cyber security inbuilt. So these are with the native Ethernet backbone that we are driving it. We work into the industries, like as per the segments that we say, starting from the water, then we do a lot of work from the desalination to the water distribution into the smart cities. Then we talk about sugar industry into the CPG, sugar distillery, as well as ethanol. We do a lot of work into that. Apart from that, we work into space as well as nuclear. So one of the proud movement for all of the Indian, like we all know about the Chandrayaan 3. The Chandrayaan 3 launch was happened by Schneider Electric Controller itself. So that is one of the key driving force for us. Right? So this is as in control system, we have really talked about, this is our DCS solution for the sugar industry, for not only for sugar, complete mill industry. Along with that, we are also providing the solution for ethanol for the distillery. So these are completely open, based on open protocols, right? Which are open for the IT as well as the IT and OT technologies. And the best part is these are the
one more minute.
Sure. These are totally the cyber secure. So till now we were discussing about the hardware. So now I am moving towards the digitization of the software force. Basically, this platform is called Automation Expert. Here we are totally decoupling the hardware from the software, right? These are totally interoperable, and we can connect any hardware which is available, any IO available in the market with this platform. This platform is totally agnostic, basically. If you really talk about, here we are bridging the gap between IT and OT, as well as this is also compliant with any IT software that we really need to integrate with. So any IT software, let's say for SAP ERP, if really want to integrate with, so we can do the integration with the help of that. Also, we can also do the any integration with engineering layer, let's say your PNID, smart PNID, so we can directly do the integration with our software itself. Last, we are moving, we are in right now into the industry 4.0, like we have seen the 4 revolution till now, and very soon we would be getting into the industry 5.0. So we have the end-to-end software solution through Aviva. Aviva is our software company, which driving the efficiency as well as the digitization that we are providing. So starting from the simulation to supply chain, we have the end-to-end solution, right? We provide the operations, we provide the predictive maintenance, asset performance, supply chain, as well as that starting from the conceptualization when we really think for the plant. So complete conceptualization also can be simulated at one place itself. The last, I would say, this is the unified operations center. This is one of the biggest platform that we have. So here, this is not only for a one plant or one DCS or one SCADA system, basically. This is the systems of system approach, wherein we can do the integration of multiple plants even at one place. Along with that, we can see the complete starting from the design to the operation part of it. Operation, maintenance, all strategies can be defined over there. Third-party databases can be kept over there. And we have a huge install base, not only in India, also into global side also. So one of the example was the Naya Raipur that has been done by Schneider Electric. That was the first smart city inaugurated by Prime Minister Modi. So sir, from there itself we have started. Conclude. Yeah. So this is all the technologies which we are really showcasing to our stall also. So we'd request each one of you to please visit our stall into 3rd hall S67. Please do visit us, and we welcome you all, and thank you very much for this opportunity. Thank you very much.
KBK.
Okay, na? Yes.
Yeah, good morning to ladies and gentlemen, and thank you very much for the VSI for having us on this special seminar for sustainability at VSI Pune. We represent ABK Cam Engineering, a part of Renuka Sugars Limited, and as 100% subsidiary of Wilmar International Limited. As a group, we are running 8 sugar plants, 3 sugar refineries, and 3 big distilleries. All are supported and engineered by KVK only. So this short snapshot, why KVK? We are having so many advantages that we can go complete erection commissioning, complete EPC and turnkey projects for sugar, ENA and ethanol. See, we are here to, I'm directly coming to the point for the interesting to all of us that this is blending performance on the all over the country basis as far as India is concerned on a state wise. So you can see here with this data that we are almost reaching 12% blending on country basis, and as per government policies it has to complete 20%. So that means by 2025 we need to achieve this target of 20%, and by 2020 we need to complete the target of 20% blending in petrol and 5% in diesel. To complete this target, we need 14 million tons of grain and 4 million tons of sugar, which is a huge feedstock as far as grains is concerned. So we have to have alternative feedstocks. So this is what KBK is now introducing, this idea of matter to ethanol. That means KBK is capable of doing or manufacturing or producing ethanol from solid, liquid as well as gas. You can see from this slide, from this picture, that we have an engineering capability of producing ethanol from industrial off gas also. So that is the complete idea of having a circular economy as far as ethanol is concerned. We can convert waste to energy. And from here over, my colleague Mr. Manik will take over.
Good morning, all the dignitaries on the dais, now off the dais. This is a typical flow diagram of a next-gen ethanol where we are combining the hemicellulose and cellulose concentration, and finally we are getting fuel ethanol of 99.8%, where there are some steps which are involved over here are pre-treatment, depolymerization, free sugar involvement, and fermentation purification. We are having this procedure in a 20 KLPD plant based on palm kernel cake. We got the order and it will be commissioned in 2 years. This is the gas fermentation what we are currently having tie-up with, where we can get CO2 or carbon monoxide from the exhaust gases, couple it with hydrogen through a compression and fermentation with a patented microbe, where we can produce 99.8% ethanol over there. Some of the achievements of KBK: we are the first company to introduce EPC concept in India distillery segment. Biggest distillery what we have commissioned is 700 KLPD distillery on turnkey basis in Sri Renuka Sugars. Complete in-house engineering and end-to-end solution to client. We have our indigenous manufacturing in field of distillery as DDGS dryer and granularized activated carbon column in sugar industry. We have advanced oxidation process to reduce the biological load of spent wash in molasses based and sugar based distilleries.
Sir, 2 more minutes.
Yeah, sure.
2 more.
Yeah, sure. This is the current achievement of the figures that we have achieved in our existing distillery premises with 12 to 14% ethanol in fermented wash, 93% efficiencies in our grain-based distilleries with a residual starch percentage less than 1.3%. Without any steam saving devices, without SCC or MVR, we have achieved 2.2 liters per liter of water consumption and 3.6 liter per liter of water consumption in grain mode, with 95% of condensate recycled in terms of process condensate and spent lees. In terms of steam consumption, we have achieved 2.5 kg per liter on molasses-based feedstock, including the dry house, and 3.6 kg per liter for starchy feedstock. We have a plant operating less than 450 kilowatt hour per kL, and 99% of ethanol recovery can be possible at any percentage of ethanol that is present in the fermented wash, ranging from 1% VYV to ranging up to 20% VYV to maximum to match 99.8% VYV ethanol concentration, matching IS norms, Australian Union norms, GB norms, as well as EN norms. We ensure stringent quality analysis procedures with with deliverables like QAP, cost and effect analysis, hazard analysis, and safe operating procedures to our clients. Our infrastructure contains 50,000 square feet area with 500 tons per month of production capacity and a manpower strength of 200 plus. These are a pot still supplied to bricks and button for batch distillation. These are some of our project profile. We will quickly scroll into some of our recent installation is Mekalsuta sugar, where we have achieved 92% solid concentration in DDGS with protein content in maize of around 32% and protein content in rice in 42%. We have Nakshatra Biofuels and Chandrika Power currently in our portfolio. These are some of our ongoing ethanol projects.
Sir, please conclude.
Yeah, just 1 minute, sir. And these are some of our completed projects throughout India, in Karnataka, Maharashtra, AP, Madhya Pradesh, and UP. These are some of the HPCL Laudia, Sugauli, and in Rajasthan. We have a 150 TPD ethyl acetate plant supplied to GNFC Bharuch. These are some of our sugar projects. We can take over any job to improve the productivity in your existing sugar unit or can supply sugar plants. These are some of our project highlights. 200 KLPD in Thailand, 100 KLPD Roxel Bioenergy is San Carlos, 125 KLPD, Kilimanjaro, 100 KLPD. This is our recent installation of 60 KLPD at Mekalsuta, 100 KLPD Baramati Agro, 50 KLPD Metahara Sugar. Here we have 250 KLPD. This plant is fully running on ACC to achieve a water consumption of 1.2 liter per liter. This is a 750 KLPD. Can just take now.
Thank you.
Thank you.
Next is Paharpur.
Thank you.
I think after this you can discuss with them. Sir, please stick to the time.
या शुअर सर. नमस्कार. VSI पुण्यांचं मी पहिल्यांदा आभार मानतो की हे व्यासपीठ आम्हाला उपलब्ध करून दिलं. हा असा प्लॅटफॉर्म मिळणं खरंच आमच्यासारख्या वेंडर्सना जरुरीचं आहे, कारण वी आर पायोनियर्स इन कूलिंग टॉवर. नो नीड फॉर द इंट्रोडक्शन. वी आर 75-year-old company in this industry and supplying cooling towers to all major industries. What are the presentation has done earlier? Whatever the process equipments requires cooling tower over here because you have to cool the water. Myself is Vivek Gaukar, working as additional GM in Mumbai office, and I have got my representative, Mr. Kuldeep Rangari, who sits in Pune. VSI we are doing regularly. Now these are the various cooling towers we are manufacturing. That is powerful treated timber cooling tower with splash type of fields, and these have got application in all application in distillery like fermentation cooling tower, distillation cooling tower, liquefaction cooling tower, evaporation cooling tower, and MSDH. Apart from that, now these are the various installations we have done all over world. That is, this is the export job for Philippines. Then this displays at our stall also. Do visit our stall in GS06 exhibit number 1. Then another references are these are the Emperador Philippines. Then these are the typical fermentation cooling tower, wooden towers. Further, we have got various series towers are there, series 9, series 10, series 15, and series 18. And depending on the capacity, we are getting the various models. And as I told you, these cooling towers are utmost importance in cooling the water in every industry and in distillery. This is a very good platform because in one single installation we have got 4 or 5 different application cooling towers. Then these comes in single cell, multi cell, as well as depending on the capacity. 10 years back we were talking about 60 KLPD plant, 75 KLPD plant. Today we are talking about 600 KLPD plant or 700 KLPD plant. So such kind of growth is there in ethanol industry and distillery, and Paharpur is the only unique name in this industry. These kind of erections are done. It is not not factory assembled product. Assembly has to be done at site. It is like shipbuilding or the construction of a real estate buildings, wherein every equipment comes in a loose and the construction is done at sites. So it is a quite a challenging job for all of us. And with the cooperation from distillery manufacturers, OEM suppliers, we are doing tremendous projects all over India today. Can you say it in a Maharashtra, Karnataka, UP? These are sugar-based states, but now based on the grain-based distilleries, we are getting the number of businesses from Odisha, West Bengal, Haryana, Rajasthan, and all other states. So this is now going to boom in the industry today. And various components of the cooling tower, we are talking about structure, casing, lowers, splash fields, fan assembly, gearbox, drive shaft, motor, grids, etc. So based on those components, we do it assembly of the cooling tower, and whenever you enter in any distillery, first equipment we see at is the cooling towers, and maybe it requires a lot of engineering which is already done in our cooling tower. That is why we are the only sole suppliers in 90% of the market share is with Paharpur. This kind of structure is built at site, and we have got various manpowers. Access is through some staircase or the ladder. Then there are these are the internal components of the cooling towers like ACB, handrails, etc. And I won't go into too much of details, and I'm not going to give you the references as such, because what we jokingly say to our customer, if you start printing the reference list, it will be sort of a dictionary. So we just give you the various photographs of ongoing jobs right now in distillery.
Sir,
and these are the various
1 minute.
Yeah, sure, sir. These are the various components like fan stack, fan guards, etc. Then so I'll go quickly based on the time constraints. So these are the photographs which are shown on the sites. Down here. These are the various instruments we are using. This is the construction of the RCC basin which is required at site. These are the various installations. Then mechanical components are also shown.
Sir, please continue.
I'll complete. Then ladder. And these are our contact details. I am sitting in Mumbai, and my colleague Mr. Kuldeep is also, he is in local representative in Pune, and will be in touch with you regularly on this. Thank you very much, sir.
So next, Clean Earth, anybody came? So this is the last presentation in this session. Sir, 5 minutes only, so stick to the time.
Sure. I will. Respected delegates and august audience, Namaskar. I am Virendra Jham from Clean Earth Energy Solution India Private Limited, the first company in plate type heat exchanger field from India. We have the product called plate heat exchangers and air cooled condensers. Jointly, they can easily get you the possibility to meet the environmental clearances target. One of some customer mentioned just now that they have utilized the products as air cooled condensers and reduced the water consumption to great aspect. I think the claim is already made, and we had been instrumental behind that. These two products, like plate heat exchangers, which are of the gasket type and the welded type, are there you are using since long, but they have a question mark in the sugar industry, as sugar industry feels that these equipment get choked, fouled, and they are not as sturdy as they want to have it. Sure, this is the condition because this is the kind of the equipment which came to us in India or cane power industry with the experience gained into the beet sugar, which was mainly in the European kind of the countries, and this product came as an imported equipment to us, and we just adopted it. And there, this adoption needed certain kind of the more features, which we have tried to build, and those features we will like to present first, that now you will not face the problem if you specify these kind of the features as well in your specifications, and then we can carry onwards with a good supply to the cane sugar, and then you can have the similar kind of the efficiency which beet sugar could get, and you will not face the problems of fouling, choking, or such kind of the problems, which we will tell you where we have tried as well and we are successful, but we need surely a tweak in the specifications there. These are the wide gap plate type heat exchangers. At the bottom you see a kind of a slide which shows which were being utilized earlier with a very smaller gaps and the thickness of the plates as 0.5 or 0.6 mm, but we have taken it to 0.8 mm and the gaps are now 12 mm gaps, which you can see on top of the plate as well, where the ribs are also there, which gives a free flow kind of the effect. So you have to specify in the plate heat exchanger wide gap with free flow concept built in on the plate. And this will surely give you a kind of a choking free, falling free exchanger, and we have utilized that and shown into the sugar industry as well, but the specifications need a mention of that. Hybrid concept is a new concept. We have taken away the plate evaporator, the normal gap plate type evaporator. We have taken it away. We have combined the features of the tube as well as the plate into this. That is why we call it as the hybrid. And here you see the tubes of around 18 millimeter, where the plate gaps used to be around 6 or 7 millimeter. Here you have the tubes which would be utilizing your any vapor or two-phase liquid, can be juice, can be spent wash for reboiling applications. And the other side you have is the concept, which is the plate concept. So put together you get a very high efficiency, as high as plate evaporators, but they don't foul because there is a tube on the other side which is facing the plate on the next side. And the marvel thing is that this can be put inside the openable kind of a construction. Shell tube you cannot open like this, which is in front of you. This can be open, and top of it, this is completely gasket free. You don't see any gasket there. You have completely welded, and in India we have this facility where all joints of the plates are done with the laser welding at our plant in Pune Chakan, and this you can see the welding quality and the gaps are large there. Overall, we can say that the Clean Earth, which brings these three projects, we can do 5 things to you. It is distillery. If this product is linked to a sugar plant as a reboiler for a distillery, you will not need a new boiler. We will tell you how, and proven concept this is there, and think about this, that this possibility exists.
Sir, 1 more minute, please.
Sure, sir. All juice heaters in sugar mill can add up to saving of steam by 3%. Air-cooled condensers can easily help you to reduce water consumption by 35%. And this we have proven at Renuka, Pandurang and Gurudat sugars. Refinery metal concentrator in hybrid construction can get to the payback period of 6 months, while coloration within the range of 10 ECUMSA. Capex 2 is less than a shell and tube falling film evaporator. So all these features put through can give you a lot of savings various places. This is a distillery where the reboiler is shown here on 5 columns in the Renuka's Manoli plant, and I'll show you why you don't need a boiler if this is linked to a sugar plant. This is a shell and tube heat exchanger where the spent lees in a reboiler is getting reboiled at 125 degrees centigrade for sure. If it is a shell and tube, you need a 147 degree, which is 4.34 atta kind of the pressure. However, if you utilize this hybrid concept, you will need the only 4.5 degrees centigrade approach temperature and 130 degrees centigrade steam you can use, which can come from any bleed of the sugar plant. Easily done, can be done, and in this kind of a case, you will not need a new boiler if you are setting up a distillery linked to a sugar plant. This example I just wanted to show you, wherein we are reaching, in the case of the raw sugar heating, 42 to 57 degrees centigrade, we are heating it up, and we are utilizing the hot condensate at 92, which can come down to 47 degrees centigrade. And you see, if this is a shell and tube heat exchanger, the 47 will be around 60 degree temperature. So you are losing approximately around 25 degrees centigrade of the heat recovery if you are going with the shell and tube. So this much kind of the possibilities exist, and same we have shown at the defaceted juice. There
Sir,
we can do it with the
sir, please
92
conclude.
cent. Yeah, sure. And this was becoming possible because of the wider gap and the reverse flow mechanism adopted, and 15 years experience is behind that at Godavari, and you can utilize this concept, and this alone thing, changeover from shell and tube to this, will give you 3% saving. Rest is the air cooled condenser, which we have already mentioned and you have seen previously as well, and therein a lot of saving can be done.
Thank you, sir.
This is the reboiler. I'm just finishing, 2 seconds. And this is the surface condenser. So this also was done to save the water. And these are the air-cooled plate heat exchangers, wide gap plate type heat exchangers utilized in the distillery.
Thank you, sir.
On all the alcohol vapors as well as on the evaporator sections, this has been utilized, and there was no cooling tower utilized for this. Thank you so much.
So I am thanking all technology provider for supporting. So for before starting next, we'll come back around 11:50 here.
क्योंकि आप उनकी जगह पे वो डिसाइड होते हैं, वो डिसाइड इंटरेक्शन वेळ देत जाऊ फार घाई करू नका पुढचं लेक्चर सेशन कव्हर करायचं
चालू किया ना? So, good morning, everybody. So, I feel privileged to welcome you for this third technical session on challenges and opportunity in bioethanol. We feel honored to have with us Mr. Atul Mule as a chair for this session. I welcome you, sir. So, please take the dais. Now, I request 5 distinguished speakers for this session to occupy the chair. Mr. Y.B. Ramakrishna, Dr. Paul Boom, Mr. Mainak Chakravarti, Professor S.V. Patil, and Mr. Ajay Nair. So before starting session, I will introduce about the chair. So Mr. Atul Mule is the President and Strategic Business Unit Head for Bioenergy Division in Praj Industries Limited, Pune, and heads global operations. Mr. Atul Mule is a member of various group, Biofuel Working Group, Ministry of Petroleum and Natural Gas, Government of India, founder member and chairman, Bioeconomy Committee of Indian Federation of Green Energy, CII, National Task Force on Sugar and Ethanol, Biofuel Advisory Committee, Maharashtra State. So may I request Mr. Atul Mule sir to give the chairman's address. Thank you.
Good morning, everybody. We yet to go to the good noon stage as yet because we have 5 minutes left. Respected dignitaries on dais, respected dignitaries of the dais, let me first congratulate and thank Dr. Konde and the Vasundhara Sugar Institute management for arranging this such a wonderful expo, which normally happens every 3 years, I believe. And then we have the dignitaries, the speakers coming from international repute, whom we will be very happy to hear to you, all of you. I also want to convey best wishes for this expo from Dr. Pramod Chaudhary, who is the founder chairman of the Praj Industries Limited, who was supposed to be here, but because of some conflicting the appointments, he couldn't join this session, but he has conveyed best wishes to VSI management and all the dignitaries sitting here and all of you here. When we have discussed about the biofuels opportunities in India, I'm sure my colleagues will also talk more about it. And it's a huge opportunity in biofuel, and how and what is that? We will go into this presentation. I'm going to touch base on, since some of you are aware about the Praj, but I want to just touch base on the recent happening at the Praj. So the Praj at a glance, opportunities flagged off in India. That's one of the major things. Drivers for biofuel, in fact, the dignitary here, like Dr. Y.B. Ramakrishnan, is the one whose tenure this whole biofuel started moving, and we would like to actually listen to you more than probably, but I will touch based on some of them. Opportunities in ethanol at large, challenges in ethanol sector, and opportunities other biofuels. So it's normally the biofuel means people only talk about ethanol, but then other than ethanol, there are huge opportunities in compressed biogas, biohydrogen, isobutanol, and sustainable aviation fuel. So while doing this, one of the major thing which normally one has to take into mind is that sustainability of any biofuel of this program, the lowest water footprint, lowest overall energy consumption, and lowest carbon footprint is basically need for developing any biofuel, and that's what we at work on that on continuous basis. So when I talk about the Praj at a glance, probably you know that we have almost 1,000 references worldwide, presence in almost like 100 countries. We have almost like 400 international references, 3 manufacturing facilities. Probably the fourth one is getting added in Karnataka now, in maybe about a year, month or so. Over 1,200 employees, 90 plus research scientists, and where we have a very good, I think, the collaboration and association with Vasundhara Sugar Institute, where a lot of exchange happening during the tenure of Dr. Sanjay Patil and now Dr. Kunde Patil. We have a lot of association going on with Vasundhara Sugar Institute. 300 patents. About 40% of our business come from the same customers, the repeat business, which takes care of the business cycle. So 10% of the global ethanol production comes from a Praj technology Praj plant. The significance of 10%, other than the China, of course, where we're not present, but the significance of 10% is like almost like it is 1200 crore liters, and that's what the India's requirement of 20% blending. So equivalent of India's 20% blending product comes from the Praj technology globally. We are celebrating our Ruby year, that is 40th year of operations. We have seeing we are a listed company, we are paying the dividend for last 24 years. Revenue roughly accounting about 3,500 crore. So that's broad Praj as of today. So opportunities flagged off in India. As I said, that 2018 was a year wherein the revised biofuel policy got announced, and that's really the flag off year, I would say. Though the biofuel policy was in place before 2018, but the 2018 has seen a major change. And before 2018, between 2016 to 2018, that Herculean work and the task was done by the eminent people sitting on a desk under the leadership of Dr. YBR, Dr. Sanjay Patil, and Dr. Konde, and then various institutes and various stakeholders, in fact, sitting there also. All of them got together, and this biofuel policy, which is a workable biofuel policy, got into the existing 2018. This policy was also talking about the biofuel of the second generation ethanol. This talked about the sustainable aviation fuel. This talked about the compressed biogas plant. And in today, if you see, this is all reality. In 2018, we talked about it. In 2023, the first, India's first, or probably Asia's first commercial scale second generation ethanol plant, ultra low CI ethanol plant, got inaugurated by Honorable Prime Minister Narendra Modi ji. Some statistics mentioned here, which is talked about that number of farmers benefited, about 100,000 farmers got benefited. Rural job creation was one of the theme, about 1,500 rural job got created. Number of cars displayed from a carbon perspective, that is pollution perspective, almost like 63,000 cars off the road for almost a year. That was an equivalent of carbon emission got reduced. CO2 emission reduction to the extent of 320,000 metric ton, and that's what the biofuel policy 2018 success. When we talk about what are the such a way that you can also have the same gas production during off season also. And that's the success of this plant. This commercially plant is already in place in Indian Potash Limited. So let's talk about the flag off of, it's not only the 2018 policy, but policy got into a reality and the reality started moving. And that's what the success of the policy. So driver for the biofuels, there's a shift in energy mix and particularly in transport sector, because whatever you are talking about is coming from the transport sector. Just to have a quick numbers on the transport sector. As you know, India is going to be world's third largest primary energy consumer, and normally it has always been measured that success or the development of a country that how much energy they consume. And then we are going to be the third largest, or rather we are the third largest energy consumer. And then we have diversified mix, almost like 31% energy mix coming from oil and gas. That's what is then. And then transport sector is the single largest consumer of petroleum product, that's everyone knows. And two major drivers which we thought of in biofuel policy, that high import dependency, 85% of oil and 55% of natural gas we are importing. And that's what we want to curtail, and that's where the policy talks about. That's a major driver. And second major driver was transportation sector, which is second largest GHG emitter in India after the industry, this sector. And two drivers has really seen a major change in the biofuel policy. In fact, the various conferences, the talk, the discussions, even today we are here only for that. And that's what the major success. So need for sustainable, alternate, import substitute product and reducing this GHG emission. So that was the major driver. And we as in India, we are ready to really take this challenge. So reimagine. So during this process, what we have discussed with various scientists, in-house scientists from our technology center, our business development team, our technology team, that why not reimagine the mobility? Why not reimagine the mobility? So today probably you have a fossil fuel. We have a lot of challenge. Energy security is one challenge. High forex outgo, as everyone knows, is another challenge. GHG emission is challenge. Oil price volatile is a challenge, and farmers exclusion. In all of this fossil side, farmer inclusion is not to the great extent. But if you shift to the alternate green opportunity here, when we talk about a biofuel, the first generation biofuel, we talk about a biofuel, which is second generation biofuel, a sustainable aviation fuel, mild hybrid vehicles, EV, and flex fuel hybrid vehicles. Probably you would have also listened to Honorable Gadkari Saab. He's talking about this. He's already using Innova from Toyota. It's a full hybrid from ethanol. So 85% ethanol, 15% of gasoline, and there is a battery up to 60%. So that's what the vehicles already started coming into India. And so that's the complete fossil fuel change. The drivers, we can get that challenges to opportunity, and this opportunity is touching based on the farmers. That's what the things are. And then there are various technology been provided by Prash for achieving this opportunities and challenges. While doing so, energy transition to green solution for the net zero. So what is that? Each of those, like for you have seen this first generation ethanol, there is one, then the second generation ethanol, there is a compressed biogas, sustainable aviation fuel, and biodiesel. Now this graph is very, in a way, complicated, but it's very simple to understand. If you go to the first generation, whether it covers inclusive growth, yes, the first generation covers inclusive growth. Whether it's a feedstock availability is there, so feedstock availability is as of now is a challenge. So that's why it is not scoring the high. Whether it coming the CI reduction, yes, it is achieving the CI reduction, but it is not achieving CI reduction to the extent of second generation. Whether technology readiness, yes, there is a complete technology available first generation. And infrastructure readiness also is a challenge. So if you see all those 5 parameters, it scores at a different level. If you take to the second generation, inclusive growth, yes, it also touches the inclusive growth. Feedstock availability, yes, it is definitely feedstock availability. Perhaps it is better feedstock availability than the first generation. CI reduction, yes, it is better CI reduction than that of probably of the first generation. Technology readiness is there already. One plant at IOCL, as I said, started producing ethanol. The another plant of HPCL and BPCL is under construction. Those plants will also come into the production during next 6 months to 1.5 years time. Infrastructure readiness, still a challenge, but inclusive growth, yes. So is the case on CBG, SF, and biodiesel. So the graph talks about all those 5 parameters which are very, very important for any of the success of any of the biofuel. And this graph has been arrived at based on the various discussion and interaction with a lot of research institute and a lot of association, and this is what is been published now. So when we talk conventional biofuels, first generation ethanol, advanced biofuels, second generation ethanol, next gen biofuels is safe, and then we also going to talk about renewable chemicals and materials. So decarbonization of transport industry and carbon recycling is something which is close to the heart of our founder, Dr. Pramod Chaudhary, and that's why we have arrived at two different set of expertise or two different technology routes. So bioeconomy at large will largely, from an India perspective, global perspective, will run from the biomobility side, and other will run from a bioprism side. And for which one has to have an expertise from an ecosystem side or from an investor side, that the feedstock availability, feedstock challenge, the technology, and the product. There are three major pillars and expertise needs to be developed for developing this ecosystem. Biomobility at large, one can see on the right hand side, that talks about the bioethanol first generation, which is a very proven technology. Cellulosic cellulosic ethanol, that is second generation ethanol, which is definitely and technically proven commercial viability establishment is on. Compressed biogas plant is also a developed technology and economically viable. Then there are marine biofuels, then there are sustainable aviation fuel, then biohydrogen, biomethanol, and ethanol blended diesel, which is a very latest trend in happening, ethanol blending diesel. So that's what the biomobility circle talks about, and each one of them are getting benefited, as I mentioned in that Pentagon diagram of 5 inclusive growth parameters. We'll touch base on that. From the biomobility, there is a bioprism. So they are also talked about the renewable chemicals and materials. So in fact, some of the topics in today's discussion is also the renewable chemical material, and this is also ultimately this is going to be a sustainable climatic action through the bioeconomy. Whole of those wheels are going to actually rotate the bioeconomy at large. In one of the conferences, there was some statement given by some of the government officers that during last 5 to 6 years, almost like 80,000 crore rupees equivalent of fuel, import fuel got saved. So probably we have saved over 80,000 crore rupees. Out of that 80,000 crore rupees, 50,000 crore rupees have gone back to the farmers. The whole circular bioeconomy, when we talk about, is started circulating there, and that's why the importance of a biofuel, which is connected to the farmers, is important here. Then what we talk about the transition from fossil fuel to the renewable fuel, that's what is a need. And then yes, today the sugar factory, standalone sugar factory attached with the multiple co-product development, there's a possibility like you have a CNG which is coming from fossil, we have a CBG coming from here, we have a gasoline, we have a bioethanol, biobutanol will come. Naphtha, you have a biochemicals coming from route from this side. Kerosene can be with the biojet, diesel, renewable diesel, and so on and so forth. So there is a huge potential, there is a huge chance of transition from fossil fuel to the biofuel, and that's what the refinery concept is going to happen. And probably some of the investment or some of the industry people already starting investing into it, and some of them are in the process of investing, for which there is a lot of encouragement coming from the government, central government and state government is coming forward for developing such green fuels. So opportunities in ethanol, when we talked about the biofuel at large, so let's focus on the ethanol. So what are the opportunities available in ethanol? There are various numbers started floating into market, but probably we have tried and captured some of the numbers here. The fuel ethanol demand, when I talked about the numbers which are available, are almost like we need about for a 20% blending, about 1100 crore liters. The potable demand, which continues to grow with the GDP to grow, the population to grow, which is almost like 300 crore liters. Industrial demand has also been captured at about 138 crore liters. The E100 vehicles, the two-wheelers, which again, Gadkari have talked about, that various automobiles are ready with their two models with 100% ethanol, which is going to take even about 230 crores. The flex fuel roughly will take about 66 crores, additional 7% alcohol about 73 crore, and so on and so forth. So they are mapped here. So all in all, by 2030, the ethanol demand is likely to be in the range of about 3,300 crore. So today, when we talked about 1,000 crore, 1,200 crore, it's going to be almost like triple in next 6 to 7 years time, and that's going to be the demand. And this demand is purely coming from the circular economy and bioeconomy, and that's going to be a crux of the whole biofuel policy. While doing so, feedstock, what is the potential for ethanol and production? So as I said, left hand side you see some of the pictures that the sugar, available feedstock from a sugar, one can go up to 700, 750 crore liters. From a starchy, one can go up to again 700, 750 crore liters. and probably lignocellulose, that is lignocellulosic ethanol, that is the second generation raw material available. One can really go to 200 to 2000 crore liters also. So by and large, whether the feedstock availability is there, the feedstock availability is there, but of course the ecosystem needs to get built for this, and that's going to be one of the major challenges in the coming 6 to 7 years time. Now challenges and resolution of challenges is something which this expert sitting here will also talk in detail about that, the feedstock availability which we have discussed. And then there are very sincere efforts are happening at this central level, state government level, and the various organization level, that how can we have a uniform policy of having a feedstock availability around the pan-India and for the round the year, and that's what the work is already been happening. Probably I would say a sugar industry about 50 years back, what was the scenario on feedstock? Probably the biofuel industry in the same phase today from a feedstock side. I'm sure coming 6 to 7 years time, this feedstock availability challenge is going to go away, and then there is this abundant feedstock availability, because India, we as a country, has a lot of potential to have multiple feedstocks available. Policy consistency, yes, it's very important, and some of the silver lining here that government is committed on that, whether they are giving the prices at the various level from year to year basis from the cane ethanol, but at the same time they are also giving grain ethanol also. Recently, after the maize prices, they have also increased the price. So there is a definite commitment which is coming from the government side. Logistic arrangement, yes, it's still a challenge today, but then addressable challenge. Clearances from institution for the new projects is a challenge, but again, the moment government comes forward, the state government comes, there are various state governments also started having biofuel boards of their own, and the biofuel board also started working very effectively. Karnataka, UP, probably Maharashtra will also coming with the biofuel board now. Non-existence of CI related mechanism. So something is which is yet to work is, yes, today maybe we'll talk more, Dr. Paul will talk about the detail that CI reduction. There is an established mechanism already there in Europe and USA. Probably India need to do that, and that's what probably the Vasantha Sugar Institute can come forward and build this very validations and certification model for the CI numbers. Lack of connect between ethanol industry and other its connected is like poultry fishery. So one also challenge, again, that's at the initial phases, the DDGS, which is distilled dry grain solubles coming from the grain plant. There are challenges, there are certain demand in certain pockets, and certain pockets not having demand. Then there are demand for the poultry, there are demand for the cattle feed. So there are various things are happening. Probably again the time has come to really incorporate this together and have a very uniform policy. So many agencies, teams, associations are working towards resolving these challenges, and I'm really glad that we, from a Praj perspective, are also one of the stakeholders who are supporting on these challenges to be addressed. So apart from ethanol, what are the approaches in other biofuels and renewable materials? I will just go through of some of the slides on probably want of time. That sugarcane on a grain biomass, you can get a protein, and then protein can either in the form of DDGS or it can be in the form of human protein. You get a carbohydrates, and then you have a range of products like ethanol, isobutanol, isopropanol, lactic acid. Then you have an organic residue for a biogas and an ingredient. Then you have an ash and probably biofertilizer, and the potash recovery from ash is becoming now a buzzword, and there are various technologies are working. Government is also encouraging those. So one can see the green ones are already been established, ready to offer. R&D type work is already going on ethylene and isobutylene, and some of them are like conceptualization like isopropene. So this is again at a large scale. When we talk about the biorefinery, the shift is going to happen like for any sugarcane based complex or any grain based complex. One can really see for decarbonization of transport sector and carbon recycling through bioprism. So that's what in future next 6 to 7 years time people will look. There is a compressed biogas technology, as I said, I touched based on that, and it is not only from press mud, it is also coming from the various agromass basis, bagasse, rice straw, and any other filter mud. That's also the technology which is well proven, and our first plant of Hindustan Petroleum, that's our first plant in Hindustan Petroleum Corporation Limited, will undergo commissioning phase probably in next 2 months time. That will be, and the another plant is already in Jamnagar. It is also getting developed again from the rice straw basis. Then green hydrogen is an area which is again one of the I would say the point which every forum wanted to get discussed. The challenges on technology, the challenges on commercialization, and I'm sure that many agencies, including Vasantha Sugar Institute and various research institutes, IIT Delhi, IIT Mumbai, IIT Chennai, everyone is working on that. and probably we would like to listen more again from the eminent speakers from here. That's what the commercially making viable is the challenge, but I'm sure with the way we have gone ahead on the various biofuel, it will be also made available within next 2 to 3 years time, and we at Praj also are working on the same. Value maximization isobutanol production is one area which is where we have tied up with Geo, and Mr. Paul talked about it in detail about it, from an isobutanol from the sugar streams. Sugarcane biomass to sustainable aviation fuel is one area which again Paul will talk about in detail about it. That, as I said, that the first commercial scale flight already been got from SpiceJet, already been flown. And lastly, one can see the farm to biofuel. So eventually, probably a decade onwards, one can see this is a reality that you have a farm, then you have raw material preparation section. It can be multiple raw material preparation section. Then you have a pre-treatment, hydrolysis, mixed sugars will come in, and then you have an option of distillation reagent either to produce ethanol, sustainable aviation fuel, or polylactic acid. Eventually, it can go for a bioplastic. So the complex is going to be no more going to be a concept. It's going to be a reality in coming 5 to 7 years time. So that's all from me. Thank you very much for your patience listening. Thank you very much.
Thank you, sir, for your informative presentation. Now I would like to take opportunity to introduce our next speaker of this session, Sri Y.B. Ramakrishna. Sri Y.B. Ramakrishna is the member of expert committee from the working group of the Biofuels, Ministry of Petroleum and Natural Gas, Government of India. He is the chairman of the task force of the methanol and the DME production from the Biomass Niti Aayog, and he is the chairman of the Biomass Study Steering Committee, DST, TIFAC, Ministry of Science and Technology. So now I request Mr. Y.B. Ramakrishna to give his presentation.
Very good afternoon to all of you. The dignitaries on the dais, after the dais. Let me take this opportunity to thank VSI for having invited me and share some of my views. As rightly pointed out by Atul Muleji, that though the session is talking about ethanol opportunities, I think the opportunities are much beyond ethanol. Ethanol is only a starting point. And specifically, I would like to focus on the policy issues, what exactly has happened in India in the last 10 years, where are we heading, and the kind of opportunities that are there specifically for the sugar industry to reposition as energy companies. I will only focus on the energy companies, but there are opportunities to go beyond energy company also, looking at biomaterials and biochemicals and things, stuff like that. But let me focus more on the energy part of it. Well, when we talk about the biofuel program at the global level, almost every country has been talking about biofuel and they have a program. And there are two major drivers, the energy security and the environmental concerns are the two primary drivers. India being an agrarian society and our agriculture being at crossroads, we are also looking at how the biofuel program can really become a tool for rural development and, giving an impetus to the local economy. As rightly pointed out by Atul Muleji, I mean, it's not biofuel blending is not a new program. In fact, we started out in the recent past, we started the program in 2002, 2003, when Ram Naik happens to be the petroleum minister. And I still remember, we had organized a conference in Bangalore where we had about 40, 50 members of the sugar industry who came there as a delegation requesting Ram Naik to start the blending program. And that particular conference, he made an announcement saying that we are going to start it. This happened in March 2003, and by June 2003, he had started the blending program. Unfortunately, it so happened that in 2004, there was a new government, and they did not take the whole program forward. But we had a policy in 2009. The policy was a good policy with a good target to do 20% blending by 2017 of ethanol in petrol and 20% biodiesel blending. But unfortunately, there was no program to get there. We had a good policy in place. And that's where the big difference was made in 2014. And when I was requested by Government of India at that point of time to be the advisor to the petroleum minister and help them drive the biofuel program, when we reviewed, to our surprise, we realized that the ethanol blending program was at 1.4% against the 20% target that we had to achieve in next 3 years' time. So we were not going anywhere. And that's when a national working group was constituted, and I was requested to chair it. And, I had the opportunity to work with Atul Muleji and many others, who were there as members. And they helped me really put together a new policy and a new program for the whole country. And as you see, in 2018, we set a target to achieve 10% blending by 2022 and 20% by 2030. And incidentally, with all the steps that we had taken, we were able to achieve the 10% blending 5 months in advance. And with the kind of steps that we had taken, we had the confidence that, we may be able to advance the 20% blending target from 2030 to 2025. And we are on the target to do that. We've already achieved 12% last sugar year. And I think, we are on track with all the kind of policy, inconsistencies that we are talking about. We would still meet those kind of targets. That's the kind of confidence that I have. So the biofuel policy itself, as he rightly said, focuses on first generation, second generation ethanol, biodiesel, compressed biogas, and some of the futuristic fuels like sustainable aviation fuel, methanol, dimethyl ether, green hydrogen, etc. Now, when it comes to first generation ethanol in 2014 onwards, several steps were taken. First and the foremost, the pricing of ethanol was at 28 rupees. And obviously, people were not, the producers were not happy with the kind of revenues that they were generating. And OMCs were not picking it up even at that such low price and doing the blending. And, there were a lot of issues like, the taxation, interstate, transportation of the ethanol and things like that. One by one, all those things were taken care of. And with the kind of interventions that were made. And also, I'm talking about that interest subvention scheme, which is a very important thing for people here to understand. People always keep telling me about the food versus energy kind of a security debate. Now, what happens if sugar is being diverted to produce it? Incidentally, in 2014-15, when we realized the sugar prices had dropped and our production was in the range of about 34 million metric tons, and our consumption was only 24 million metric tons. And then almost about 8 to 10 million metric tons of sugar had to be exported out of the country, and the international prices were much lower than our production costs. Government was spending something like 5,000 crore rupees as subsidy to encourage the export of excess sugar that we are producing. And we were not allowing the bee molasses or sugarcane juice to be converted into ethanol. So our argument from the working group was saying that, you're spending 5,000 crores, and that sugar is going out of the country without affecting the sugar prices within the country, without, we will be able to divert that excess sugar and produce, ethanol. And that 5,000 crore rupees that you are talking about, why don't we spend that kind of money in creating the kind of infrastructure that is really required for building it? Government agreed, and that's how that interest subvention scheme on first ethanol came into. And you have the prices. This is the latest price from 28 rupees in 2014. This is where we have now transition, and you get prices almost up to from sweet corn up to 71 rupees a liter, and the lowest price that you get is something like 56 for the C heavy molasses. So this is where we are when it comes to prices. Now, if you see the steps that we have taken, in 2012-13, it was so low, the production was so low. In the 14-15, I think 500-600 crore liters was what was being procured for blending. And now we have already crossed the 5 billion liter kind of, and at 22-23, as I mentioned, we did cross 12%, and 5 billion liter is what the procurement was. And now from year to year, you see how the procurement happened and how the blending percentage was achieved, except 1 or 2 sugar years where the blending came down a bit. You see that there has been a very consistent growth. Now, okay. As he was mentioning about the second generation ethanol, you're also talking about the availability of the feedstock. Being an agrarian society, in 2015, there was a study that was instituted by Ministry of Science and Technology under DST Type Act. Incidentally, I chaired that study steering committee. And from 11 major crops, what has been left back, the agricultural residue that has been left back on the farmer field, was something like 187 million metric tons. We produced about 1 billion. Out of the 1 billion metric tons of agri residues, there was already a lot of usage, but what was wasted on the farmer's land, burnt or unutilized, was in the range of about 187 million metric tons. And India has so many varieties of different crops that we grow. I'm only talking about 11 crops. So if you really take the top 50 crops, then it may be going into about 2.5 to 3 billion metric tons. The challenge that we have is aggregation, storage, and making it in the, making it available in the form and factor it is really required for the processing, whether it is 2G, CBG, or whatever it is. So that is where been the challenge, and that is where a lot of policy interventions are there at this point of time, and encouragement to bring in investment into creating that kind of supply chain. When on this, I want to take one more minute on that particular feedstock. When we are talking about various programs, most of the feedstock comes from our wasted resources like agricultural residue, municipal solid waste, or some waste that are being generated from the industry. But then the most wasted resources in this country is the land owned by the farmers. I'm not even talking about the wasteland categorized by the government. I'm talking about the land underutilized or wasted by the farmers. That runs, you will be surprised, about 45 to 50 million hectares of land. In the last 20 years, we have not grown anything. These are all arable land where farmer could have done it. For various reasons, there have been no agriculture there. And another 70 to 80 million hectares of land, we have been raising only one crop during the monsoon. That means for 7 months in a year, we are leaving that land barren. So we have the land which has been wasted. Can we think in terms of engaging the farming community with the right kind of interventions and with the right kind of energy crops? We can talk about energy crops, food crops for meeting our protein requirement, which is, and growing our oil seeds. But if you are able to make use of the land which is wasted at this point of time, involving the farming community with the right kind of interventions, let me tell you, India can be a bowl of not only the food and fuel. Food and fuel both can be supplied, if not to the whole world, but definitely to the whole of Asia. It is possible for us to do that. But that is the kind of opportunity that we have when it comes to feedstock. And I think, when we started the white revolution in this country, we also had the challenges of supply chain. But today, nobody talks about the supply chain issues in the milk industry. And we have become the number one country when it comes to milk production. And this has happened in 40 years. 1981 is when we really, Koreans started the whole thing. And in the bioenergy sector also, it is possible for us to become the major supplier of energy and feedstock that is probably required for the rest of the world also. So when it comes to feedstock, I am very positive about it. It's not really a negative story in India. It is a positive story with the right interventions. And of course, on the second generation, we were supposed to put 12, 4 are being fast tracked, and 3 of them are coming with Prash technology. And one other plant with bamboo as the feedstock is coming with Chempolis technology from Finland. As he mentioned, IOCL plant has been commissioned. We are looking forward to a day when you really take it to 100% capacity production, and that is when the investor confidence really in the technology really goes up. But let me tell you, when it comes to second generation ethanol, we have already become the world leader. Across the globe, people have set up this plant and they have withdrawn. Basically, some of the technology challenges that they had, they could not overcome. But in India, we have overcome all the technology challenges that we have. And the challenge that we have is how do we really bring down the capex and the operating expenses. I think that is where people like Praj and a whole lot of organizations have been working on that. And I am telling you that once we build about 5 to 10 plants, the second generation ethanol will be on par with first generation ethanol. It's going to happen in this country. Well, this is the Praj picture that I have. This is the 12 ton per day kind of a demo plant, which is very close to Pune. And this is the other picture of the Panipat plant that Praj has built for IOCL. Another picture of the distillation column, I would now, when it comes to sugar mills, I talked about the capex and opex and all that. This is something that can be brought down considerably, basically making use of some of the infrastructure that is already available in the sugar industry. You have fermenters, you have distillation column, you have a lot of utilities that are already available there. Now, it is possible for us to have the second generation technology as a bolt-on technology to the existing plant, and that is going to help bring down the capex considerably. So this is something that the sugar industry has to seriously look into. And another area is on the enzyme. If when you talk about the operating cost, when the cost of ethanol coming from the second generation, almost 30 to 35% of the cost is enzyme cost. And we are today importing that. So we initiated some work, multiple initiatives in 2017-18. Today, we have enzymes which are being developed within India and, at very competitive prices and without compromising on the quality. We are able to deliver the same kind of, performance that, where is it? Okay. Performance that the multinational company has been able to provide. So these are all the factors which is really going to help us bring down the cost as we move forward. And the other thing that is going to make the whole second generation ethanol sustainable is the kind of byproduct valorization that is possible in the entire value chain. Lignin comes in as a byproduct, and lignin can be one is currently in all the 2G plants, lignin is being burnt to generate the heat and steam that is really required for the process. But as we move forward, we had to think in terms of converting that lignin into much higher value added products. And incidentally, Praj has the technology to convert that into lignosulfonate and also biobitumen and things like that. Biobitumen as a binder, can fetch much higher revenues than what you would get when you burn the lignin. So these are all the kind of possibilities that are there in the value chain, and if we are able to focus on that and develop those kind of technologies and make them commercially viable, I'll tell you that's how the second generation is going to be competing with the first generation ethanol in the coming days. He talked about the sustainable aviation fuel, and we took a lot of initiative way back, almost about 1.5, 2 decades ago in this area. There were several institutions which were, which had joined hands. In August 2018, the first flight, you talked about the first commercial flight. We were talking about the first test flight that was flown from Dehradun to, Delhi. Incidentally, I was also on the flight, and this flight, we blended up to 25% of sustainable aviation fuel and one of the engine. it was produced from jetrofoil. So, the technology that Praj and Gevo has is from the ethanol route. Ethanol can be converted into isobutanol and isobutanol to sustainable aviation fuel route. But I was talking about the HEFA route where, any kind of oil can be converted into biodiesel and other aromatics. Now, today the technologies are there. Now we have to think in terms of how are we going to really commercialize it. On this, government has been working on some kind of a policy framework which is in alignment with CORSIA. CORSIA is an international agreement on how to really bring down the carbon footprint in the aviation sector. There are certain targets. Government is working towards it. Government has already announced a blending target of 1% by 2027 and 2% by 2028 on all the international flights. And let me tell you, if we can put our heads together and make use of our resources and the kind of technologies that we have developed, this is not a difficult thing to achieve at all. And I think, we will be able to go much beyond that. And that's the picture of the first flight which we took from this. And I'm competing with you. You had one minister. We have 5 ministers here receiving us. So on the biofuel sector, if you really look at this chart, there are different types of wasted resources. I mentioned about the agricultural residue. You have spent wash, pressed mud coming from the sugar sector, MSW, sewage treatment, the sewage, and then recoverable animal dung. That itself, it's huge. If you really look at it, it is possible for us to, if all this is available to us, we can generate about 60 million metric tons of compressed biogas. Incidentally, I just want to share some statistics with you. The total consumption of all sorts of gases today in the country, whether it is compressed natural gas, LPG, whatever, everything put together coming from all the fossil sources is something like 45 million metric tons. And out of that, almost about 25 million metric tons is being imported into the country. And if you are able to achieve this, 60 million tons, you have 100% taken care of your requirement, and then, you have more to export it out of the country. And in the process, you generate about 370 million metric tons of biomanure. It's a compost, excellent manure, which can replace 100% of chemical fertilizers that we have been consuming at this point of time. And that's the kind of opportunity. And in the Sataj program, we said, okay, let us just look at, in the first phase, only about 25% of that opportunity. Instead of 60 million metric tons, let's only look at 15 million metric tons. And that itself will replace 75% of the import that we are doing and almost 35% of the total consumption of gases in the country. And, we had a target, ambitious target to set up 5,000 commercial plants by 25-26. But, it's not happening because we lost some time because of the COVID in between for 3 years. But let me tell you, I think in the next 1 or 2 years, we are going to have about 750 plants becoming operational. And by 2030, we will have those 5,000 commercial plants in place. So, there are issues with regard to offtake. You talked about the infrastructure part of it. The pipeline infrastructure, government is yet to announce a policy, but they have finalized it, where from the CBG plant to the nearest, CNG pipeline, it is possible for you to have a pipeline and inject it into the pipeline. And for that, 50% subsidy is going to be given by the government for up to about 75 kilometers of pipeline. So that's going to be a big booster for the CBG sector. Then you do not have to worry whether the oil marketing company is really lifting it or not. You produce it on a daily basis. Every minute you are injecting it into the pipeline and your revenue comes. So there is no worry about the marketing part of it. So that is the kind of ecosystem that is evolving. And also on the manure that is going to be generated, we have a lot of challenges because, you cannot compare it with the chemical fertilizers because, your nutrient content is low here. And then, the basic advantage with this is, you have the organic carbon which will go back into the soil. Right now in our agriculture, we are not replenishing the carbon at all. So this is where you have so much of organic carbon which can go back into the soil. And you also have certain nutrients. it is also possible for you to do certain fortification of this manure so that it can 100% replace the chemical fertilizers. So we have a huge opportunity in that area. So when you talk about CBG, it is not just the the biogas. We are also talking about manure, which could be an additional revenue stream. And the third one is carbon dioxide. We have to work on the carbon dioxide valorization and see, how we can monetize on carbon dioxide, because every plant is going to generate 65% methane and 35% CO2. If that can be captured and if that can be monetized, there are 3 sources of revenue. And the fourth, there is one more, which is the carbon. You mentioned about the carbon also. The market is emerging. Government is coming up with policy. For every ton of carbon saved, there is going to be some kind of an incentive that is going to be offered. There are incentives available in European and North American market, but we are going to be putting up a program here, and Ministry of Petroleum is already working. We are trying to make it very simple. For every ton of gas that you produce, you get earn credit. So simple as that. No complicated calculations and things like that, and there will be an ecosystem to market it within the country. So the policy is emerging, looking at the infrastructure that really needs to be created, how the industry needs to be incentivized, and how do you really create the ecosystem for marketing all this product. Everything is evolving at this point of time. And interestingly, this is the food waste to biogas plant in Pune, in the city. I think probably a few kilometers away from where we are sitting. And they process about 300 tons of food waste and produce about 13 to 14 tons of compressed biogas on a daily basis. And this is one, from paddy straw. This is one of the earlier plant that was set up, 100 TPD plant in Fazilka. And this is the first plant under Satat in Namakkal in Tamil Nadu, where they use press mud and poultry field. They use poultry field basically to increase the productivity. You have, probably 4.5% is the yield, the gas yields with press mud. With poultry feed, it goes up to 7-8%. So they use that combination there. And I think this is the most important slide. Currently, you generate humongous amount of bagasse, and most of the bagasse is being used for generating electricity. Now, the bagasse-based electricity used to fetch about 7 to 8 rupees per unit. But with the deployment of the solar, and I don't think any utility is willing to pay the 7 to 8. Once your per purchase agreement ends, you're not going to get more than 3 or 4 rupees for every unit. Then it won't be viable at all. There's so much of bagasse can be released to produce, ethanol, and that lignin can be used for power and heat generation, and further value addition is also possible, as I mentioned earlier about lignosulfonate, bitumen, and things like that. And of course, bagasse to CBG, you are talking about press mud, add a certain quantities of bagasse, and if the microbial consortium can handle both the bagasse and press mud, your gas production really goes up. So these are all the possibilities. Why I am insisting on this is, he talked about the feedstock related issues. The sugar mills do not have feedstock supply chain related issues, and the feedstock that is required for bioethanol as well as the CBG program, everything is available with you already. So now further valorization of this and adding value to that, there are plenty of opportunities, CBG as I mentioned. And then once you have the sugars, whether it is the sucrose or the C5C6 cellulosic sugars, we have the technology to convert them into cosmetic, chemicals, alternative materials, etc. And we did talk about the ethanol to sustainable aviation fuel through the isobutanol route. But there are other routes also now. Straight, you can get other products like, isoprene. Isoprene is, isoprene rubber has become a very popular product at the global level today. So that is going to reduce the carbon footprint considerably. Starting from molasses to any kind of sugar that you may have, today we have the technology to convert that into sustainable aviation fuel, isoprene, biorubber, whatever we are talking about. So huge opportunities are there. And of course, the carbon dioxide. In sugar mills, there is so much of CO2 that is generated in the fermenters. And when we are talking about the CBG program, almost 35% of gas that you produce is CO2. And from this, we have to think using CO2 to produce ethanol, CO2 to lipids and biodiesel, and multiple other products which are possible. So the horizon is growing. There's a huge opportunity for the sugar mills to look at. There are a lot of technologies which have been commercialized. There are technologies which are at the laboratory level, ready to be commercialized and things like that. You mentioned about the hydrogen. The bagasse can be used for generating hydrogen. I'm not even talking about the electrolyzer. I'm talking about gasification route through which you can generate hydrogen at much lower cost than the electrolyzers. So you have the resources. All you need is a gasifier and a proper filtration mechanism to get good quality of hydrogen. So there is a new world that is actually opening up, and this is something that the sugar industry has to seriously look into. With one short note, I just want to end my talk, and this is specifically for VSI to consider. Now, when we come to feedstock, one is the making use of all the available wasted resources. Second thing is to involving the farming community and to grow something. And then the third most important aspect is, the increasing the coming up with those kind of varieties. Looking at the productivity and looking at different application possibilities. This is where I think tremendous amount of work needs to be done. As I give you the example of Brazil, wherever I grow, where they have the energy cane. From the same 1 hectare of land, I think we have achieved close to 90 tons per hectare here. Now, the energy cane reduces your water consumption by almost 50%, 50 to 60%, and increases the production to about 180 to 190 tons. Now, the sugar percentage comes down, biomass goes up, but per hectare sugar production remains the same. It is not going to come down, but you would have generated more biomass, which means that the sugar mills may have to crush more cane to get the same amount of sugar, but then you will be sitting on two times more biomass, the 2 times more bagasse, which can be used for all the applications that I have been talking about. So the kind of research that has happened in the energy cane and things like that, I think needs to be looked at and replicated here. That is one area that VSI has to look into. The second area is, as the sector has been growing, the biggest challenge that we have is the manpower. We are not getting the manpower. So being a institution where you are training people, and you have to really look into the bioenergy sector requirements and have the right kind of courses to generate the kind of human power that is also required from this institute. And we have people like Atul Muleji who will be able to give you a lot of inputs on the needs and requirement of the industry. And I think that is another area I think you should really be looking into. Thank you very much for the opportunity.
So really thank you to Mr. Ramakrishna sir having nice talk. Now next speaker is Dr. Paul Bloom. Dr. Bloom is Chief Carbon Officer and Chief Innovation Officer of GEO USA. Prior to joining GEO, Dr. Bloom served in series of commercial and technical roles of increasing responsibility at ADM. Through his career, Dr. Bloom has successfully managed technology, business development initiatives from the idea stage to commercialization. He has authored more than 30 patents. I request Dr. Paul Bloom to give his presentation.
All right, it looks like it's ready. So sorry about the technical difficulties there, but wanted to say, first of all, thank you very much to VSI for this great invitation to be here and speak with you all about what we're trying to do. A really carbohydrate-based sustainable aviation fuel and chemicals, really trying to get to a future that looks like net zero, but even beyond that, how do we get to net negative? Because we need it. We are a publicly traded company, so I'll skip that. But if you haven't heard of Gevo before, we're traded on the NASDAQ. We were founded in 2005. We have about 100 employees, so we're still fairly small, but we have big dreams, right? And what you'll see here is that we're really all about how do we make drop-in replacements, starting with carbohydrates, right? Working with farmers, working with those farmers, working with energy partners to provide renewable energy. So we not only can use renewable feedstocks that have low carbon intensity, but we can also use the right combination of energy to be very efficient with renewable energy to convert all the way to make things that are net zero and net negative for the future. You'll see here just a few pictures that I'll call your attention to. I'm from the Denver, Colorado area. That's where our R&D facilities are located. So I have to say thank you, Pune, for great weather, because when I left, it was -20 C. So my family is very jealous, I can tell you that. And I may stay an extra couple of days. I don't really want to go back tonight. So you'll see also some of the other facilities that we operate. We have a what we call our demo facility. It's actually about a 75 million liter ethanol plant, but we also make about, we have the capacity to make about 4 million liters of isobutanol at that facility, both running in a side-by-side combination. And then typically what we've done in the past, we've actually, you know, a lot of firsts, right? Well, Gevo has a lot of firsts too. We were actually able to convert wood wastes into isobutanol then into SAF, and we did that at our fuel plant in Silsbee, Texas. It's a small plant with about 400,000 liter capacity, so we're excited to move beyond that capacity where we've been operating for many years into a net zero 1 plant, which is slated for South Dakota, a very small town called Lake Preston there, but it will be our first large-scale sustainable aviation fuel plant using carbohydrates, also making a lot of feed and food products at the same time. And then we're very excited. We talked about it. We heard about it, the role for renewable natural gas. We're big believers, right? We're big believers in renewable natural gas. This is our dairy manure biogas plant, about 400,000 million BTUs capacity, operational today. We just got done with our expansion, but we're partnered with dairies to basically pipe those together to one upgrading station. We put that in pipeline ready gas, but we didn't get into it for that. We got into it to make basically zero or carbon negative renewable biogas so we could repower our production facilities and get to very low carbon intensity for the thermal needs for those plants. And then the last thing that we have here is just a picture of our office we opened in Albuquerque, New Mexico for Verity Carbon Solutions. It's not just that we need to make sure that we can produce these products, but for our customers, for exactly the reasons for that we talked about earlier, heard about around how does government have the right measures and sustainability topics. We need to track all the carbon, right? We need to count the carbon effectively. We need to make sure that we can be efficient with that. So we have a new carbon tracking business called Verity Carbon Solutions. It's all digital, a digital MRV solution that we've been able to introduce. So that's just like Gevo as a quick snapshot. But what we really do, I'll call your attention to the left-hand side of this slide here. We're focused on working with farmers first, right? But we're putting the whole business system together from the farm all the way to the fuel that goes on the wing of the aircraft or the chemical product that ends up in durable goods in your home today. So we really need to make sure that we start with the farms, that we can make sure that every chance we get, we're always pulling out the protein and the nutrition, putting that in the food supply, but then also using the rest to go forward with sustainable fuels. We're really focused on using carbohydrates. We use alcohols as intermediates, both ethanol and isobutanol. And then we go through chemical conversions, things that look more like what a traditional petroleum refinery or petrochemical company would look like. So we always are combining the best biotechnology with the best in catalysis to put together to make the fuels and chemicals. Again, drop-in fuels and chemicals. No need for us to redo what we need to do in an engine. We can drop in the SAF, we can drop in those fuels, we can drop in the chemicals. So think about things like ethylene, propylene, butenes, all those useful chemicals that we're making. So that turns into our four basically businesses that we have. Our Zero Fuels, which is focused on delivering SAF, renewable diesel, and naphtha. Our Zero Chem, which is both isobutanol and ethanol into chemicals like isobutylene that was mentioned earlier, and ethylene, propylene, other butenes. So we're very excited about this. I'll talk about it a little bit more. Then we have the Verity Carbon Solutions, like I mentioned, and our RNG business, which is active, that we just got done expanding and is a revenue generating business for Gevo, being still early stage. That's really important that we now have a very stable revenue generating business, and we're very proud of that. So why are we here? Why is this so important? Why is it so important to talk about what we're doing? I just wanted to bring this up. I found this really interesting when I was doing some research earlier for another talk too, that how much of the world's energy is actually renewable or zero carbon energy. And from the mid 1960s till basically today, we've got to about 20%, right? It's gone through ups and downs. There were some, delays in some nuclear energy, but other things like hydroelectric started to take over. Wind and solar have been on the rise now to take up where we stalled for a little bit. And I felt pretty good about this. I said 20% renewable energy. That's an accomplishment. Unfortunately, when you still look at what happened over that same time period, the world's appetite for energy in general went up fivefold, right? So we still saw this, we still see, and it's hard to see here on this slide, but we still see an increase in the overall output of CO2 equivalents across the board. So we need to get to that inflection point where we can go backwards. That's why it's so important for us to say we want to get to net zero solutions and actually net negative solutions so we can start to move backwards on this. It's also, I was here in Goa for the Clean Energy Ministerial back last year, which was a great event. But one of the other things that is really important to us is what we can't measure, we can't improve. That was the theme of a seminar that we had at that event. Really great, because we do need to be able to track this. We need to be able to prove it. We can't take that for granted and make sure that everything that we're doing is really making an impact on this big need that we have here for this need. So when we think about what do we need to do, the good news is that we're fairly well, we have a lot of this in hand. You heard this from the earlier talks, that we have a way to get to economical drop-in replacements, things that we can use today in the infrastructure that we have. We have options, and we're implementing them for defossilized or zero carbon electricity. We need the accurate carbon accounting, which we're making progress on. We still need to harmonize. We still need policies that come together to make sure that this happens. We need scalable technology. So it's great that we have partners like Praj who can do this and scale technologies, but we still need financing. So that's the stage that we're in today with our plant, and you'll hear a little bit more about this. So, this has been one of the areas that continues to, these things aren't free. These are big capital investments. And so definitely need to continue to get investment to make good on the carbon goals that we've set for the world, basically to make these challenges good on these challenges. So on solutions, right? When you think about what Gevo is doing, this is probably really simple, right? But we like the simple. And what we've been doing for so long is not only using carbon as our source, but we've been using process energy that's also fossil based, right? So both of those things have to be resolved. We have to use renewable feedstocks that can be low carbon, and we need to use low carbon energy to power those facilities in order to make this happen. And if we do this the right way, we're not only, potentially being able to get that down to net zero, but through the right sustainable practices in agriculture, we can actually take more carbon out of the cycle by avoiding carbon emissions, but then going beyond that and actually building carbon in the soil, right? Using soil, you think about that as a way that we can sequester more carbon. And then, of course, we need to use that renewable power to power that, and use, a number of different things, carbon capture and sequestration. Ethanol is perfect at this, has a naturally concentrated stream of CO2. So that's a big part of our plan in the US. But then when we finally make that fuel, after it's burned, we think we can get to a lower output of CO2. We can actually take more CO2 out of the environment than we put back in. This is our version of the circular economy at Gevo. It's really about this whole business system, and this is what you see us investing in. So starting with farmers, working with farmers, rewarding them, paying them a premium to provide low carbon intensity crops, which can also be done with sugarcane. We use carbohydrates broadly, as we'll talk about a little bit more, but we take those feedstocks in. We also separate out the food and the fuel components. We repower the plants with things like wind and biogas, but it circles back around, right? Because a lot of the co-products that we make actually go to dairies today. The same dairies basically that we're working with to take that dairy manure biogas and capture that gas and upgrade it to pipeline quality. And so you can see that it's all these different circles together that help us go from where we're at today with fossil GHG emissions, not only to zero, but where we think we'd be using the right combination of soil carbon sequestration and CO2 sequestration from the actual fuel production process, that we can get to that net negative solution. So when we put it all together, right, this is why it's really important for us to think about how do we measure everything holistically. So we start in the US, we always wonder, how come this hasn't happened yet with the ethanol industry? So we use ethanol to jet technology today, but we need to track it all. But if you think about just using an ethanol plant that basically makes ethanol with grid electricity and regular natural gas, you would come up with something that looks a little bit lower. So this is the carbon intensity score measured by Argonne GREET. So you can see that about a 70. If you then use an alcohol to jet technology and power that with that grid electricity and natural gas from the grid, you still have to condense. What we have to do is take ethanol and up its energy density, because we need energy dense liquids for the wing of an aircraft. So that costs energy to run that process. If we did nothing to decarbonize the overall system, we would end up with a renewable solution that may have a carbon intensity that's not as good as the fossil-based alternative. So in order to do this, this is what we put together. This is the system that we're deploying today for Net Zero 1, where we use defossilized electricity. A lot of benefit comes from the integration of ethanol and ethanol to jet to drop that overall carbon intensity and be very efficient with the energy that we use. We also use renewable hydrogen. It's just a small amount of renewable hydrogen. We use CCS, so you can see all of these things are moving us back to negative. But the biggest lever that we think, and are the ag practices and the potential soil carbon sequestration. We have it listed here as a potential -30 on the CI score. We think it can be much, much larger than that. So this is going to be really important for us as we go forward. But again, this is how when we talk about it, this is how we get to a negative potential fuel, even after it's burned. What's important? Well, it's really important that we use non-fossil based carbon feedstocks. And we think this is the solution. Carbohydrates are really what we're doing, but you've seen a lot of companies announce power to liquids technology, basically capturing CO2 from the air, using enormous amounts of power, then to convert that CO2 all the way back into hydrocarbons, right? Taking something very stable and putting all that energy back into it. Well, we think the best thing to do is to use photosynthesis. Photosynthesis and these carbohydrate products, it's the best direct air capture CO2 project out there, right? It's fantastic. So we want to use the sun. We want to use what is out there to actually capture most of that energy, so we can only add what we need to make our fuels. Just really quickly, when we compare this, if you just think about a pure power to liquids play, going from CO2, adding all of that hydrogen to get to the structure here drawn as just a C12 jet fraction, you're going to basically put in more energy per gallon than you get out. So that doesn't seem like the most sustainable solution. But if you put everything together, and I don't care if it's an alcohol to jet route or a HEFA or a vegetable oil based route, you're still getting the benefits of photosynthesis. So think about that, and this is really in a general case, but you get a net gain of 90,000 BTUs per gallon instead of a net loss, right? So again, it just shows the power of harnessing photosynthesis, the importance that we work with agriculture and use agricultural-based feedstocks. So then can we compete on cost, right? So when we think about a cash cost basis, and this just shows you that here's the price of jet fuel. This is a very US-centric slide, and West Texas Intermediate shows you where the blue dots are all where petroleum-based products have been. But we think that alcohol to jet and HEFA really can be competitive in these cases. Direct air capture, however, when you look at that and all that energy that we just talked about, that's going to be a much more expensive and less efficient type fuel to produce. So good news is agriculture has a big role to play in how do we repower, how do we have SAF as a lead. So we think that the sustainable aviation fuel in general represents about 3% of all global emissions. Gevo has about 3 billion per year which is 400 million gallons a year of signed take or pay offtakes. So the demand is there. We need to get going, right? We need this investment. We need to make sure that we can be building these plants. It's great that we have amazing partners like Praj and Axens to get these things done. So our plant that we're working on today, we've brought together the integrated process technology where we can cut out about 70% of the overall thermal needs from the design process. And we're working closely with Praj and Axens to get this done, to deliver this, and then of course counting all the carbon. This is what it looks like today. If I showed you a picture, it would look like a big empty space, but we've broken ground on it, but we haven't accomplished everything we've wanted to on the show you a real picture yet, right? So that's slated for 2026 when we can have this. Again, we take in renewable carbohydrates and make all these products. We actually make more feed and food products out of this in a sustainable fashion than we do fuel on a dry matter basis. So we're really proud of that. All powered by hydrogen, renewable wind, and zero carbon energy and RNG to make this a reality. Then we have to track it. Again, we have to track it, but we also have to reward those who contribute to lowering the overall carbon intensity. So we pay farmers a premium. We work directly with farmers, and we will be putting this all together. We started this program about 3 years ago, but we track back to their farms, and so every bushel that will be coming into our plant, we anticipate, we track, we score, and we reward them on a performance basis for the carbon intensity that they're able to deliver. We've got a project pipeline, but we're really working on getting the first one going. And just in efforts of time here, because I'm running a little long, the good news is, and what's really exciting to us is alcohol to jet. When you look at this, we expect it to be the major pathway for sustainable aviation fuel. And if you just look at the chart, what you can see is the combination of crop-based fuels of ethanol to jet and cellulosic is really where we think that most of that growth is going to be, both from corn and cellulosic and obviously sugarcane. HEFA definitely has a place to go, but you can see how it somewhat levels off, and that's because the waste-based HEFA feedstocks are fairly spoken for, right? They're all used up today between renewable diesel and the SAF projects that have been announced. So not much room for growth, especially from the waste base, but huge opportunity for carbohydrates with alcohol to jet pathway going forward. And what I'll end with really quickly is just, it's not all about sustainable aviation fuel and drop-in hydrocarbon fuels. We're really excited about our potential to make net negative carbon materials, right? The durable goods. Think about the circular economy. Now we can think about how can we take ethanol, and with our proprietary production, we call it ETO, ethanol to olefins. We can make a suite of ethylene, propylene, butenes, and pentenes in basically one step. We're starting to pilot it, but we did partner with LG Chem on the chemical side of the business. This is great feedstock, not only for fuel, but for chemicals to make these durable goods, and then use all the different opportunities like I just talked about to actually hit very carbon negative materials when you use renewable energy, when you use carbon sequestration, when you use sustainable ag to make this a reality. So I will cut a little short with that and end. But thank you very much for the invitation to be here.
So next speaker is Mainak Chakravarti. Mr. Mainak Chakravarti is the CEO and co-founder of GPS Renewables. GPS Renewables is a bioenergy company that is working on biofuels, namely biogas, bio-CNG, ethanol, and green hydrogen. Mr. Chakravarti had been named as one of the top Indian innovators under the age of 35 by MIT Technology Review. He is the member of several committees like Bioenergy Advisory Committee of MNRE, Grant Reviewer under BIRAC. So now I request Mr. Chakravarti to give his presentation. Thank
you. Thanks, Dr. Kunde. First and foremost, thanks for inviting me to this stage, where there are a lot of veterans from the industry that we look up to. Obviously, Dr. YBR sir, Atul Mule sir, and all. So for all those who don't know me, my entry ticket is the picture that you see on the screen. So that is Asia's largest bio-CNG plant based on MSW. It also happens to be India's largest operational bio-CNG plant, or RNG plant as we call it. This is in the city of Indore. This was inaugurated by the Honorable Prime Minister of India a couple of months back. I'll be talking more about it. In general, my intention is to share some insights from the field, not just Indore, but other agro-residues based plants, and maybe try to draw some relevance for the sugar industry. So this is the agenda that I have kept. First and foremost, maybe why bio-CNG is important for India. I'll not spend too much time because my seniors here have already spent a lot of time on that, on aspects related to why this is important for India, the climate aspects. So maybe I'll talk more about, again, on some notes from the field, and another very important aspect, which is money. We all have to make money, and maybe I'll talk about some numbers again from the field. Finally, what are the right models for the sugar industry and going beyond PMC? Now, before that, very quickly, I'll just touch upon who we are, just to set the context. I'll not spend much time, just one slide on that. Now, just to give an overview, GPS Renewables is a biogas technology and EPC firm. I'm the co-founder and CEO of the firm. This is a company that had started right after graduating from IIM Bangalore. Today, very proud to say that we are executing projects worth around 2,000 crores, that is $250 million. We are sitting on a pipeline of around 4,500 crores, so north of $500 million in all. I say this not to market ourselves, but to talk about where this bio-CNG industry is headed. And this is, I'm talking of a company that we had started literally from scratch. And again, thanks to all the policy interventions and all, and especially due to the efforts of people like YBR sir and all, that is what many of us are actually witnessing on the ground today. In terms of the track record, as I mentioned, we have commissioned Asia's largest bio-CNG plant. Very recently, we commissioned what is the world's fastest executed CBG plant. This is for Reliance Industries at Barabanki. This is the project that Mr. Mukesh Ambani had spoken about in the last Reliance AGM. We have a very strong R&D team with multiple patents. I have some of my senior colleagues out here in the audience, such as Dr. Rana De sir, who was ex-director of Agarkar Research Institute, Dr. Gore sir, again a veteran from the alcohol industry of India. We are around 375 members strong. We are the first Indian startup to have raised private equity funding in this particular space. And finally, we are co-developing projects as well. We have a joint venture with IOCL. Now, moving on to some notes from the field. This is the project I was talking about. Now, some interesting insights for all of you could be, this was, we had a lot of learnings from this project. When we started working on this project, the ecosystem hardly existed in India. In fact, even today, it is still developing. So despite that, very proud to say that we were able to cold commission the system, reach in 9 months and reach COD in 15 months. This was despite the COVID second wave, the Suez crisis, and record rains and all. I mean, this gave us the confidence that it is possible to maybe achieve COD in 12 months. And this is something which we have already achieved for our partners such as Reliance. Second thing, I mean, we were able to, despite the speed, we were able to do this without any incidents and all. So with a 100% HSC track record. Finally, and most importantly, talking about the financial aspects, here we have been able to consistently generate more than 100 cubic meters of raw biogas per ton of MSW. Of course, it is a function of the quality of the waste and things like that, but it was again a very important benchmark. Today, as I speak, it is generating around 15 to 16 tons of CBG, and it took us a year. Having said that, it did not happen on day one. We had a lot of challenges such as sand and silt, as I mentioned on this screen. But again, and this is a reality of India with so much construction happening. Talking of PMC, you might not have the right pads everywhere. A lot of sand and silt may creep in along with the feedstocks and all. Things are never ideal out here in our country. Having said that, what I can say with utmost confidence is that it is possible to run plants despite all of that consistently. Again, similarly, VPSA, we had faced a lot of challenges on the biogas upgradation side. Having said that, again, we were able to fix many of these issues in-house. What we can say is that it's not rocket science. It took its own sweet time, but today, as I say, I mean, we are running multiple plants with almost 100% uptime, and this is across multiple feedstocks and all. Similarly, talking about Barabanki, the project that I was talking about, this is a plant that runs on a combination of paddy straw, press mud cake, and cow dung. This was cold commissioned in less than 9 months, and the COD was achieved in less than 12 months and all. We introduced a number of new, ideas in this particular project, which is now being replicated in many other projects across the country as I speak. So one was introduction of slip form for erecting of digesters and all. It's not a new concept otherwise, but in the CBG space, in the bio-CNG space, we took a leap of faith and tried this. Today, again, what we can say confidently is that we can erect tanks in just 3 days. The shuttering and all does take time, but as far as the actual erection is concerned, I mean, we are actually doing it in less than 72 hours and all. Another thing is that as a part of this project, we introduced membrane-based biogas upgradation units, which we manufacture ourselves. We have a partnership with Ube from Japan, and we are consistently reaching methane purity levels of in the range of 98 to 99%, and which again, I'm sharing this from the perspective of the industry that, and it's not just us who are doing this. Today, I mean, we are seeing tremendous changes happening, not just on the policy side, but in terms of developments on the field through be it us or many other companies, of course, needless to say, such as Praj and other technology and EPC companies in the sector. Now, that's a bit about us and some notes from the field. I'll skip this particular these slides which talk about why this is important for India. A lot has been spoken about. Maybe just touch upon one part, which is while the initial uptick, it took some time for Satat to heat up and all. Today, we can see that happening. That is how industry starts. That is what I'm told. I'm not so old, but that's what I'm told. But I can see that happening. As we speak, we command a significant business of Reliance Bioenergy's compressed biogas projects today, and we know firsthand that already many of these numbers are committed. Someone like Reliance has already committed around $1 billion in this industry. The PSUs, most of the PSUs are coming up with joint ventures and all. IOCL, as an example, did already have a joint venture with Praj. Today, they have a joint venture with us as well. And there are many other project developers who are coming into the sector. As we speak, we are already seeing commitments worth a few $1 billion that have already happened in the CBG sector. Finally, what gives further push are the various policy interventions which have already been spoken about. The most important thing are trends. In general, lots of these tremendous changes have happened in the last few months, and which I feel is amazing because normally such things take years and all. But here we are seeing massive movement as far as different departments coming together to make bio-CNG happen. Now, some relevant, numbers as far as the sugar industry is concerned. So here, I mean, sharing some a standard sample financial model for what what could a typical bio-CNG plant look like for a sugar mill. Now, again, before getting into that, one disclaimer. Excel sheets are like video games. They are addictive. Things are very different when you are doing this on a keyboard versus on the ground, which is like a battlefield. So there are lots of moving parts. I mean, things would always be different on the ground, but these are numbers that we can confidently talk about with a certain degree of confidence based on what we have seen on the ground. Now, here what I've taken is a sample case of a 12,000 TCD sugar mill. Now, and again, there are some standard assumptions around how much press mud cake can be generated and all. We are talking about approximately 240 tons of press mud cake generation, which, assuming a typical 4% yield or so, 3.5 to 4% yield, we are talking about CBG generation of in the range of 9.6 to 10 tons per day. Now, considering some standard market assumptions and all, this is what maybe, like the ROI, some of the key metrics that could look like. Now, while there are a lot of moving pieces and all, goes without saying, the price of CBG, one of the most important pieces. At what price one can sell the compost FOM, that's another major driver. But leaving that aside for a change, capex is a very important aspect as well. So here you can see how the ROI changes for various numbers and all. Again, we are talking of roughly a 10 TPD CBG plant, and different scenarios ranging from 45 crores to 70 crores. Essentially, what I'm trying to drive home the point is that what should be the right capex in terms of per TPD. As you can see, as long as it's within, say, 50 CR, so as long as it's ideally within 5 CR per TPD, numbers look fine as far as banks are concerned. If you look at the DSCR ratios and all, things are fine. As we go higher, around 6 or higher, numbers are a bit shaky and all, and this is at a 70-30 debt equity ratio. These are discussions we cannot avoid. These are some things banks inevitably they will look at irrespective of whatever the government pushes. Now, the key point is that ideally, the capex for a CBG plant should be around 5 CR and ideally not go beyond 6 CR per TPD. Now, this in the sugar industry, we believe it's difficult to achieve below a capacity of 9 to 10 TPD. Now, there could be ways to cut corners and all. One can set up plants. There are various pathways of setting up CBG plants and all. There are so many technology pathways. There are so many pathways for biogas upgradation and all. But if one were to do it with proper technical integrity, I mean, 9 to 10 TPD is what we feel are the ideal numbers and all. So these are few numbers that I'd like to share. The other thing is, again, from our own experience, what we can say is that as far as paddy straw is concerned, we have already been able to bring this number below this particular threshold. Having said that, that's at a much higher scale. We are talking about 20 tons per day scale and above. As far as press mud cake is concerned, I mean, many players are already in the range that we are talking about. Expecting anything below that would be, might not be very realistic, but this is very much doable. So the key point is that it's important that, if anyone is a project developer, you should try to ideally look at the scale around that 10 TPD scale. Now, in terms of what are the various models that one can look at while setting up plants? One is, as I mentioned, ideally maybe 10,000 TCD. Now, this might not be the case with many sugar mills. So that's where maybe the idea could be to club multiple sugar mills and all which are in a geographical vicinity. Number of people are already doing that. Ownership. Now, it's again a function of, at the end of the day, what is one's risk appetite from a sugar mill's perspective, how is their balance sheet and all. There are today various models out there. There are a lot of project developers, climate funds who are coming to the sector, who are happy to invest in these plants and all. One can co-own plants and all. And as we speak, all these models are today coexisting. Again, similarly, PMC pricing. Either one can go for a long-term, price offtake. This is definitely a low risk, low upside, model. The other thing is that pricing, there are also cases where people are pricing, and we have done that, where the pricing has been indexed to the bio-CNG prices not. Having said that, the higher potential upside comes with a higher risk as well. There could be a downside as well. So, and people have also integrated, the PMC cost in the form of sweat equities and all. But these are a few models which are happening as we speak. And finally, BioCNG offtake, right from own retail outlet. That's the beauty of the Satat and the BioCNG policy in India, to private take or pay agreements, to Satat or grid injection, as YBR sir and others talk about. These are the various models out there. At the end of the day, as I mentioned, it's a call that one has to take. But there is enough material out there in public domain, that one can refer to. But as long as some of these key numbers are adhered to, we feel that this is eminently doable. Final slide. Now, PMC is the starting point. It's a very easy feedstock to deal with. But again, as other speakers also have spoken about, there are massive possibilities beyond that. Now, there are, again, the numbers that I show are based on certain assumptions. But the key point is that if you can see the potential CBG that can be generated from other, some of the other aspects of the sugar industry, such as bagasse or cane trash, could be much higher. Having said that, it has its own challenges and all. Pre-treatment is a key challenge. And we believe the holy grail is a cost-effective microbial pre-treatment. That is where institutes like VSI come in and all. And and that is why I think India could command a leadership, given the huge biosciences community, given the leadership of organizations such as BIRAC and all. But we believe that could be the way. So I'll stop here. So that's it from my end. Final point. All I would like to say is that BioCNG or CBG here is definitely here to stay. And I think if anyone has doubts, I'd like to say that it is one of the most tangible biofuels out there. It is already competing with its fossil fuel equivalent. So if someone is in doubt, you should definitely think about investing, be it your money or your time, into CBG. As far as we are concerned, we are a very proud Indian company. We are already have Indianized 95% of our supply chain. Our import component of the projects that we execute is less than 5%. So we are always open to working with Indian equipment suppliers and all. So if we cannot meet, happy to connect on LinkedIn elsewhere. And the final point is that for equipment supplies from outside of India, my only suggestion would be that the action is here. Maybe you should set up shop in India. Otherwise you might not be so competitive in the future. So that's about it. Thank you. Jai Hind.
Our next speaker is Professor Sanjay Patil. Professor Patil is working as a Professor Emeritus at VSI. He has been having more than 40 years experience, including 38 year experience in VSI on 1G ethanol project. He has been involved into R&D activities related to 1G, 2G, value-added products and biofuel. And he has been nominated as member of the different committees like CPCB, MPCB, Punjab Federation, State Excise, and he has published more than 100 papers. I request Professor Sanjay Patil sir to give his presentation.
Thank you very much, and good afternoon everyone. Good afternoon all the delegates, the guests here, and my students. Let me first thank the organizing committee for giving me the opportunity to make a presentation on this important topic in this August gathering. Of course, most of you will agree with me that production of ethanol in our sugar mills today is a very important aspect. It is like our bread and butter, and that has helped us in last few years to survive financially in spite of producing surplus sugar cane. So before I start, I would like to inform Mr. Uday Patil and Dr. Gore. You asked few questions yesterday. Probably you can find answers to your question in this presentation. This is the brief highlights of the ethanol blending program. I will not go into the details, but unfortunately, in this year, the sugar production in the country has reduced, and it is going to be about 31 million metric ton after diversion of about 1.7 million metric ton of sugar for ethanol production. In the last year, after achieving the blending of 12%, the government of India was able to save almost foreign currency to the tune of almost rupees 24,300 crores. And in last 10 years, the oil companies have paid to the sugar mills for the purchase of ethanol to almost rupees 1,15,000 crore rupees. And this has helped also to reduce the CO2 emission to the tune of almost 42.6 million metric ton. I would like to bring to your attention the sugar balance, which is very important aspect. You can see in the table of sugar balance that in the last 2 years the government allow export of sugar, and that's why our surplus stocks were in a controlled manner. But as probably you know that this year the government is not allowing the export of sugar, and they have restricted the diversion of sugar to ethanol of 1.7 million metric ton. And even if we consider 31 million metric ton as the net sugar production and a consumption of as high as 27.5 million metric ton, we will still be having 9.8 million metric ton as a surplus sugar available with us. And if you compare this with last few years of surplus sugar, this is going to be quite high amount. I don't know why government is so panic about the sugar stocks, and I feel that government can still consider allowing us to go for higher diversion of sugar for ethanol production. Yesterday, the Honorable Minister Nitin Gadkari mentioned about the availability of the grains in the country, and I have tried to put a ethanol potential in this graph, and you can see that if the export is not allowed, right now the export of rice and even corn is not allowed, and if the export is not allowed, we have a potential of producing almost 12 to 13 billion liters of ethanol from surplus rice, and about 1 billion liters of ethanol from the corn. So the desired quantity of grain ethanol also can be produced from the surplus rice, corn, and also wheat in our country. I will not go into the detail of progress of ethanol blending program in our country. Mr. Ramakrishna has already covered this. It was very good going for last few years, but in the August 2023, government gave us a shock. They banned the FCI rice for the use of ethanol production, and again at the starting of December, they stopped they restricted the diversion of sugar to ethanol production to 1.7 million metric ton. This has put us in a real big problem. Our distillery have invested a lot of money in building their capacities, and really right now we don't know whether we will be able to achieve, we will be able to survive financially also. Mr. Ramakrishna mentioned that 15% blending may be achieved this year, but we are very doubtful with the restricted diversion of sugar. This may not be possible. Coming to the pricing of ethanol, this is unique policy, probably once only in the India that they have given differential pricing of ethanol based on the raw material used. But government was very good. There was a very good support, and you see that every year they were increasing the prices of ethanol. But in this year 23-24, they have not increased the prices of ethanol. You can see that for C molasses and for maize ethanol, they have increased the price. It is not the price increase, it is actually incentive. So this incentive may be taken back again in next few years. So we have to be very careful about this. But we are expecting that the prices will be revised in next few months. That's what the Honorable Minister said, that wait up to April and then we'll see what is going to happen. Coming to the use of BAV molasses for ethanol production, of course, BAV molasses has been a very good clean substrate as compared to our conventional C molasses. We have used it very efficiently. We were able to achieve 12 to 13% of alcohol concentration. There is absolutely no problem. We were also able to recycle spent wash to the tune of around 10 to 20%. And that's why we were able to reduce our spent wash generation also. But the main problem today, Atulji, is the stock of BAV molasses. You know, in our sugar mills, we have a lot of stock. Yesterday I was speaking to someone, he has 50,000 tons of BAV molasses stock. At today's cost, it will be 70 crore rupees. They don't know what to do. They cannot make ENA from it. And they cannot sell it also as C molasses because otherwise they cannot, take care of their loss in recovery also. So this is a big problem, and we will have to sort out this issue. A lot of sugar mills have already written to the DFPD, and we wait for their. I will skip this slide, but coming to the challenges with the syrup, of course, we are not familiar with syrup fermentation. In the initial phase, we faced a lot of problem. Syrup is not as good as C molasses or BAV molasses. There were a lot of problems. And particularly in Indian context, we follow the double sulfitation method, and therefore we have a lot of sulfides also. There is no buffering capacity, and we have faced a lot of problems. But slowly we have recovered from this. For the sulfide issue, we were required to increase our fermenter capacity, increase the retention time to around 50 hours, and try to minimize the sulfide content in the syrup. Of course, some of our distilleries have shifted to defecation. With defecation, the problem can be resolved in a good extent. We have been able to achieve 13% alcohol concentration, and that is helped us to reduce our spent wash generation also. With syrup, we are now using active dry yeast very efficiently. We have to maintain proper yeast count and transfer at least 15% of the free fermenter volume to the fermenter. The feeding cycle is one of the most important critical factor, and it has to be properly optimized. So we get residual sugar as low as less than 0.5%, and with syrup we have been able to recycle the spent wash to almost 40 to 50%, and that has helped us to reduce the spent wash generation. Coming to the issue of sulfide inhibition, as I told you, one of the solution is to go for defecation, and some of our sugar mills have already done this. They have set up a parallel defecation evaporation system, but in this case again our capex is increasing. But in the last few years we have also switched over to diluting the sulfited syrup with either raw mixed juice or clarified mixed juice or even secondary juice, and that has helped us to reduce the problem of sulfide inhibition to a certain extent. However, we are facing a problem of low pH in the fermented wash because the syrup doesn't have the buffering capacity, and the resultant rectified spirit is also very acidic, and therefore we have faced a lot of corrosion problems in our reboilers, PHEs and piping, and we were required to switch over in the MOC from SS304 to SS316. Coming to the challenges and opportunities in grain ethanol production, of course today the government is promoting corn. They want the distilleries to switch over from rice to corn. But the most important factor probably is going to be the quality and the price of the grains, at which the landing price and the quality also. I have seen in north the corn which is available is very bad quality, infested, and therefore it also affects the quality of DDGS. And in grain ethanol also, the fuel which is purchased from outside, it is also very important key factor in the profitability. So we have to control the price of the fuel which is available. And therefore the multi-grain feed systems are now coming up. So we can put either rice or maize or even wheat also. And there are high alcohol tolerant active dry yeast which are available, and we have achieved 14 to 15% alcohol concentration. And in future probably genetically modified yeast will be also made available, and with this one can go to up to 18% alcohol concentration. There are new generation of enzymes are also available, and with these enzymes probably we can reduce our energy consumption. And with new modern kind of grain alcohol plant, we have to go for lot of heat integration, so we can bypass the jet cooker. We can go for integrated evaporation, or we can use the dryer vapors to run the evaporation system, and even multi MVR systems are also being considered, and vapor phase ethanol production. So with this kind of approach, people are now talking about coming down to 2.8 kg per liter of ethanol production. Of course, with grain ethanol, there are opportunities to recover a lot of byproducts, particularly the food grade CO2. I'll talk about the corn oil and protein from rice also. And therefore, there are dual feed systems which are now being considered. And even with the molasses-based distillery, people are now thinking about going for integration with corn oil, corn wet milling systems, where apart from ethanol and DDGS, you can produce a lot of other products like the oil, de-oiled cake, gluten, dextrins, and starch also. So these systems are also being considered in the distillery proposals. This is the multi-feed system, a typical multi-feed system which we are proposing. Here you can see the fermentation, distillation, the evaporation system, the condensate polishing unit. They can be common, but the preparations are required for grain. You will require separate preparation. For syrup and molasses you will require, and on the downstream side again you will require dryer for DDGS, and either a dryer, spent wash dryer, or a incineration boiler for the molasses or syrup system. So this is one case study. We are working for 200 KLPD distillery proposal, and here you can see we are proposing two parallel 100 KLPD plant which will run on syrup at 200 KLPD capacity during the season, subject to government allowing us to use syrup. And in the off season, if the BAV molasses is available, it will run on BAV molasses at 100 KLPD capacity, and it will run on grain on 100 KLPD capacity. If BAV molasses is not available, then the distillery will run at 100 KLPD capacity only on the grain. So this basic concept in this this configuration is that the distillery capacity is decided based on the capacity of the sugar mill and the availability of the own raw material, plus the most important part is the availability of the fuel or the bagasse from the sugar mill to run it for 300 days. Coming to the byproducts from the grain-based distilleries, you can see that this is the first plant we established in Maharashtra. This is for the recovery of corn oil from maize, and this is called as front-end oil recovery. And you can see that before fermentation we degerminate or take out the germ, and then of course there is a refinery, and this refinery can produce good quality edible corn oil, and we are already selling this corn oil. So this is the probably first corn oil plant installed in a dry milling plant. Of course, there is a back-end recovery also possible in some of the US plant. This is being done, and what our friend Mr. Fernando explained, that one can go for the biodiesel production with the distillers corn oil production. There is also possibility to recover protein from rice. So this is one example that from rice DDGS one can recover protein. I will not go into the details of this, but again in this also there is a front end protein recovery also possible. I know one plant, one grain based distillery is now setting up a plant of a front end protein recovery. It is going to be a very high value product, and it can improve the profitability of the distillery. Coming to the challenges which we faced with the syrup is when we use the syrup spent wash, we get less biogas. Even the methane content of the biogas was reduced. We face severe problems in the scaling in the evaporation systems. The quantity of the effluent generated was also very less, and with the syrup spent wash, we had effluent which had very high fixed carbon and chlorine content, and therefore we had a lot of problem in treating this spent wash. Of course, we feel that the profitability will vary depending on the downstream effluent treatment system, and therefore today, apart from incineration, we are also proposing dryers, and now also there are potash recovery systems which are coming up. With syrup spent wash, our spent wash quantity is reduced as compared to the spent wash which is produced with CAV molasses, and that's why we face a lot of problems in the incineration boilers. But with C molasses and BAV molasses spent wash, our incineration boilers have worked properly. I have been advocating it. We have gone for differential pricing of ethanol, and we are using different kinds of raw material to produce ethanol. But we may have to also go for allowing us to go for some new effluent treatment systems. So with syrup, if the spent wash generation is very less, probably we can go for direct composting in the season, and that we have tried to represent in many forums, but at present it is not allowed. We have to go either for incineration or drying of the spent wash from the syrup. With energy and for water conservation, already in some of the presentation this has been covered. We can go for air-cooled condenser where the water consumption can be reduced. There is no requirement of water treatment. There will be no effluent generation also, and the operation and maintenance cost is going to be less. With the new restrictions coming on the fresh water consumption, probably many of our distilleries will have to go for this air-cooled kind of condensers in the coming years. Of course, there will be more capital requirement. It will require higher electrical load. So these are the systems which are already getting installed in our distilleries. We can go for MVR based evaporation and distillation systems also. MVR based evaporation system are already installed, but now people are also talking about the MVR based distillation, where you can reduce your steam consumption from 1.8 kg to almost 0.5 kg per liter of ethanol production. So that is also possible. This is one more case study where we are working for a dedicated juice to ethanol plant, and here we can use the vapors from the juice evaporation to run the analyzer column. We can also go for the rectifier working under the MVR, and we can go for multiple MVR also for the spent wash evaporation. So this kind of system will reduce your energy and water consumption in future. VSI has worked on the extraction of potash from the incineration boiler ash. We already have one pilot plant which is running in VSI campus, And here you can see that we can recover potash in different forms depending on what is your requirement. We can produce either solid K2SO4, solid MOP, or liquid products also. And here our potash recovery is more than 94 to 95%. Coming to the last slide before conclusion, this is one more technology which is now available and it is approved by the MOEF and CPCB, and it is for the recovery of potash and depotash vinasse from the molasses, and it is a zero liquid discharge system. It is installed in one of the distillery in Maharashtra, 60 KLPD distillery. So here you can see that from a 60 KLPD operation, you can recover almost 45 tons per day of depotash vinasse, which can go as animal feed, and it fetches a very good price. In this case, the FCO grade potash recovery is around 3.3 ton per day, but you can further purify this FCO grade potash into K2SO4 also if required, and you can get higher price. So finally, coming to the conclusion, with this background, I can say that considering the sugar balance in the country, higher diversion of sugar of about 4 million metric ton is still possible, as government has banned the export of sugar, and still 2 months are remaining, so government can consider this very seriously and can allow us to divert more sugar because B-heavy molasses and syrup stocks are already there with our distilleries. So in future, whenever there will be surplus sugarcane available, it will be definitely possible to divert substantial quantity of sugar through ethanol production from syrup and B-heavy molasses. And this is the probably answer to the question which was raised yesterday. Multi-feed distillery concept is now emerging as an important option. We can use syrup in the season, B-heavy molasses, or grain we can use in the off season. I know few distilleries are now this year will be crushing sweet sorghum also on trial basis, and of course sugar beet also is being proposed for extra after season operation of the distillery. For higher distillery capacities, multi-feed mode with own fuel and appropriate steam balance will be required. Profitability will vary depending on the downstream effluent treatment system. Incineration route is not really suitable when syrup is used, and incineration is a very costly affair today, and there are a lot of corrosion problems. As far as sugar mills are concerned, we get a lot of other indirect benefits when we divert B-heavy molasses or syrup. That is increase in crushing capacity and export of power, higher export of power, reduction in steam consumption, and saving of bagasse. Saving in handling and bagging charges of sugar, the amount of sugar which is diverted, we need not go for the bagging of that sugar. And of course, the most important is the reduction in interest burden of the sugar stocks. The emerging technologies such as high alcohol tolerant active dry yeast, high gravity fermentation, the advanced enzymes, air-cooled condensers, MVR-based evaporation and distillation, even the RO systems which are again now being proposed for reduction of the spent wash generation, and heat integration approach, they will all these factors are going to be key factor in reducing the cost of production in future. The recovery of potash, the recovery of depotash vinasse, producing compressed biogas, producing corn oil, producing biodiesel also in future, which can be combined with the distillery operation, and producing protein from rice will provide additional benefits, and technologies are available and some of the technologies are under development. However, it is most essential that Government of India is required to devise a long-term sustainable policy for boosting the ethanol production in the country, instead of flip-flop kind of policy which puts our sugar mill in a big problem. with all these emerging trends, technologically, we have seen in last 2 days that there are going to be exciting challenges and opportunities in future. So thank you very much for your patient hearing.
Thank you, sir. Now, next speaker is Ajay Nair, Managing Director, DEIF India. I request you, sir, stick to the time and finish in 15 minutes. Thank you.
Yeah, good afternoon, all distinguished guests and esteemed dignitaries on this stage. So, as a last speaker, I realized that I'm the last one between. I'm the only one between you and lunch. So I'll try to, I'll try to finish. I'll try to cover the topic as soon as possible. So basically, I am going to talk about the power management systems in the power plants. Like all the esteemed speakers, they have spoken about fuel and those matters. But what happens to the power which is created after the fuel is burnt? So that's the topic where I'm going to cover, and I represent DIF. DIF India is in the business of giving solutions to the asset owners, to the industry, where you can mix the power which is coming from the fossil fuels and the renewable energy. So that's the solution that we provide, and we help the industry in achieving the sustainable goals in that sector. Yeah. So today, if we look at the energy electrification in the industry, then these color represent the power sources which produce the CO2 emissions, and so from there to green. So that's the transition that we have to go. Like today, you have the power sources which are emitting the CO2. Then it is burning fossil fuels, and from there we have to go through the transition from that to completely green in nature. Where there are where it is the energy generation is completely sustainable. So that's the journey, and that's I'll give a bit of perspective on how the control systems can be used to go through this journey. So if you look at today's scenario, then there are turbine generators or diesel generators in the industrial plants, and then there's a grid. The utility sources are there, and going forward, we have this PV systems, the solar power plants, and then the latest you have the energy storage, the battery systems which are there, and this needs to be integrated. So when it comes to the control technology, then it's also a requirement that we need to understand the energy mix. Now the energy energy which is produced from diesel power plants, from gas power plants, or from the solar power plants, or from the energy storage, these are of different characteristics, and this has a different this needs the knowledge to put together the operation between these plants. Yeah, so here it is the control system needs to know about the different energy source natures, the infrastructure required when it comes to the different power sources that are different, the way in which it operates, that part is different, the speed in which this power can be brought into use, that is also different, and then we need to integrate the whole the solution together. So that's what we call as the energy mix here. And when it comes to the integration, there are also what we see from a control system perspective is the prime movers. Some of the prime movers are new prime movers. Then you have the old systems also which are there. So integration between the old and the new assets, and then the integration between the sources which are generating power through the fossil fuels, and then we have the sources which are also generating through the renewable energy like solar, and then we also have the energy storage where there is a possibility to store energy. So that's the mix that we need to see in the projects today. So when we are looking at the future, so that when we are looking into the future, then we are also looking at the fuel cells, the power generated from the fuel cells, the power generated from hydrogen, the energy which is generated from hydrogen. So this is there is a need when we go into the future to control or to monitor the power which is generated from these sources, and then do a very efficient power management to achieve the sustainable goals. I'll just yeah. So here, when we are also looking at the different sources, then there is also a need where we need to look at which the cost of energy. So which the power generated from which source is the cheapest at that point of time, and then allow the utilization of that source. And we could also think about arbitrage, in that sense. So when it comes to when it comes to a control system and the power plants which are related in the industry, so we have, as I was mentioning, we have different equipments which are there, which are already installed, and there is also a possibility to install various sources like solar energy storage in the future to achieve the sustainable goals. And so from a control system perspective, it is needed that we provide a solution which is understanding the present energy source and how the future sources are going have to be brought into the system, and that needs to be integrated. So here there are different layers in which, when we look at from a control system perspective, one is the nature of equipment, then the asset control, the individual asset control which is required, and then there is a layer of application control where we need to provide a holistic view of how the power management needs to look. And then on top of it, then it is an energy management system where you have the access to the where it has a connection to the grid, and then there is also cloud monitoring and analytics and those type of controls which are required. So from a company whom I represent, DIAF India Private Limited. So it is we provide this intelligent PMS and EMS, which focuses on maximizing the green power penetration. If there are power sources which are running on generators or turbines, optimizing those, then ensuring resilience in the plant. So when there is a block load or which something like that which is there on the power plant, then the system which is there, it has to the design of the system has to take care of that sort of requirement, and then accommodating all the power sources. And also, it is a easy system configuration that we provide. So finally, it is what we call as the intelligent energy control, which has to be more intuitive. When I say intuitive, then it also has to look into the various aspects like the generation cost, and then decide on the control system philosophy and how the plant should operate. Then more technology supported. Today we heard the power which is generated from hydrogen. Then there are new technologies which are coming in. So there is a need for more technologies to get supported. It has to be securely connected, because today we are also talking about the cyber crimes and those things. So cyber threat. So these are also very much applicable for the power plants. So that is also something which a energy system has to get. The energy control has to take care of, and then of course it has to. The system has to be designed to extend the limits of each source, and then less risk related to the last minute changes. It has to be scalable, and then finally it has to it has to act as an enabler to grow the business. So the intelligent we provide these intelligent energy management systems which will help the energy puzzle and to achieve the green goals. So we are working with the energy with the engineering department of VSI to for these aspects, and we also are working with the sugar industries here to enable to achieve their sustainable goals. Yeah, I will. Thank you.
So thank you, sir. Now I request Chairman sir to felicitate our speakers. I request Chairman sir to felicitate Mr. Ramakrishna sir. That's okay. Now I request Chairman to give memento to Dr. Bloom. Now I request DG sir to give memento to Mr. Chakravarti. DG sir. Now I request DG sir to give memento to Professor Patil sir. Now I request DG sir to give memento to Ajay Nair. I request Mr. Ramakrishna sir to give memento to our chairman, Mr. Atul Mule sir. So thank you all. I declare this is the end of the session.
So our next session will start by next 30 minutes.
Very good afternoon to everyone. We will begin the technical session 4, Environmental Sustainability in Sugar and Allied Industry. I apologize first of all for the delay in starting the session. Our last session ran slightly over time. So for this session, we have 4 very eminent speakers. And I will introduce them to you. And we have our leading expert in pollution control and environmental management as a chairman, Shri J.S. Kamyotra, sir. I will invite him on stage. I will also invite our speakers, Dr. Winnie Gerben-Leens to please come and take her place. Dr. Yashpal Singh, Mr. Santosh Nair, and Mr. Pankaj Tanwar. I'm sure all of you are aware that we are now talking beyond environmental pollution, what we used to talk about only pollution, controlling pollution, water, air, soil, etc. We are going beyond that and we are talking about environmental sustainability. And sustainability is that the environment should remain in a sustainable condition for future generations. So meeting the needs of the present generation without compromising the needs for the future generations is what sustainability is defined as. And under that, a whole gamut of areas are covered. So today in this session, we will be talking about water footprint and then we will also be talking about how to avail the benefits of water and carbon credits for the sugar industry. Many of you who are from the industry may have faced penal action. So these days the NGT is also very active and people are approaching the NGT for various issues. So how are environmental damages and compensation decided? We are having one lecture on that. And finally, what are the initiatives of the government of India for different sustainable initiatives? One speaker will be talking on that. As I said, we are very lucky today to have Mr. J.S. Kamyotra, sir, who is the former member secretary of the Pollution Control Board, Central Pollution Control Board. He's a leading authority, he having handled so many industries and from a peak position, having worked his way in the Pollution Control Board to the very top. And now he is also a member of the Expert Appraisal Committee. So some of you may have also faced him while going for your environmental clearances. And he's bringing about a good change by getting in people to not just enforcement, but how you can actually comply with what the conditions are there. So we will begin. Sir, any remarks you have to offer at the beginning?
First of all, good afternoon to everybody. Good afternoon to everybody, and it's a privilege to be here and really thankful to VSI for giving this opportunity. And my thanks to Madam for this pleasing introduction. Yeah. So today, the topic that we are talking is sustainability. And because now everybody talks today, it's resource conservation, we talk about the circular economy, we talk about the carbon decarbonization, carbon neutral, and so many things. And now when we talk about sugar and distilleries, allied industry. So we are moving towards that. If you see, we are helping in moving towards that. Ethanol, when we talk, we are trying to move towards resource consumption, that means economy. We are saving a lot of money of the foreign exchange. But at the same time, in the presentations, we have seen in the morning, how it can be a resource now. In the morning, we have seen that yes, we can have protein when we generate this, we can have potash, we can save potash from a proper treatment of the our wastewater. We can
Nahin.
use CO2 as a resource also.
Mic is not working.
It's coming. So it's coming as a resource also. So the industry, especially the sugar industry and ethanol distilleries, are helping in resource conservation in a big way. But they have also a lot of issues and challenges. One, they are drawing a lot of water. And that, yes, it's getting disconnected. No? Already on. Yeah, so when we say that distillery and sugar industry, they are categorized as a red category of industry under the highly polluting industries. So that means from the pollution potential, they are on the higher list. And at the same time, we are using a lot of water also. Though it has come down drastically over the years, but still there is a lot of scope to bring it down further. Besides that, whenever we produce, we talk about ethanol production, big way, moving towards a big ethanol production, 20% blending, and 12% already done, 20% by 25, and moving towards 30% later on in 2030. But we are also releasing a lot of carbon dioxide. For every ton of ethanol produced, roughly 1 ton of CO2 is released. So this is another challenge that we talk about on one hand of controlling greenhouse gas emissions, but we are adding also to CO2 also in a big way. So this is another challenge where we need to look into that. The technological challenges are that how to reduce the power consumption. We talk about treatment, but we at the same time say that it's not economically viable. We are talking about ME, we talk about RO and all this. So we need to look into the technologies where they are not power intensive and help in mitigating and abating the problem of pollution also. And this is besides meeting the statutory requirement, because as Madam mentioned that there are a lot of issues of environmental compensation, damages occurring, NGT being very severe and harsh on violation cases, and the fines being very, very large. But at the same time, there are certain legislations which also require stringent measures, like the recent law which came in 2020 from the Ministry of Jal Shakti regarding the water audit. It says that every 3 years, you need to bring down your water consumption by 20%. And that's a big challenge. And we need to start working as on date. How to work? That's a question. Where to reduce? That's a question. And that can only be achieved if we are very fair in our estimates. I just want to add from the government side also that whenever the policies are made, opportunity is given to the industries also to present their views. But if that time the data is not presented in a right spirit, the policies do not reflect the true picture. And then it becomes difficult for the industries to meet the obligations. So since most of the people from sugar industries are here and the distilleries are here, so my request is that kindly in next round of legislations or rules, whenever they are made, try to be fair and give the right picture so that, yes, true pictures are known. Now what happens that 4 KL per KL is the limit proposed to you and the industry is not able to meet. Then the water audit will also reflect the 4 KL by KL. So that means the true picture again is missing. So looking at this this seminar and what I was listening in the morning, yes, were very useful. And presently this session talks about the sustainability aspects. So we should forget what I was talking to Madam also, that earlier we used to talk about LCA, life cycle assessment. And since we are talking now recovery of everything, so life cycle was talking about cradle to grave. And now since we are talking about recovery, recycle, reuse, and this, so we need to talk about cradle to cradle, not cradle to grave. So we need to change our view and look into that way and work together. And I hope that this session will be very fruitful and useful to all the people, all the participants here. And I extend my invitation to all my colleagues here, speakers here, distinguished. Thank you.
Thank you, sir, for those very important words. And as we talked about water and the usage of water, I think it would be very right that the first speaker is talking about the water footprint of the sugar and bioethanol industry, because water is a very precious resource, not just in India, all the world over. And with climate change, we are facing more and more water stress. So our first speaker today happens to be Dr. Winnie Gerbens-Leens. She's an associate professor and works on the Integrated Research on Energy and Environment Society at the University of Groningen. She has been part of the group that first worked on the concept of the water footprint, and her field of specialization is water footprint, energy and water relationships, transitions in food and consumption patterns in Africa towards Western patterns, and consequences for land, water, and energy requirements. She will, of course, as I said, be talking about the water footprint of the sugar and bioethanol industry. So I invite Winnie to give her talk. Can you just switch on? Yeah. We put the one presentation.
Here it is. Welcome everybody. I was just introduced, and well, I'm very happy that I got invited here. In the past days, I already learned a lot about sugar, sugar beet, sugar cane. I saw a lot of presentations. But when we are talking about sustainability and challenges, I will add the perspective of water. Now, it was already mentioned, I'm from the Netherlands. I worked together with Professor Hoekstra, who developed this water footprint concept. We had a quite small team, but a few years ago, Professor Hoekstra, at the age of 52 years, passed away. So this small group now has the responsibility of this heritage that we will bring further. Good. Water footprint of sugar and ethanol. What am I going to talk about? In this presentation, I'll show things about the availability and the role of fresh water, because we're not talking about water, but we're talking about fresh water. I'll explain this water footprint concept, and this concept can be applied also for sugar and ethanol. Good. What's the problem? Well, some years ago, we did an assessment for the Coca-Cola company. And as I mentioned before, in the Netherlands, we developed this so-termed water footprint concept. And we organized ourselves in a so-termed water footprint network. It's still located in Enschede at the University of Twente. And when this was founded, one of the first members became the Coca-Cola company. So then they also came to us because they were very interested in well, their corporate responsibility to make an assessment for their Coca-Cola. The idea was that we would have the ingredients of the cola. Of course, we didn't get that because it's a secret. But we made the assessment, and for what we see here, it's working. Try to use the pointer. It's not really working. For a small bottle of Coke, 250 milliliters, well, of course you need so much water, but most of the water is needed to produce the sugar. So it's related to the sugar. It's not needed in the plant itself when you produce your cola, but it's needed in the supply chain. So what we need to do is go back in the supply chain. This is just an example of how our water footprint works. So around 10, 15 years ago, as I mentioned, we established this network. Companies became very interested in their water use because it was part of their corporate responsibility. So they not only looked at their carbon footprint anymore or land footprint, but they included water. And what we discovered is that many businesses did not really know where the ingredients in their supply chain came from. For example, we also did our assessments for Unilever. They had no idea. So if you want to do an assessment, and in general we see that the operational water footprints are small compared to the supply chains. So if you really want to do something, you have to look at the supply chain. Of course, the operational water footprint needs to be fine, so no pollution control. But then going back in the chain is far more important. This was an introduction to what I'm going to say. First, the availability and role of water. So it's about fresh water. It's not about salt water or brackish water, because the availability of fresh water is a limitation. But we need it for just everything. We need it for households to drink. Well, I was surprised by all the bottles that I emptied, that after a few days in my room I had a huge pile of bottles. bottles just everywhere. Of course you need to irrigate your crops, but there are also other uses and other large consumers of fresh water, like electricity generation in power plants. At the moment we have a huge project together with CGR that we look at the water for electricity in Africa, looking at all the power generation in Africa. But then about water. I'm taking a step back, so I don't look at the companies anymore. I look at the global water cycle. Very often my students say, okay, why would we be concerned about the availability of water? Because the volume of water on our planet Earth is a constant one. So, yeah, but then it's about where is my water and when is this water available? Of course, you see here the hydrological cycle, very large simplification of what happens. Your water evaporates, it forms clouds, it starts raining, and it flows off to the sea again. Simplification. But then, when we start thinking about climate change, when I look at my country, what's happening there, when I left to India, it was cold. And normally, when I was a kid, it was cold and we could go skating on the water. But now it's only a few days in a year. We had much precipitation in autumn, and the crop fields were so wet that the sugar beets could not be harvested anymore because the farmers could not go into the fields. So this is an example that in my country we see that the changes are going so fast that we can see it. It's a gradual change anymore, because if things go gradually, you don't observe it quite well. But these things are now happening in a few years. We see fires of the forest. So something is changing in this hydrological cycle, which has huge consequences also for the availability of fresh water. Most of the water on our planet is salt water, so we can't use it, and we need fresh water. So only 3% of the water available on this globe is fresh. But then again, we cannot use it all because we don't have access to all the water, because part is stored in ice. But then, of course, also climate change is going to do something about that one. We have huge groundwater stocks, and we can pump it up to use it for agriculture. But only a minor part of our total fresh water on this globe is surface water, where we have access to. When we look at the water withdrawal per sector in the last 120 years, then we see an enormous increase in the water use. And of course, we know these types of graphs from CO2 emissions and energy use, but this also holds for water. It goes up quite steeply. And what we also see globally is that, it's working. Most of the water is withdrawn for agriculture globally. Minor part is domestic water, and about 1/5 is used for industrial purposes. So some for power generation, primary energy production, and other industries. Now, if we specify a bit more, if we zoom in a bit more, in the same period, we see that it's especially agriculture. And what I show here is that there's a difference between the actual withdrawal and the consumption. When we withdraw water, we don't consume everything. Part returns to where it came from. So we are interested, and also from a water footprint perspective, we are interested in the consumption. So the water that is actually lost and that's not available for use anymore. So what we then see is that there's a huge difference between the consumption and the withdrawal in agriculture, and this is by far the largest. Domestic use, the difference is far larger, so we withdraw, but then when you treat the wastewater, it goes back, it returns to where it came from, so it's not actually used. And in industry, you have the same. For example, if you use water to cool your power plant, you take it from a river, or you take it sometimes even from groundwater, and then it goes back with a higher temperature. Further zooming in, where is the water used? And then what we see is that here, Asia. Asia is the largest consumer, and this of course is not strange, because we have the largest populations over here, India, Pakistan, Asia, Southeast Asia. Africa is quite small. South America, they can use rainwater, so they don't need to irrigate so much, but also the United States is large. In central USA, they pump up the water from aquifers. For the sectors, Asia, the withdrawals are mainly dominated by agriculture, 81%. So if I relate this to one of my first slides showing the operational water footprints in a company and the supply chain, if we want to do something, if we want to save water, we really need to go to the first stage, so agriculture. Europe, it's small. In the north of Europe, you don't need to irrigate so much. It's mainly in southern Europe. Okay, then the water footprint. If we want to know something about water withdrawal, water consumption, we need to make assessments. We need to make calculations to find differences, and to find differences among countries, among provinces in countries, among crops. Where is the water used? Without this information, I cannot become more efficient. So the water footprint is part of what we term the footprint family. The first footprint was developed by Wackernagel and Ruiz in the last century. This was the ecological footprint. They came from Canada. And what they did is that they introduced a way to calculate land use and also land that was needed to take up carbon again, that you could relate to human consumption. So what they did is that you can relate human consumption patterns to land use. This was, well, an example for Professor Hoekstra, who developed this water footprint concept, which is basically the same. So you relate consumption with water. The CO2 footprint came later. So let's focus on this water footprint concept. Yeah. What we can do with this is that we make an assessment, basically first, how much water do I need for a specific item. But what it also does is that you can relate the origin of your item to your consumption, because as we sit here, I think we all wear something that's made of cotton. No? Now, there are some large cotton regions. I think also cotton is produced here in Asia, but this is probably, you have seen this picture, this is the Aral Sea. The rivers that feed this Aral Sea are completely pond dry because they use the fresh water for the irrigation of the cotton fields. So if we consume cotton, we are also responsible for what's happening here. And in this way, you can relate your consumption to the production places and see how responsible we are. Okay, so when we make a water footprint assessment, we go to 4 phases. You first set your scope and goal. What are we going to do this assessment for? What is my purpose? What do I want to know? Then phase 2 is the actual footprint accounting. So I start calculating. So I need to make an assessment of how much, well, if we talk about agriculture, how much water do I need to grow a specific crop? But then comes the so what question. What is the aim of my assessment? So I want to make my consumption more sustainable. So I need to do some way or another a sustainability assessment. And then the final phase is the water footprint response formulation. Now you can make this assessment using this water footprint concept, but you can also do a life cycle assessment. Yeah. LCA is also a very well developed tool to make assessment, to look at sustainability of production. Initially, LCA looked very much at pollution, and later they also introduced water in their assessments. And they do the sustainability assessment a bit differently than we do. There is now an ongoing, discussion between the two communities to come to a general concept that we integrate LCA and water footprint assessment. We are working on a common paper right now. So what we need to know then, if we want to make this assessment, we need to know what this chain looks like. So we need to know if I have an ingredient for a specific product, where is it coming from? I need to know where my water is coming from. So I need to know also the supply chain of my water. If I have a crop field, then I need to know where my water is coming from, because what we quite often see is that you have huge losses in your supply chain. For example, a PhD candidate of mine, he looked at the water supply in the Indus Basin in Pakistan, finding enormous losses. And this has to do with poor management of the water supply. Okay, then you go to the farmer stage. You go to the food processing stage. You go to the retailer, and finally your product ends up at the consumer. Then we define 3 types of water. We look at green water footprints, which is basically precipitation, mainly rainwater. We look at blue water footprints, so it's the water that you withdraw from groundwater or from surface water. And then there's a final one, a gray water footprint, and that is a theoretical footprint that expresses how polluted your water is. So we define it as the water that is needed to assimilate the pollutants. And then, of course, there are different standards in different countries about what are acceptable water quality standards. So it also depends on where you are. Now, thinking back at our company and the supply chain, we identify a direct water footprint. So the water that is used at the place where, well, it's actually used, and the indirect one that's in the chain. And then you can see the 3 colors, so green, blue, and gray. Green and blue are related to the actual consumption of your water, so how much water do I need to produce my product? And then the gray one is related to the water pollution. Now, when we look at the statistics, because we need water source data sources to do this, when you look at the statistics of, for example, FAO, Aquastat and FAO, you see that they report mainly the withdrawal data and not the consumption data. So these are the traditional statistics. We developed a huge database that is available on the website of the water footprint, showing all these water footprints, so the separate colors per crop, per country, per province. So if you want to do an assessment, say, about the consumption pattern in a country, you can use those numbers to make your assessment. Okay, so then the definition. The water footprint of a product is the volume of fresh water to use to produce the product, summed over the various steps of your supply chain. And therefore, it's different than CO2 emissions, because here it's more complicated because you have a temporal and a spatial dimension. It matters when and where you use your water, and that creates differences. If we want to assess the water footprint of a product, we use the crop water use, so cubic meters per hectare, and we expressed it in units of yields. So this basically means that the higher your yields on a unit of land, the smaller your water footprint. This is for a crop. We could also make an assessment for the water footprint of an animal, but then you need to know how much feed is going into your animal, and you have to sum it up over the lifetime of an animal. And when we have products with more end products, you have to distribute your initial water footprint. You have to allocate it over the derived products. Then I was talking about the sustainability assessment. So in some way you have to make an assessment, how sustainable is my water use. So what we then do is that we look at the blue water footprint. We do that per country. We know the water availability, and then you can compare the water scarcity. Water availability is expressed in the water footprint concept as well, we look at environmental flow requirements. So that basically means that you cannot take out all the water from the environment, because then you would really harm your environment. So we assume that around 80% needs to be available. Yeah, so you can take out roughly 20% without too much harm to your environment. But what we then see happening is an enormous blue water scarcity, then especially in Asia, North of Africa, but also in Europe this occurs, depending on the months in the year. So here we see an overview of the annual average monthly blue water scarcity, and then India and Pakistan are popping up, parts of Australia, but also in the United States, southern Spain. So developing this concept, and then you can use it to start making your calculations. And we have all these numbers. We did that for a huge amount of consumer products, so varying from other food products, but also for cotton and shoes and power. Now, in general, and you could expect this already, products that are based on crops, so sugar, they are low in the pyramid, so they relatively need less water than the other products, for example meat, because then I need all the feed ingredients that go into the animal, and then you get really huge water footprints. Now, showing all these numbers also made that there's, well, at least in my country, there are advices to eat less meat, because the pressure on our freshwater resources becomes too large. We also made these assessments for sugar, and then you see the enormous amounts of water that you need for 1 kg of refined sugar. But this is a global average, and it varies a lot among countries. As I mentioned before, my group made this huge database with water footprints of all the crops and crop-derived products. And then we decided, okay, now we have it for crops. We can also do this exercise for bioenergy. So we were the first to make an assessment of the water footprint of bioenergy. So for ethanol and for biodiesel, because initially the biomass is the same, whether or not you make a food out of it or if you make a fuel out of it. So you can use your biomass to generate electricity and heat directly. So you can use jatropha, or you can use wood and burn it. For example, here in India, they use a lot of wood for cooking. You can also use it, to make a product. For example, you have sugar cane and you produce your sugar, then you have a residue left. Then again, you can use that residue for something. You can also make ethanol or biodiesel out of it. So depending on the purpose, what you want to do with this. Now this is a figure from our first publication that we made. What we see here is that from a water perspective, it's more efficient to produce bioethanol than biodiesel. So that's my first result. We see here a distinction between blue water and green water. Now, if you remember, then the green water footprint was the precipitation. So basically, this is for free. This is what's falling from the air. So this is free. And this is my blue water or my irrigation water. So I see that there's a huge difference between the crops. Yeah, some crops need far more irrigation than others. Now the sugar beet is very efficient. The sugar cane, well, it's also fine, but it's less efficient than the sugar beet. We could also do this for other crops that have a carbohydrate content. So for potato, for maize, cassava, barley, rice, paddy rice, and wheat. And here we find the oil crops. Now maybe this jatropha was an interesting one. Yeah. I did not know at that time about jatropha, but I wanted to include it in my analysis. But then I got a lot of comments about this because at that time, we're talking about 15 years ago or so, there were huge interest from business to go into jatropha for the biodiesel. We also made an assessment for sugar and for bioethanol globally. This is one of the figures from that publication. Here you see the sugarcane areas. Here the Indus Basin and the Ganges Basin, and here this is where we are now. And you can then relate it to the water availability and water scarcity in this area. Water footprints of sugar cane. I just showed the global average. What we see here is the difference between countries. And then you can see the locations or maybe the agricultural practices that are less favorable. For example, here we see Egypt that has a huge use of irrigation water. We here see Cuba. Cuba has more precipitation. It doesn't use so much irrigation, but the overall water footprint is far larger, and probably this has to do with low yields. Then I'm showing another example of how we can decrease our water footprints. This was done by one of my PhD candidates who is now working for the Ministry of Agriculture in Pakistan. What we wanted to do, we knew exactly where the crops are grown, and we knew the combinations of crops, so the cropping pattern. So we knew where they were located, and then we wanted to optimize this. We did the same exercise for Iran, and we could decrease the water use. So what we see here is that when you start moving your crops, and we did this for water and we did this for energy use that is needed to pump up your water, we try to optimize both. So first the water by moving the crops, then you can decrease by about 10 to 15%, and then the energy footprints, and you can also see that that goes down. So what we see is here the relative gross blue water footprints of the sugar cane. So it's more efficient in the south than in the north, and for energy this is the same. And then we start optimizing, so moving the crops. Basically the sugar cane goes to the south where it's more efficient. We did a similar exercise for transport fuels, looking at the water footprints, and what we then see, because in the European Union there's a policy to blend petrol with ethanol, but there is also a tendency to use more electrical cars. So we express this in terms of water, and what you then see is that, this is a logarithmic scale, so the differences are used. So that especially when you start using your ethanol, your footprints are sky high. Hydrogen is a bit better, and for electricity it depends very much on the source of your power. If you use the mix that we have now with natural gas and coal, then it's not so good in terms of water. And something about ongoing research, because what I showed was present results. We have a new PhD candidate in our group, and she is going to look at the future water availability for food and energy development in Pakistan. Because what we see is that what we have is presently, maybe you heard of this energy drought, that when there's not enough wind and not enough sun, we cannot generate electricity, but something similar could happen to snow droughts. What we see is that at present, snow is melting, the glaciers are shrinking, and this could have an enormous impact in this area. And this PhD candidate is going to model the future water availability that is generated in this area. So this is the Hindu Kush Himalaya area. She's going to use about 40 models to see what will happen in the future. But these mountains, they are the source of very important rivers. In China, here in Southeast Asia, we have the Mekong. Yes. We have the Ganges River and we have the Indus River, and this might very much affect agriculture and possibilities for agriculture in these areas. So this is ongoing work. I think I got a note here that there's no time for questions anymore. But you can always send me an email. You can probably find me. And thank you very much.
Thank you, Dr. Winning, for a very informative presentation, highlighting the need for optimization of the water footprint and the methodology to be adopted for assessment of water consumption, demand, and abstract. Thank you very much.
You can use table mix.
It's not working.
Dr. Winnie has to leave. Her flight is. So I will ask the chairman to kindly present her with a memento. Now for the next presentation, we have Mr. Santosh Nair, who will be talking on something which will interest you environmentally and financially as well. He will be talking about availing water and carbon credits for the sugar and allied distillery industries. And that's another way of generating finance as well as meeting your environmental goals. So I will ask Mr. Santosh to please come and give his presentation. Why is it not?
Respected dignitaries, my fellow speakers, ladies and gentlemen, very good afternoon. My name is Santosh Nair and I represent Progressive Management Consultants, a company at Goa largely for carbon and water credits. Let me just introduce myself. As I already said, I represent Progressive Management Consultants in the capacity of CEO. I'm a chemical engineer by qualification. Very important to mention here because I have been addressed as Dr. Santosh Nair in many places. So please note that I'm not a doctor. I don't know, it has been pointed out, but still in some of the, I think in your books also it is mentioned as doctor. So I don't have the certificates for that. Besides that, I'm a lead auditor in almost all the major ISO standards like ISO 9001, ISO 14001, you know it is Quality Management System, Environment Management System, 22,000 Food Safety Management System, 27,001 Information Security Management System, so on and so forth. ISO 14064 part 1, 2 and 3 which talks about GHG accounting, you know, and verification, 13485 medical devices, so on. I'm also a lead verifier for carbon credits and water credits. We'll be dwelling more into that, and also facilitators for those organizations who wants to go for net zero certification. Nowadays, there is an increasing requirement for organizations to claim as net zero, both in carbon as well as in water. So we do facilitate that, and also into sustainability reporting. Again, that's the need of the hour. Today, organization, governments, they are insisting on organizations to have a sustainability reporting. We do that on behalf of organizations in various frameworks like GRI, CDP, SASB, BRSR, EcoWadis, all this. So And lastly, also carbon and water footprint. Those organizations who would like to know about carbon footprint, what is the carbon footprint of their, their carbon footprint, also water footprint. Of course, Dr. Vinny has highlighted a lot about water footprint, so that made my work easier. So quickly about the contents, introduction to the carbon and water credits, importance for sugar and allied industries. In fact, almost all the industries will be benefiting from this since the theme is for sugar. So the theme is based on that. Key concepts about the carbon credits, about the water credits again, and calculating this carbon and water footprint. I will spend a couple of minutes on that. Some case studies. What are the challenges posed and the potential benefits that you can derive? And of course, we can have the question and answer session. I know that we are running short of time, so I'll try to make this very quick. And if you see, I have given my details in the footer of every slide. So those who are interested in knowing more about this can send a mail to me, or you can also contact me through WhatsApp. We are also having a lot of associate organizations who help organizations to reach us rather. One such organization who has been doing a lot of work with us is Sasa Enviro, who is also present here. So you can also get in touch with them because they are the ones who have done a lot of work with us in this regards. Introduction to carbon and water credits. What are this? Now, carbon credits help industries reduce their carbon emissions. We talk about carbon emissions. How? By supporting green projects. For the last 2-3 days, we have been hearing about a lot of sustainability projects and all those things. So definitely each of these projects can earn carbon credits. Okay. And similarly, a concept which is not widely known, but this is going to be something very important for the future, is about water credits. Now, this is to help industries to save water and use it in a more efficient manner, and by investing in water saving practices or very water conscious approaches. Now, these credits encourage industries to go beyond the compliance level. There is a requirement as far as compliance is concerned, but yes, we go beyond that and try to become leaders in positive change. They help businesses to be more eco-friendly and sustainable. And when these industries use water and carbon credits, they meet all the rules applicable and also becomes leader in eco-friendly practices, which means that yes, they care about the environment. Importance of carbon and water credits for the sugar and allied industries. Now we're talking about sugar. Reduced pollution, that is one of the most important aspect. The sugar industry definitely is a significant contributor to the GHG emissions. We all understand what is a GHG emissions, which is largely carbon dioxide, followed by methane, nitrous oxide, so on and so forth. So definitely sugar industry is a contributor to that, and it can reduce its pollution by using renewable energy sources. Like a lot of thing has been spoken about it, so I don't want to repeat it. I'm sure every one of you know what are the ways of doing this, and also by reducing waste, doing waste management activities. Very important aspect, financial incentives. So carbon credits can provide an additional source of income for the sugar industry. Now these credits that we get, these are something that can be traded in Indian market or export market, international markets. Apart from that, water conservation. Yes, definitely the sugar industries uses a lot of water, and also a lot of water is reused, recycled. As I have understood in the last couple of days, people have already started having huge data on that. Now these all atoms can be utilized for gaining water credits, right? And this again, like carbon credits, can be traded, and again that is an additional income for you. And lastly, brand reputation. Definitely those organizations who are earning water credits and carbon credits, well, it shows that you're committed to protect the environment, and that thereby promoting sustainability, which is the need of the hour, and thus improving your brand reputation. Talking about carbon credits. Carbon credits are nothing but incentives given for what? For reducing the pollution and GHG emissions. through initiatives such as renewable energy projects. We have seen, like I said earlier, now there are sugar industries which are using bagasse fired boilers instead of coal fired. So these are all initiatives that actually reduce your dependence on fossil fuels. So this is what we have to look at, and all such initiatives can be classified as a green project, and for which you can get carbon credits. Afforestation definitely is one of them, and also indulging in several energy efficiency measures, practices, okay, improving your energy conservations. Then we have carbon credits are issued for such sustainable contributions. Now what happens is, once you do these green projects, then they are expected to be verified. So unless and until these items are not documented and verified, you cannot get a credit for that. So this is issued for such sustainable contributions, provided they are verifiable. These carbon credits, as I said earlier, can be traded on carbon markets, or also can be sold to those organizations who cannot reduce their emissions, but they want to reduce their carbon footprint, or rather go towards a path towards net zero. So this is where this can be utilized. What is a carbon credit? One carbon credit equals 1 ton of carbon dioxide equivalent. When I say equivalent, like I said, everything, like we have methane, we have nitrous oxide, but to make it uniform, everything is converted into the equivalent of carbon dioxide. You have efficiency values for that, by which you can convert it. There are many types of carbon credits. Basically, we have CERs. CERs are nothing but certified emission reductions. Now these are for compliance market. Okay, now these are credits generated under the CDM, that is Clean Development Mechanism of the Kyoto Protocol, and for reducing emissions in developing countries. They are verified by the UNFCCC, United Nations Framework Convention for Climate Change. We have VERs. Now this is something for the voluntary market. We are largely associated with this type of carbon credit. This is voluntary emission reductions, are carbon credits from voluntary emission reduction projects. Okay, so these are not mandatory, but this is a voluntary. So these are verified by third parties. We have something called REC, which I'm sure every one of you must be aware of. Okay, so these are nothing but renewable energy certificates. These are additional incentives given for you for generation of renewable energy, and indirectly contribute to reducing your GHG emissions. So even if you avail REC, you can still avail carbon credits. Okay, so this is an additional to that. Carbon removal credits, as someone mentioned in the previous session, in the first half, there is something called direct air capture. Okay, so these credits represent removal of carbon dioxide from the atmosphere through projects like, of course, afforestation and direct air capture. Carbon offsetting, that's a term we use, which involves purchasing carbon credits to compensate for the emissions that cannot be eliminated. So the first thrust should be to eliminate, to reduce your emissions, right? Those which cannot be eliminated, you can offset it by purchasing carbon credits to that extent. Talking about water credits, again, water credits are incentives to conserve water, keeping it clean, preserving it through efficient water management practices, meaning a lot of water can get wasted. So, by reducing it, by recycling it, by capturing, by conserving rainwater, all these measures, you can improve your water management practices. Water credits are issued for such good causes, again, provided they are verifiable. So you need to have proper documentation which shows that yes, this was the project that we have done, and this much is the water we have saved or reused or recycled, so that fresh water usage can be avoided. Again, they can be traded or sold to those looking to offset their water footprint towards net neutrality of our water. So if you see, the carbon credits and water credits were very similar, subject is different, that's the only thing. And what is one water credit? We call it ROU. It equals 1000 liters or 1 kiloliter. So 1 kiloliter is equivalent to of course, water saved or recycled or reused or harvested. So 1 kiloliter is 1 water credit. There are many types of water credits that has been spoken about globally. I'll just touch upon some important ones. Blue water credits, that talks about management of freshwater resources. Okay, like surface water, groundwater. We have something called gray water credits. We already know what are those footprints in the previous session. So now, similarly, we have gray water credits, which talks about reusage of wastewater from your industrial process. Stormwater management credits for handling rainwater runoff. Okay, because it has to prevent issues like soil erosion and water contamination. So for that, you get stormwater management credits. It's also called water conservation credits, which talks about reducing the overall water consumption by industries. How? By using proper equipment, efficient technology, and all those things. Community-based water credits, that is for those industries who support local communities for getting proper access to clean water through such projects. And also last one, it is biodiversity water credits, which focuses on those projects that enhances the aquatic ecosystem, like also wetland preservations, etc. So these are the different names by which these are all known across. But now here we have a water registry that is coming up, which will talk about all of this in one umbrella. Okay, we call it in different scopes. Like in carbon credits, we have 3 scopes, right? Scope 1, scope 2, scope 3. So here we have 5 scopes. There is another interesting program initiated by the Indian government, that is Green Credit Program, GCP, you must be aware of. What is this? This is a program by the Indian government that encourages people and businesses to take action to protect the environment, to ensure that you do some practices which can help the environment in both way, carbon as well as water. This is a combination of both. It offers financial incentives. Even this is an additional income to you for voluntary environmental actions across different sectors. Sugarcane is one sector. Methodologies are currently being developed. It is in the final stage, draft stage, to award green credits based on benchmarks to ensure environmental impact. Okay, now the best part is this is in addition to what you can already, the other carbon credits that you can avail. So this is an added thing. So it's not that there was some apprehension that if you get green credit, you cannot use carbon credit. It's not like that. This is in addition to that. A digital platform currently is being built to ensure that the entire process is streamlined, right from registration of the projects, verification of the credits and all, and final trading. So it's a comprehensive package that is being developed by the Indian government, a very good initiative. Now steps to avail this carbon and water credits. How do we get? Now you all know what are the projects that can qualify. A lot of technical resources are available. A lot of talks have been spoken about. Good things are happening, but now what? So the next thing is to look for getting carbon credits. That's where consultants like we come into picture. First thing is you can engage any consultant, of course, and they will come, they will study your process, collect all the data that is required, and then they will prepare the necessary documentation. Now we are called as a documentation consultants. We are not a technical consultant on telling you how to do, how to set up a plant or something like that. So once you do it, we prepare the documentation that is required for the registry to register your projects, like project concept note, we call it PDD also, monitoring report, okay, then emission reduction data, all these things, calculations, these are prepared, which we upload it into the registry, concerned registry. So then it is open for verification. Then a verification body is engaged who comes and does the verification and validation. And on successful verification and validation, the registry issues the carbon credit. So these are the steps which I spoke about. First, it could be a site visit, followed by understanding and getting the complete project details, completing the entire documentation with respect to project PCN, that is project concept note, monitoring report, and all the calculation sheets, which gives the details of all the emission reductions that has been carried out, and uploading the same into the registry. getting the verification and validation done by the verification agencies, and they will, after the audit, prepare the verification report and the statement and upload it into the registry. And finally, the registry issues the carbon credit or water credit. So this is pretty simple steps to avail the carbon credits. Now we spoke about registries. There are many registries, more than 40 registries are there across the world. Some of the prominent ones I can talk about, that is VERA, which is from United States. We have something called Gold Standard, which is from Switzerland. We have ACR, that is American Carbon Registry, which is again from United States. And Global GCC, that is Global Carbon Council from UAE. And of course, two from India, that is UCR and UWR. These are the registries that we are supporting. UCR is Universal Carbon Registry and UWR is the Universal Water Registry. They are, of course, all the registries are good, but this is very, can say, aggressive, and a lot of projects has been completed on this registry. In fact, we ourselves have done, I think, more than 10 sugar industries itself, apart from other industries, to get carbon credits and water credits. Speaking of Pune, we have done for Serum Institute also. Serum Institute, we have done 3 carbon projects for credits and 3 water projects also. Quickly, we'll just touch upon the case studies. I have taken only three this thing. All 3 are from sugar industries. One that we have done in Ghaziabad, which is in Uttar Pradesh. From 2013 till 2022, they have earned around 7.8 lakhs of carbon credit. I won't go much into the technical part of it, just to save time. Also, we have done one more, that is at Katauli, which is again in Uttar Pradesh. From 2013 till 2022, they have earned around 8.6 lakh carbon credits. Again, a sugar industry. And another sugar industry which is in Punjab, from 2014 till 2021, they have earned around 5.8 lakhs. So you can see that there is a lot of, this is only with respect to the bagasse field. Now there are so many other projects also a similar industry has done, which also can get you carbon credits. Okay. And if you look at the, of course, I'm not supposed to speak on the financial part of that, costing, but we all know that the cost ranges somewhere between $1 to $4 per carbon credit. So I have seen some of our clients getting $2 also. So when you talk about 8.6 lakhs, it is close to, around 15 crores, okay, like that. So it's a good income that you can think about. However, there are some challenges. Well, challenges are nothing but it could invoke some investment, because if you want to, have a project specifically designed for that, there will be some initial investment that you may have to. But again, if you look at the returns ROI, I'm sure you will understand that in a few years, you will definitely cover up much more than that. Of course, ensuring systems, putting systems in place for measuring, reporting, and verifying reductions, ensuring there is verification being done. This all can be sometimes complex and time consuming, but yes, by engaging a good consultant like us, you can, of course, make it as less complex and pretty fast. I can assure you that. Like I said, yes, the rates are very, very, very volatile. Sometimes, right now the rates have come down a bit. So that could be a problem for you to, kind of take any factual based decisions on that. So that can be a challenge. But at the same time, if you look at even the lowest, let's say $1 is also pretty good enough. And lastly, talking about the potential benefits, we already have realized that availing both carbon and water credits can offer numerous advantages to the sugar and allied industry, for that matter, any industries, of course. The most important is the financial incentives. Okay, like carbon and water credits can help businesses earn more money by providing additional revenue streams and potentially increasing profits. So that is one thing, one very big reason that you should look into this. Access to new markets. definitely by reducing your environmental impact, businesses can attract environmentally conscious consumers. These days, consumers are getting more and more environmentally conscious. So the doors are open for you now. And industries who prefer to engage with eco-friendly businesses. So that is another good reason. Improved sustainability, because sustainability, again, like I said, everyone has to demonstrate their role towards sustainability. Implementing sustainable practices to reduce emissions and water consumptions can help business align with your sustainable development goals, SDGs, that we talk about. So this is a path towards achieving your goals, sustainable development goals, and also, of course, meeting your regulatory requirements besides that. Brand reputation, enhanced brand reputation. Participating in this carbon and water credit programs can demonstrate a business commitment to environmental responsibility, which can finally, in turn, increase your brand reputation, because yes, you are an environment conscious company. So that gives a very big positive image. And of course, environmental protection. Carbon and water credits can help businesses protect the environment by reducing their carbon footprint and also water footprint, that is conserving water resources. So these are the potential benefits that we see as of now. Definitely, I'm sure financial incentives is something that can excite anybody more. So please look into it, try to identify there, because there are so many things which is already happening. That's what is, hurtful. People don't know that, how much you can get for this, that these all projects qualify for such carbon credits. So please look into it, reach out to us, reach out to our associates, and understand how all you can, avail these credits. Rest assured that we'll ensure that the process becomes as simple as possible and we get you the credits at the earliest. Well, with that, that's my time. Thank you very much.
Thank you, Mr. Nair, for a very informative presentation that with carbon and water credit, you can improve your economy of the industry, at the same time ensuring eco-friendly procedures and sustainability, a step beyond compliance. That's very important. And it is also highlighted in the presentation that what are the ways where we can use the carbon credit and water credit both. And that is what is required in the sugar industry presently. And they are already doing it in many cases. So they have to see that how they utilize the work they are doing to get water access now, carbon credit now, and the financial incentive. So it's a really very good beginning, and with the government scheme on the green credit program coming up, so which will also open a new vista for taking credits in both in terms of green rating and the carbon credit. So now I'll request Dr. Vaki Singh to take the floor and present on the financial damage.
Yes, Dr. Yashpal Singh is next, and he is a water and air pollution control technologies, climate change and clean development, the whole gamut of waste management, pollution control, and of course damage assessment. So I'm sure he will deliver a very interesting presentation.
Thank you so much, ma'am. इसे जाएगा? Yes. इसे जाएगा? Okay. Thank you, ma'am. It's an honor to be here with you. All that madam has said is not my specialization. These are areas where I have worked for some time, that is all. And after two beautiful pieces of presentations, I don't think if these match the tenor of those, because this is slightly different, and we are wanting to talk to you about regulation now. In this session on sustainability, I felt that technology is very important. Technology is very important, but compliance and governance are, I think, a little more important than technology. Because, and I, all of us know it. Yesterday only we went for dinner. We know what is lacking. We see our rivers, we see them polluted, we know what is lacking. It is not that you do not have technology to achieve these standards. It is that you lack the will to achieve those standards. That is where I would like to do it. We have people, we have friends from industry, and we've got students also. The purpose today is to sensitize you on the environmental compensation and penalty regime, so that you can understand it better, and so that when it comes on you, you can at least analyze. I will try to give you both. I will try to give you the responsibilities, and I will give you, I'd like to give you the rights also, how what you should look into. So sure. Okay. Now, gentlemen, India has a very robust regulatory mechanism in place. But what, as I told you, what we lack is governance. And the developer's response is very important. What happens is, you get a piece of paper, you get a consent from the State Pollution Control Board, you get an environmental clearance, and when it comes to you with about 100 conditions, what you do is you tend to, your general thing is you tend to keep it in the drawer and you just leave it there. And next year, when it is about to expire, when the consent is about to expire, you call your consultant and tell him, look, my consent is going to expire, now get it renewed. So the consultant starts work on it, and this is what is bad. What is required is that the moment you get your consent or your EC, I have been suggesting people, you divide those consent conditions into groups. And for example, you have 5 managers or 10 managers, apart from the environmental managers. Whoever, you have 10 managers, give each 10 conditions, that these are 10 conditions that you have to take care of during the next year. And let them do it. So earlier, when I joined the Pollution Control Board in somewhere around 1979, at that moment of time, sir, the pollution costs were an externality. Whenever we were wanting to appraise an industrial project for financing, the cost benefit analysis was done basically on the capital cost and the operating cost of plant, building and machinery. Environment and pollution control machinery was nowhere included, sir. And it was the name, Mr. Kamotra also joined the board by that time, I think. So in those initial days, when we used to ask people, ki bhai, I cannot grant you consent because you do not have a effluent treatment plant, they would say, sir, give us some time. They did not know of the responsibility that they have to provide for an effluent treatment plant. So then we introduced what you call the concept of NOC, that was an administrative order. Then that NOC served to tell you what you have to do for environment, and then we linked those NOCs to the licensing mechanism. We told our organization in pickup or the financing organization that whenever you are appraising a project or whenever you are granting a license, a loan, kindly examine whether they have a consent, the NOC or not. It is only in 1988 that this NOC was formalized into what you have today, the consent to establish and to consent to. So environmental management costs were not considered. And apart from the regulatory mechanisms, there were many mechanisms which were being used world over. One was this scheme in Indonesia called Proper. What they did was they did not have a very huge administrative machinery. So what they did, they asked all the offices to come together and they went to the industry, and based on performance, they color coded the industry. Red, orange, green, red, black, like this. The worst performers were black, and there was no impact. Then suddenly one officer said, look here, we are going to make this list public. The moment they said that we are going to make this list public, there was a 50% added compliance. So this is one instrument. Then we, in my state of Uttar Pradesh, we performed an environmental performance rating for distillery sector. We involved almost about 40 distilleries, and we found that if the benchmark was not the standard set by the Pollution Control Board, the benchmark was the best achievable that you could do, and we found that those industries which were good achievers. Now, if the bad achievers tried to achieve only up to the level of the good achievers, the sector could improve by about 200 crores of wealth they could generate. You don't have to do according to the standards prescribed by the regulator. You do according to what you have done, what one of your brethren has done, what one of the other industries has done. Just try to emulate. All in terms of resource management, the water consumption, molasses consumption, power consumption. So this study, I was very fortunate. The World Bank had they made a poster out of that study. They invited me to Paris it was attended by almost 30 countries, EIA organized. I made a presentation on the entire, it is on the OECD website, this paper, on the, so, and then after 5 years again, I took up and I tried to find out what was the advantage. So most of the industries had brought down their water consumption per unit capita. So it has been a very, then we also did one exercise with the CII where we rated industries into red, orange, green, and that aided in compliance. So now coming to damage. Legislation, the Air Act, the Water Act, and the EP Act, all these acts provide that if you are damaging the environment, you are liable to compensate for the damage. They are provided. This next point that I wanted to tell you, this MC Mehta Oleum case, this is very important. He says that the measure of compensation must be correlated to the magnitude and capacity of the enterprise. आपका इतना बड़ा इंडस्ट्री है और आपने इतना सा गलती किया तो फाइन इतना ही बड़ा आपको पड़ेगा. आपका इतना बड़ा इंडस्ट्री है, इतना बड़ा फाइन कर दिया तो आपको इतना बड़ा फाइन. This is what he meant, that it should be a deterrent. To allow it to be a deterrent, the enterprise is strictly and absolutely liable to compensate all those who are affected. The measure of compensation must be correlated to the magnitude and capacity of the enterprise because it must have a deterrent effect. Then the NGT in this particular case in 593 of 2017 said that the CPCB will take penal action for failure if somebody does not set up an effluent treatment plant and he's supposed to be setting up an effluent treatment plant, then the CPCB will take penal action. And it also said, and also recover compensation for damages. Now this judgment is very important. It introduces two concepts. One is penalty for non-compliance. I have no consent. I want an effluent treatment plant. I do not have an effluent treatment. That is penalty. The second component is CPCB may also assess and recover compensation for damage to the environment. The second thing is damage. Unfortunately, today, this line is very thin. CPCB, not exactly the CPCB, all the regulators, for that matter, are imposing compensation even for the first clause. Compensation, I am going on a bicycle or I am going on a scooter, I hit a bicycle और उसका हवा निकलता है, तो what is the compensation? हवा निकलना. इफ अगर हम उसका रिम टेढ़ा कर देते हैं तो कॉम्पेंसेशन क्या है, रिम हम सीधा कर दे. बट आंख बंद करके नाउ 10 crores, 15 crores, 100 crores penalty is going without any assessment of the damage. And we have to be very careful as industry, because there is no limit to which the NGT or the boards can go in imposing penalty. Absolutely no limit. 10 crore देख लिया, कुछ कर दिया. The boards, the CPCB and the state boards are imposing penalty, right? My perception is that the CPCB and the state boards are not authorized to impose any penalty. Why? It says that fines are provided. Fines are provided in the Act, but it says that the cognizance of the offence has to be taken by a court of law. So the CPCB can go, the State Pollution Control Board can go to court, complain, tell them this is being caused and we want you to impose a penalty of 5 crores of rupees. Then the court will impose that penalty. An officer of the Pollution Control Board, without issuing you proper notice, without following the procedure, just can't say, I went to your industry on such and such date, your BOD was 35, therefore a penalty of 5 crores of rupees. You can't do that. This is what this is very important when it comes to you, as an industry, when a notice for compensation comes to you, kindly find if these things have been followed or not. There has been a very recent change. They have come up with the Jan Vishwas Act 2003. I hope you are aware of. Now, this Jan Vishwas Act has amended the Air Act in terms of penalty and compensation. Here also, penalty, they say, has to be imposed by an adjudicating officer to be created at the government level. No board. Board will not impose the penalty. The adjudicating officer will impose the penalty. And unfortunately, in this act also, it speaks only of penalty. It does not speak of compensation. This Jan Vishwas also does not speak of that. Normally, the boards are utilizing powers under Section 5. You are aware of powers under Section 5. Section 5 of the EP Act provides powers to the central government and were delegated to the Central Pollution Control Board or the Chairman State Pollution Control Board to issue directions for closure, suspension of power supply and suspension of water supply. Now, these provisions are being utilized for imposition of penalty, which of course I think there should not be. And of course it says that there is a need of a show cause notice. I've already highlighted the fact that how much? 10 minutes. 10? I've already tried to highlight that penal action is for failure in setting up and maintaining STPs, and the second compensation is to assess and recover compensation. NGT Act makes a specific provision for penalty. Under Section 26, it says if you are not complying with provisions, then you are liable to be penalized. That penalty is in fiscal terms, NGT can impose. Then under Section 15 and 17, it says compensation is for damage. Penalty is for non-compliance, compensation is for damage. This thing has to be very clear to us, because otherwise you get a environmental compensation for something which falls in the category of penalty. Then there is one very important thing that has to be noted, and that is if the river is getting polluted, if the river BOD is 500 milligram per liter or say 50 milligram per liter, then, and I have an industry, you have an industry, sir has an industry, all four of us will get a penalty of 5 crores of rupees. NGT says that if the pollution is being caused by 4 different sources or 10 different sources, then the damage has to be apportioned. आपने कितना किया, you कितना किया, हमने कितना किया, and the penalty should be concomitant to the damage that I am causing. This is not being done. Ganga is being polluted. There are 300 odd industries in Ganga basin. Everyone gets a no, चाहे वो छोटा electroplating unit हो, चाहे छोटा हो, चाहे बड़ा sugar plant हो, चाहे को, everyone gets has been imposed a penalty अभी in the Ganga के 5 crore rupees everyone. And for what? Where is this money going? And whose money? It is not my money. I am an industry. The penalty that I pay is not my money. It is the public's money, the shareholders' money. Yeah. So anyway, so this has to be noted that whenever you get a notice for a penalty or compensation, you just try to analyze whether it is fit or not. Otherwise, go. There are appeals. There are appellate authorities. You make an appeal. Tell them that I have not caused that pollution. I am only responsible for 5 milligram per liter of BOD. Then there's a in terms of environmental compensation, there's a violation committee, if you are aware of it. Environmental clearance, if you are aware of the term, environmental clearance is for a prior, it is to be taken prior to setting up a site. Now what has happened is that the ministry has come up, the ministry has come up with a notification which says that if you have not taken EC, then we will regularize that post facto. That notification now that violation notification also has both things. It has penalty and it has compensation. Penalty is 1% of the cost incurred or about 0.5% of the total turnover. Next slide में आप दिखाएंगे तो वो है. और compensation के लिए the violation committee says that you have to get an EIA done. You have to prepare a damage assessment report. Find out how much of damage has been caused because of you, not because of him. Because of you, and then you assess that, you put out the remediation costs and you submit that penalty, that compensation. Again, where and for what purpose, I don't know. The purpose actually should be that if there is a damage at that place of time because of me, then I should be asked to pay for remediating that damage there. Not that I should be asked to put it in these, they have an escrow account at the CPCB also, or the escrow account at the government level. Usme aapne dal diya, then you can not take out your money, you cannot spend it for remediation ever. And I think there may be billions and billions of rupees lying with the pollution control boards and the as penalty. I have been in the department for 40 years, so I should be excused. Now, अभी क्या हो रहा है? SEIA, the State Environmental Impact Assessment Authority, they have also started imposing penalty. Why? No one has given them any authority. They have an authority under Section 5 of the EP Act. The chairman SEIA has an authority. But that authority is just to review the compliance of the EC granted by it and then either modify or cancel that EC. They cannot, they cannot impose penalty. I go to for a violation case. And they are doing it. और सर बिल्कुल आप बताऊं कि 15 करोड़ 20 करोड़ आंख बंद करके जो साहब के मन में आया वो the CPCB the CPCB in compliance to the directions of the NGT, they have come up with the guidelines. And these are those guidelines, sir. The first three guidelines relate to non-compliance. They say if cases considered for levy of compensation, 6. One is discharge in violation of consent conditions. Second is not complying with directions. Third is intentional avoidance of data submission. Then the fourth to sixth are accidental discharges, intentional discharges, injection of. So where you are causing damage is the last three part. What the boards are doing is that they are assessing everything on this formula. This is again a CPCB formula for assessing damage. For defaults A to the first three defaults, non-compliant, they have EC is equal to PI into N into R into S into PI is the pollution index. रेड ऑरेंज ग्रीन जो कैटेगरी इंडस्ट्री बनाया है उसमें उन्होंने क्लासिफाई किया है 80 60 क्या रेड है क्या, तो दैट इज पीआई. एन इज द नंबर ऑफ डेज, आर इज एन आर्बिट्रेरी रेट, S is the size and location factor. So these 5 things they have taken, and I also don't agree with it anyway. So I'll just change the slide now. So that PI again is PI is the water pollution score. Now they say the average for red category they are taking 80. Why are you? If I am an industry which fall in the 90 category, why are you giving me 80? And if somebody falls in the 60 category, why are you giving him 80? So it should be exactly, and all the industry scores are very well specified in the red, orange, green. Most of the 300 odd industry they are specified. Then why are you charging me on the potential to pollute? See, 80. I am a red category industry. That is my potential that I am a polluting. You should charge me according to what I am discharging. If I am discharging 100 BOD and sir is discharging 200 BOD and both are distilleries, why is the same rate? He is damaging the import so. Let me change it because time is short. This you'll get, sir, yes. And the minimum compensation is 5,000 rupees a day. Then they have said that this arbitrary factor, that R is a factor in rupee. That factor in rupee is 500. Who gave you the idea of 500? Why not 250? Why not 1,000? And you are multiplying my compensation by 500 times. See, everything is into. By 500 times, you calculate something and you multiply it by 500 times. That is fast. मैं इसलिए बता रहा हूँ सर कि आपको कभी आए इस तरह का तो आप कम से कम जाइए ना. दे आर नॉट डेफ पीपल, रेगुलेटर इज ऑल अलाइव. तो आप अगर बोलोगे नहीं तो I know when I joined my pollution control board in 1979, my first member secretary told me, Yashpal, if a child does not cry, the mother does not give milk. And he told me, first day he told me, whenever you want to say something, whenever you want something, you come to me. Don't just keep sitting. क्या वो गलत कर रहा है, गलत कर रहा है, गलत कर रहा है, गलत करना क्या? अपना बोलो तो सही क्या है? Tell him what is right. Minimum compensation is 5,000 as per the CPCB guideline. Minimum compensation is 5,000 rupees per day, 2 times on first repetition, 4 times on second, and 8 times on further. मतलब 5 करोड़, 10 करोड़, 20 करोड़, 25 हमारा पैसा. For the balance 3 compensation parts जो मैंने दिखाया था, CPCB has suggested that they will have an agency which will draw up guidelines, etc. They have not commented on the damage assessment part, at least in this guideline. But in 2022, recently, they have come up with this I'm skipping this. These are the standard operating procedures for violation cases, where you have commenced 1% of the total project cost. Then if you have commenced operation without EC, that is 0.25% of the total turnover. So I'm skipping these slides. You will have this with you there. Then the CPCB has come up with these guidelines in 2022. This is for damage assessment. This is a very good set of guidelines that has come up for damage assessment. And you have they've given a they have given a methodology. I'll just skip it fast because you can get it later. How do you calculate damage? Determination of environmental damage cost. Environmental damage cost is assessment cost plus cost of remediating. Assessment cost is also cost of this thing. Damages to environment ecology plus compensation for damages to environment and ecosystems. Then you have to identify the best achievable remediation and restoration methods and the cost based on this. Then how do you calculate? They've given us systems how to calculate in terms of air pollution. You have these models operating. Then you have the disability adjusted life year assessment. Then you have your value of statistical life analysis. These are methods available where you can calculate the damage. In terms of surface water also, they may be they may be conservative substances are those substances which do not degrade in water. So for conservative substances, they've got a separate method. For degradable, they have they study the decay. What is the decay of the pollutant, and then they find out. Then they have given how to estimate cost estimation to human health damage. And you got models for them. Then how to evaluate the cost of one fatality. एक आदमी मरता है तो उसकी cost क्या होगी? Evaluation of cost of affected person क्या है? Cost of damage to fisheries क्या है? Like कितना है? Economic loss due to damage of fishery is जैसे एक नदी में if the people are not able to fish, then what is the loss due to them? For example, that river stretch was giving 10 lakhs of rupees of fishes, and if it is not giving now any return, then those 10 lakhs of rupees into the number of days that we could not fish there. That is the environmental cost. एकदम बढ़िया है. ऐसे ही cost of recreation, cost of environmental property loss, damage, groundwater, soil, and thank you. This is one book that I have, it is in press. I think it should be within 10-15 days. This is on sugarcane and sugar, where I have, it's a 700 page book almost, and it has the biology, agriculture, manufacture, regulation, environment, and pollution control all in one, with 4 sections, where we have the ecology, biology, agriculture. One section we have the regulation, all these 30 sets of all your acts, all acts are applicable on sugar, we've given there. Then for environment, we have given the and pollution control, the air pollution management, water pollution management. So maybe 15 days I'll send you a copy. Thank you so much for
Thank you very much, Dr. Singh, and for elaborating the various aspects of the law where compensation or penalty can be envisaged. I just want to add 1 or 2 more things. He says that whenever the consent comes, you put in the drawer. There is a negative aspect also to that. there are many times conditions which you are not able to meet. And since you have not seen that, when the board comes, they look towards those conditions which you have not implemented. So, and other aspect is that sometimes the condition in the next EC consent are changed. So, which supersede the earlier one. Yeah, sometimes it happens. So, in case anything happens, so you have violated the earlier consent and you have violated the present consent. So, you are liable for. Other point was that the violation committee has since been absorbed now. There is no violation committee. And the EC committees, which are looking after the subject matter, are also dwelling on the subject of violation cases also. Third point is that the formula that the December 22nd formula that what CPCB gave is a very complex one, and is not easy to understandable. Yeah, I'm openly saying it's not easy, and it needs to be made simple so that the industry or the stakeholder understand it. It should not be that only the consultant understand what is required. So it should be made simple, and that point you have to raise what Dr. Singh mentioned. Unless you raise the issue, it will not change. And that was the same thing with the earlier formula also. When it was made in a very haste, and simply there were time limitation was there, it was made. But the violators have never challenged the formula, they have challenged the amount. Yeah. So you have to, yeah, the representation has to be in a proper way, so it can be implemented. So thank you very much.
All retired officers from the pollution control board think on the same lines.
I will call upon Mr. Pankaj Tanwar for the next speech. He is Vice President Technical at Organic Recycling Systems, Waste Valorization and Resource Recovery professional. He will be talking about byproduct valorization along with various Government of India initiative policies towards sustainability. I will request Pankaj to be very brief. Pankaj is also one of our alumni, and we are very proud to see his progress. So, asking Pankaj to start. We have to start our next session also for the conclusion.
So, good afternoon, everyone. Since we are running already behind the schedule, so I'll not take much time and we'll finish as quick as possible. So, I'll be speaking on byproduct valorization aligning with various Government of India initiative policies with reference to sugar and allied industries. I have divided this presentation into basically two aspects: what we are as an organization, what we have achieved, what we are doing in terms of waste valorization when it comes to sugar industry and allied industry, and the second part into various Government of India initiative which is part of the waste valorization and giving incentives, encouragement to sugar and allied industry for such initiative, for such development of those projects. So to start with the organic recycling system, we are a 15 years old company now working in the field of waste valorization. It's a strategic initiative between team of technocrats and group of investors to promote greenfield projects. Our vision to become champions of innovation and to provide cutting-edge technological solution. Obviously, focus is on providing integrated scientific solution in line with and in confirmation with solid waste management rule and also in the concept of circular economy and decarbonization. So, in continuation, as not all the waste can be processed or treated by a single technology, each waste fraction require to be treated in the separate manner. Based on this philosophy, we as a company set up first of its large scale co-digestion based waste processing facility, which is there in Solapur, wherein we are processing 400 tons of municipal solid waste along with press mud from sugar industries. This plant is functional. We constructed this plant to start construction in this plant in 2010, completed the construction in 2 years time with our own challenges to build that plant. And since 2013 July onwards, we are continuously wheeling electricity to MSEDCL grid. Now we are converting this plant into compressed biogas along with other feedstock in the form of press mud and Napier grass as well. Over the past decades, we have worked on dozens of waste management and processing projects, which I'll be discussing in the next slide, what kind of presence we are when we started and where we are today. So our timeline started in 2008 when we incorporated this company. 2013, we have commissioned our first plant, which is in Solapur. 2014, we got the patent for the segregation as well as our advanced biomethanation system, which we call Dryad. I'll be speaking more on what is Dryad, what Dryad stand for. 2016, we have come up with our decentralized modular systems, compact containerized system in the biomethanation. In 2019, we established our EPC division and licensing service and consulting division as well. 2022, we have again gone for 2 additional patents. We have our own research and development facility and expanding. These are all footprints. We have implemented 10 plants of decentralized vertical in part of Delhi, South Delhi, North Delhi and East Delhi Municipal Corporation area. We have deployed 3 plants in the state of UP, Varanasi. We are implementing one project of 100 tons per day composting facility in Kalyan Dombivli area. I have mentioned about Solapur plant, which is 400 TPD municipal solid waste processing. We have recently secured 2 projects in consortium in Kerala, which is again based on 200 TPD municipal solid waste processing along with exploration of additional feedstock to compressed biogas. And we have one more project in Kerala, which is in the city of Munnar for 20 TPD capacity. So I'll skip these slides. I think ma'am has already spoken about what is sustainability, environmental sustainability, what is sustainable waste management. So I'll just skip on this. Coming back to the byproduct valorization, I'll be speaking only on the press mud side of it. We have enough discussion and in the terms of what is bagasse, what we can do with bagasse, what we can do other kind of byproduct. So when it comes to press mud and what we are doing into the press mud, what can be done, what are the technologies available, including the biomethanation, composting. So there are basically technologies which are biological in the system. Prominent one are biomethanation, composting for the biodegradable fraction, and there are thermal route possible as well through incineration, pyrolysis. People are doing the pelletization as well. So biomethanation scores over the other technology in terms of higher sustainable output and better quality of compost. Biomethanation has typical 2 variant, mesophilic, thermophilic, and we are into thermophilic biomethanation. We call it Dryad. Dryad stands for dry anaerobic digestion, and this is based on the principle of thermophilic biomethanation. This is the typical technological comparison when it comes to anaerobic digestion of any feedstock. So this is what I was talking about in terms of developing our first plant, which is based on the Dryad application, which is there in Solapur. The typical anaerobic digestion process about the Dryad. First critical factor is the pre-treatment. When it comes to any organic waste, that has to be treated, homogenized properly before it goes to anaerobic digestion. And then post digestion, obviously dewatering, solid for cake, liquid for again using back into the process. Benefits of the Dryad, obviously it operates on the 50 to 55 degree centigrade temperature. It has a higher organic loading rate that requires your less footprint area, less water consumption. Obviously it's a odorless operation as it operates in the entire enclosed condition. Biogas generation is typically in the higher range as compared to conventional biomethanation system. captive consumption is low as compared to conventional or thermal technologies. Digestion and composting period. Quality of compost is obviously better as we do the anaerobic digestion in the thermophilic range. This is a typical process flow for the feed preparation, how the feed is being prepared, how it is being pre-treated, followed by the digestion. Once the feed is prepared, it is taken into the digester, gas is extracted from the top of the digester, and it is stored in the intermediate balloon over here. After the gas is taken into the balloon, it has either taken into the biogas engine for the conversion to electricity to meet the captive requirement, and remaining gas can be further purified and purified into compressed biogas or bio-CNG. This is a further again post-treatment side of it. This is a typical plant sectional view, how it looks like when it comes to any biomethanation facility. Digesters, pre-treatment, balloon and all. These are typical of few of the pictures of our established system. Apart from that, as part of the waste valorization or as part of the valorization for the byproduct, we have developed various products which can be highlighted as prom, sugarcane, and all these harit coconut. These are the product which is being developed from the other feed substrate. This is phosphate rich organic manure which can be produced after the digestion. Sugarcane again with the addition of neem powder and zinc sulfate, ferrous sulfate. These are few of the product as a company which we have developed. These are few awards and recognition we have been highlighted in recognition under the waste management manual, waste to wealth book, and solid waste management book by Government of Maharashtra. Now coming back to the later part of the various policies as being highlighted by the during the first half session in the presentation. This sector for the waste valorization, especially press mud or any such compressed biogas plant, comes under the priority sector lending by the RBI now. There is a central financial assistance provided by MNRE, which is applicable to any such projects, even for the existing plant as well. Those who are generating 12,000 meter cubes of biogas, they can get up to 3 crore rupees per 12,000 meter cube of biogas, and any new projects can get up to 4 crores per 12,000 meter cube and maximum to 10 crore. These are the assured long-term pricing which is available under the SATAT. I hope you are all aware of. SATAT is sustainable alternative towards affordable transportation, which is the scheme by MOPNG, wherein they are giving the assured long-term price and the offtake mechanism through oil and gas marketing companies. So you can see the slab over here. It starts from rate 55 to 75 as per the rate in the different cities. They have defined it. They have earlier come up this policy wherein the rate was 46 rupees, but that has been revised based on the various discussion at policy level. Now the same has been facilitating by the oil and gas marketing companies through providing the LOI, wherein these oil and marketing companies are facilitating in the plant owners design, erection, construction, commissioning. They will offtake the CBG produced by those plants. They will also facilitate marketing of biomanure produced from such CBG plants for marketing the same. They have entered into the Indian Oil has entered into the MOU with the NAFED. Oil and gas companies are also entering into MOU with the state government for facilitating CBG plants. Policy guidelines has also been issued for synchronization of CBG produced by such plant under SATAT scheme. Now there is an amendment in the fertilizer control order as well, wherein the terminology FOM and LFOM has been introduced, fermented organic manure and liquid fermented organic manure, to support such kind of plant as part of the valorization for the press mud. There is a market development assistance which is provided earlier as well to the chemical fertilizer company, but this has been revised again now, and this is available to compost manufacturer as well. So manufacturer will have to register in the particular portal to get this facility. There is again a concept of blending of CBG in the CGD network. CGD is city gas distribution, wherein this methodology has been introduced so as to blend this compressed biogas in the pipeline network. There is a formula also available to determine the price as well. As of now, it is close to rate 60 rupee plus additional 2 rupee for the compression. So it becomes 62 rupees per kg as of now. There is an additional potential available for the revenue generation, which is your biogenic CO2, which we have heard about in the previous session. So this will be again a additional revenue source. There are so many discussions happening at the policy level wherein we can have some kind of offtake arrangement the way we have for the compressed biogas. So this will change the entire scenario. That's all. Thank you. I hope I must have finished. I hope I must have finished in the time. So once again, thanks to VSI. It's my entirely privilege, my pleasure to be here at this forum at VSI. Thanks to VSI organizing committee, and special thanks goes to Dipali, Dr. Dipali, for this invitation. Thank you, ma'am. Thanks.
Thank you, Mr. Pankaj, for appraising of the various policies formulated by the government departments for facilitating. Yeah.
Where is the location? Where is the location? The location is in Tujapur.
For facilitating CPG, and the 2016 rules he mentioned, that was a paradigm shift in the rules, waste management, because they talked about waste as well. Earlier it was all talked about waste, and the 2016 rules talked as waste, and the last option was the landfill site. So thanks a lot, and thanks to all the speakers, Mr. Nair, Dr. Singh, and Mr. Pankaj, for very elaborate and detailed presentations highlighting their challenges faced and the policies for governance. Thanks to everybody. Thanks to the audience for their patience. Dr. Dipali, now it's yours.
Yes, sir. Sir, before we conclude this session, I would like to request you to felicitate all these three speakers. First of all, I request my staff to give Kamyotra sir the memento, with a memento for Mr. Yashpal Singh. Dr. Yashpal Singh. Now I request Kamyotra sir to give memento to Mr. Santosh Nair. And to Mr. Pankaj sir. Now I request our head of the department, Dr. Dipali Nimbalkar madam, to give a memento to Kamyotra sir. Before giving thanks to you all, I would like to make one announcement. All of you are requested to please join us for a poster prize distribution program in the Pandal at downstairs, where posters are displayed. It is going to be start in just few minutes immediately after conclusion of this session. And now I propose vote of thanks to all present here on the dais, especially Kamyotra sir, Dr. Yashpal Singh, Mr. Santosh Nair, as well as Pankaj sir, who spent their valuable time for us. And of course, Dr. Leens madam, she has to catch a flight, so she went earlier. But I'm thankful to her, and thanks to you all for present for this session and making this session very fruitful. Thanks to you all.
Thank you. आपले स्टुडंट आहेत.